Hello everyone. In this video session, I am going to explain part 226 of Java for Tester series, that is set interface. So what is a set? Set is a predefined set is a predefined interface in Java. Predefined interface in Java, and it is a child interface of collection interface. Okay, it's a child interface of the collection interface, which belongs to which framework? Collections framework concept. Okay, so let me show you visually. As you can see here, this is the collections framework. Entire collections framework is here. It has some predefined interfaces and classes. It's a collection of predefined interfaces and classes. As you can see, there are some root interfaces like collection interface, map interface, and then some miscellaneous predefined classes and interfaces are there in this other section also. Okay, and out of all these things, if you expand this collection interface, this collection interface has some child interfaces like list interface, set interface, and queue interface. Okay, list interface, set interface, and queue interface. And set is a here, if you focus, set is the child interface of the collection interface, which belongs to which concept? Collections framework concept. Okay, collections framework concept. Set is the child interface of which interface? Collection interface. So set is a predefined interface in Java, and set is the child interface of which interface? Collection interface. That is the child interface of the collection interface in the which belongs to the collections framework. Okay, so that is actually set. So since set is a child interface of the collection interface, all the methods of this collection interface will be inherited by the set interface, right? So since set is the child interface of the collection interface, all the predefined methods of this collection interface will be inherited by the set interface because it is a child interface of the collection interface. So what are the different predefined methods of the collection interface? So these are all the predefined methods of the collection interface, guys. Okay, collection interface has this many number of predefined methods. Okay, all these predefined methods of this collection interface will be inherited by this set interface. Okay, all the predefined methods of this collection interface will be inherited by this set interface. Okay, so all these methods can be used with set interface also. So does another question will arise here, guys. Okay, does set will have its own specific methods? Does set has its own specific methods? The answer is no, guys. Okay, so set interface doesn't have its own specific methods. Instead, set interface will inherit and use all the predefined methods of the which interface? Of its parent interface, that is collection interface. Since collection interface is the parent interface of the set interface, all the predefined methods of the collection interface will be inherited by the which interface? Set interface. And set doesn't have its own specific methods. Okay. So in order to use the predefined methods, set has to inherit them from the collection interface and use. Okay. As set doesn't have its own specific methods. Fine. Now next things I would like to explain are what actually the set is. Okay. So what actually the set is? In order to understand the set properly, we have to compare the set with list. Okay. If you compare the set with list is an interface, guys, and on the other side we have the set. Set is also an interface. Okay. So if you understand the differences between this list and set, you will understand the set properly. Okay. What is the difference between this list interface and the set interface? You have to understand first. First of all, coming to the list interface has some concept known as indexing. Okay. Indexing means when you add objects to this list interface, those objects will be added according to some index. That is, first object will be added at index 0, second object will be added at index 1, third object will be added at index 2, like that, and so on. Okay, some indexing concept is there in case of list, but set doesn't have such kind of indexing. So no indexing, guys. Okay, there is no indexing. So now let's understand more about the list and set. Okay, if you compare this list and set, you will understand the set more. Okay, fine. Since this list has this indexing concept, duplicates are allowed, guys. Duplicates are allowed. Okay, you can insert duplicate objects into the list because of this indexing. That is, when you insert objects, they will be stored at particular index. Let's say you inserted some duplicate objects. Okay, more than one duplicate objects you inserted into this list. Okay, what happens here is one duplicate object will be stored at one particular index, another duplicate object will be stored at another index. That means duplicate objects can be differentiated with the help of indexes. Okay, one duplicate object may have the index value as 0, another duplicate object can have index value as 5 or 6 or something like that. Okay, they can be differentiated with the help of index. So list allows you to add duplicate objects. Same time, here insertion order is preserved. Preserved means saved. Okay, here insertion order is saved. That means the order in which you are adding the objects to this list will be saved in the same order. Okay, in the memory, the order in which you are saving this list, in the memory also, they will be saved in the same order. If you add the first object, that first object will be added at the index 0, and second object will be added at index 1. The same order in which you are inserting the objects, the same order in which they will be saved into the memory. Okay, but coming to the set, there is no indexing, guys. First of all, there is no indexing, and here duplicates are not allowed. Not allowed. Okay. So what happens here is, if you try to add some duplicates, okay, they are not allowed, guys. Okay. Duplicates objects are not allowed. You cannot add duplicates here. Okay. So in case of set, what's the difference between list and set? In case of list, duplicates objects are allowed. You can add as many number of duplicate objects as you want. But in case of set, duplicate objects are not allowed. Okay. And second thing here is insertion order is preserved. Here insertion order is not preserved. So when the insertion order is not preserved, okay, that means the order in which you are inserting the objects will not be same as the order in which they will be saved into the memory internally. Okay, here they will be saved in random order. The objects will be saved in some random order. Here the order of the saving the objects will be same as the insertion order, but here coming to the set, random order they will be saved. Okay, even though you try to add the objects in a kind of particular order, those order will not be considered by this set, guys. Okay, internally set will save this inserted objects in some random order. First object will be saved somewhere, second object will be saved in a different place, like that. Okay, there will not be any particular order in case of set. Okay, fine. So guys, now you understood the difference between list and set, so that you can understand more about the set, right? So when you have to go with set, guys, if you get a particular requirement where you have to group, okay, group some individual objects. If you want to group individual objects into an entity, into a single entity, okay, generally collections are meant for this, right? To group individual objects into single entity, that is collections. Here list is also same thing. Group individual objects into a single entity, even list is also doing the same. It groups the individual objects into a single entity. But coming to set, it will group the individual objects into a single entity by not allowing duplicates and not preserving the insertion order. Okay, if you want to group individual objects into a single entity by not allowing the duplicates and not preserving the insertion order, that is some random order, then set. Coming to a list, it's a different, right? It will also group individual objects into a single entity, but allows by allowing duplicate objects and saving the insertion order. In case of list, insertion of order is preserved and duplicates are allowed. But the concept is same. It will group the individual objects. Here set is also meant for grouping the individual objects. But here duplicates are not allowed and insertion order is not preserved. That is random order will be there. Okay. So if your requirement is to not allow the duplicate objects and to store the objects in a random order, then you have to go with set over the list. Okay. If your requirement is such kind of requirement, you have to go with set over list. Okay. So guys, that is one thing that will help you in understanding set in a more better way. Okay, which has no indexing, duplicates are not allowed, and insertion order is not preserved. So set has its own child classes and interfaces. Okay, the set interface has its own child classes and interfaces. So let me take new. Set is an interface, right? Set is a predefined interface, and which is the child interface of the collection interface. Set is the child interface of the which interface? Collection interface. Okay, set is the child interface of the collection interface, and the set interface has some predefined child classes and interfaces. Okay, set interface has some child class known as HashSet. There's something known as HashSet, which is a class case. Okay, HashSet is a class, is a child class of the set interface, and this particular HashSet has another child class. Okay, another child class, that is LinkedHashSet. Coming to other side of this set, okay, apart from this predefined child classes, that is HashSet and LinkedHashSet, this set also has another child interface known as SortedSet. This is an interface, guys. Okay, it's not a class. SortedSet is a child interface of the set interface, and this SortedSet has another child interface known as NavigableSet. This is an interface again. Okay, child interface. NavigableSet is a child interface of the SortedSet interface, which is a child interface of the set interface. And this NavigableSet has a child class known as TreeSet. 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 Child class. Okay. So this is hierarchy, guys. This is hierarchy. Set interface as a parent interface as a collection interface. Set interface has a child class as HashSet, and it has child class known as LinkedHashSet. Other side, the set interface has a child interface as SortedSet, and it has child interface known as NavigableSet. It has some child class known as TreeSet. So there are three. How many child classes are there for this set? 1, 2, and 3. Right? There are 3 child classes for this set. At the same time, how many child interfaces are there for this set? There are 2. This is 1 and this is second. 2 child interfaces for this set and 3 child classes for this set. And it also has a parent interface known as collection interface. Okay, this is the hierarchy of the set, guys. As we already know, as we already know, as we already know, we cannot create objects for an interface, guys. Can we create objects for the interface? Here set is an interface. Here set is an interface. So can we create objects for set interface? Can we create objects for set interface? The answer is no, guys. We cannot create objects for the set interface. It's not only for the set interface. In Java, any interface you take, okay, any interface you take, objects are not allowed. Okay, you cannot create objects for the set interface. When you try to do so, you will get some compiler errors, right? If I say set s is equal to new set, if I try to create an object for the set interface, okay, I can import this set from the java.util package. Set interface can be imported from the java.util package, but you can see the compiler error is there. You cannot instantiate the type set. That means you cannot create objects for the set interface. Okay, interfaces cannot be created. The objects for the interfaces cannot be created. So what's the way then? So what we have to do in that case? If you are not able to create objects for the set interface, so how you are going to use the set interface? What we are going to do is, we are going to create an object for one of the child classes of the set interface and assign it to the variable of the set interface. So let's choose one of the child class of the set interface. Here, let's say HashSet is one of the child class of the set interface. So here what we'll do is, we'll create an object for the HashSet, okay, which is a child class of, this HashSet is a child class of the set interface. Import this HashSet from the java.util package. You see, I created an object for the HashSet. This particular object, I'll assign to the variable of set interface. I can assign this object of the HashSet to the variable of the set interface. Okay, this is possible, but I cannot directly create object for the set interface, guys. In order to use the set interface, I have to create an object for the one of its child classes and assign that object to the variable of the set interface. Then only I can use. Okay, then only I can use. So guys, I'm not going to take any practical demonstrations. Okay, I'm not going to take any practical demonstrations on this set interface. Okay, so So when I explain more about this HashSet, LinkedHashsets, and this TreeSet, I'll explain more. I will do more practical demonstrations, guys. Okay. For now, this will be enough for understanding the set interface. Okay. This will be enough for understanding the set interface. So this is all about the set interface, guys. In the next video, we'll go to one of the child classes of the set interface, that is HashSet class. Okay. HashSet class is one of the child classes of the set interface. As you can see in the collection framework also, if you expand this set interface, we got HashSet class as a child class of the set interface, and another grandchild class is like LinkedHashSet for the set interface. On the other side, we have SortedSet interface, NavigableSet interface, and TreeSet class, which are all the children of the set interface only, children or grandchildren of the set interface. So, the upcoming videos, I will explain one after the other predefined child classes and interfaces of the set interface. Okay. In this video, I completed the explanation about this. I have given the explanation about the set interface. In the next video, I am going to explain about this HashSet predefined class or child class of the set interface. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 227 of Java for Tester series, that is HashSet. So what is HashSet? HashSet. HashSet is a predefined class in Java. HashSet is a predefined, one of the predefined class in Java, and it is a child class of set interface, which belongs to collections framework. Okay. HashSet is a predefined class in Java, and it is a child class of which interface? Set interface, which belongs to collections framework. Let me show you visually. Okay, here we have the collections framework, which has collection, map, and other miscellaneous classes and interfaces. When you expand this collection, you got some three child interfaces. One is list, set, and queue. Okay. When you expand set interface, out of these three different interfaces, if you expand the set interface, then you will find out this HashSet class. Okay. HashSet is a child class of the which interface? Set interface, which is a child of the collection interface, which belongs to the collections framework. HashSet is a child class of set interface, which is a child interface of the collection interface, which belongs to the collections framework. So, since HashSet is a child class of the set interface, since HashSet is a child class of the set interface, will HashSet import or will HashSet inherit any methods from this set interface? As I already explained in the previous video, set interface doesn't have its own specific methods. Okay, set interface doesn't have its own specific methods. So, but here HashSet is a child class of the set interface which doesn't have any methods. That means nothing will be inherited, right? No method will be inherited from the set interface. Okay, no method will be inherited from the set interface. At the same time, HashSet is a grandchild of this collection interface, and collection interface has predefined methods. Okay. Though set interface doesn't have any its own specific methods, but collection interface has its own specific methods, guys. So there are several methods, as you can see on the screen, which are the predefined methods of this collection interface. And this HashSet is a grandchild class of this collection interface. That means HashSet inherits all the predefined methods of the collection interface because it's the grandparent of this HashSet. Okay. So what are the different methods we have here? For adding an object, we have some method. For removing, we have some method. For clearing, iterator is there. Okay, contains is there. Is empty, size. A lot of methods are there. So all these methods we can use with the HashSet class. Okay, because HashSet is the grandchild of the collection interface, parent interface or grandparent interface. So all the predefined methods of the collection interface can be used by this HashSet, which is the grandchild of this collection interface. Okay. This is one thing you have to know, guys. Okay. So there is no method inherited from the set interface, but all the methods which are inherited by the HashSet are from the which interface? Collection interface. Okay. And there are no specific methods. Even HashSet doesn't have even HashSet class doesn't have its own specific methods. There are no specific separate methods which are created only for the HashSet. There is no such kind of methods. Even in set interface, which is the parent interface of the HashSet, and even in the HashSet class, there are no specific methods belonging to this set or HashSet interface, set interface and HashSet class. Okay, all the methods which will be used by this HashSet will be imported from which interface? Collection interface. Collection interface is the grandparent of this HashSet. All the methods which will be used by this HashSet will be inherited from this collection interface. Okay, these are all the methods that we are going to use with the HashSet class. Fine. Now, guys, now we need to understand more things about this HashSet. Okay, HashSet is a child class of set interface. So whatever the things that are there for the set interface, that will be carried forward to this HashSet, right? That is, set interface doesn't allow duplicates and insertion order will not be preserved. The same thing will be there for HashSet also. Since HashSet is a child class of the set interface, okay, since HashSet is a child class of the set interface, duplicates, okay, duplicates are not allowed for set, guys. So duplicates are not allowed for the set interface. So duplicates are not allowed for the HashSet class also. Okay, and insertion order is not preserved. Okay, it's not saved. Insertion order is not preserved or saved in case of the set interface. Since HashSet is a child class of this set interface, these two rules will be applicable even for the HashSet also. HashSet will not allow the duplicates and HashSet will not store the insertion order. Okay, instead random order. In random order, the HashSet will be storing the objects. Okay, so let's move to the practical mode now, guys. Okay, let me practically demonstrate how the duplicates are not allowed and how the insertion order is not preserved in case of the HashSet in a practical way. Okay, so for that, let's start with the insertion. How to insert the objects? How to insert the objects into the HashSet? First, let's create an object for the HashSet. Guys, HashSet is a predefined class in Java, so you can create an object. Okay, HashSet h is equal to new HashSet. Okay, HashSet h is equal to new HashSet. Import this HashSet, guys. Import this HashSet predefined class from the java.util package. So once that is done, you can use this object reference h dot. Okay, HashSet will be using which methods, guys? HashSet will be using the methods which are inherited from which interface? Collection interface. Okay, collection interface methods can be used with the HashSet because they are inherited. HashSet is a child class of the collection interface. Okay, so h dot. What are the what is the method for adding the objects in case of collection interface? Add object. So same thing will be used with the HashSet also. H dot add object. Okay, h dot add object. Let's say I'm adding Arun. Okay, I'll add another object, guys. Add object of Varun. Okay, h dot add object of Tarun and h dot. I'll add some heterogeneous objects. So far I added string objects, guys. So I'll add some integer objects, say 9. Add of 9. H dot add of double objects, that is 3.52 double object, and h dot add of some boolean object, say true. Then h dot some character object, say some single character, yes. Okay, like this heterogeneous objects can be added. These are all objects, guys. These are all objects that I'm adding to the HashSet. Okay, so now the thing is, you're able to add the heterogeneous objects into the HashSet. That's fine. Now, can we add duplicate objects? Can we add duplicate objects into the HashSet? Duplicate objects are not allowed. Okay, duplicate objects are not allowed into the HashSet. So what if I still try to add h dot add? Let's try to add a duplicate object, say Arun. Okay, the same Arun object I'm trying to add into the HashSet like this. Will I get any compiler error? No, you'll not get any compiler error, guys. Okay, you see, even though I added this duplicate object Arun, here again I'm not getting any compiler error. But this object won't be inserted. Okay, this object won't be inserted, guys. How to check that? If I say system.out.println, and if I try to print h, that is a object reference of the HashSet, all the objects that are added to this HashSet will be added, right? Right? So if I run this, right click, run as Java application, you see Tarun is there, character S is there, Arun is there, only one time Arun is there, only one time, but here I added Arun twice. Arun once, Arun twice. Duplicate objects are added, but here When I run this program, it shows me that only single Arun is there. That means this is ignored, guys. Okay, simply this is ignored without giving any compiler error or something. This is ignored. And also, guys, there's one more thing happening in this case. Okay, that is, if the object is not duplicate, this add method will return over the mouse. So it's a warning. That's fine. So maybe I have to do something here. Say, let's first overcome the warning. Let's add some generic here. Say object generic. Okay. You can add heterogeneous objects if you give object here. Okay. Warnings are gone. Now once the warnings are gone, when you hover the mouse on this add method is returning which type? Boolean. Okay. Boolean. Boolean. It's returning Boolean. Either true or false it should return. Okay. So I'm adding Arun for the first time. Is it duplicate object? No. In this case, this method will return true, guys. This method will return true. Okay. So let's say if I say system.out.println directly, if I say h.add of Arun, this will return, this will print true, guys. Okay. Add method will add this object to the hash set and it will return true. Okay. But in case of this Arun, if I try to print this one, system.out.println, I'm trying to add a duplicate object here. Arun is already added here, right? But I'm trying to add the Arun again. In this case, what will happen, guys? In this case, what will happen? In this case, this object will not be added because this is a duplicate object. And at the same time, this method will return you a Boolean value, which is nothing but false. Okay. Whatever the return Boolean value that is getting written, that will be printed by this print statements. So while adding the normal object, I'll get the Boolean value printed as true by this println statement. And here it will be printed as false because I'm trying to add a duplicate object. Anyhow, the duplicate object will not be inserted into the hash set. You see, only one time it is added. Fine, let's run this. Right click, run as Java application. First true is printed, that is system.out.println h.add Arun. Okay, I'm not adding a duplicate object at this point of line, right? So since it is not a duplicate, it is added to the hash set and it has returned true. But here, when I'm trying to add a duplicate object, Arun again, okay, this object is not going to be added and it will return false. You'll get the result as false and this object will not be added. So you'll not get any compiler error or any other error, guys, okay, or runtime error or compiler error. Only thing that will happen is this method will return true or false. In case of true, it will add to the hash set. In case of false returning, it will not add the hash set. That's the only thing that is going to happen. Okay, fine. So guys, now tell whether the duplicates are allowed or not. They are not allowed. When you try to add, they will not be added. They will be ignored, and the add method will return false. Okay, that's what is going to happen when you try to add duplicate objects to the hash set. Next thing, insertion order is not preserved. So here I already run this program, right? First Arun object is inserted, then Varun, then Tarun, then 9, then 3.52, then true, then S. Is this the same order that I got the result in the output? First Tarun got printed. Here Arun, I'm expecting Arun to be there here, but here Tarun is there. Okay. Here insertion order is not preserved or saved. Okay. So everything will happen in a random way. Okay. When you try to add these objects, they will be stored in the memory of the hash set in a random order. So here Arun has been stored here in some different place. Here I inserted first, but it is stored in a third place or something like that. Okay. Then came Varun. But here Varun is at the fourth place. Then Tarun is in the first place. Here it's in third place. So there is a mismatch between the insertion order and the insertion order and the stored order. Okay. So this proves that insertion order is not preserved, guys. Okay. So how this happens then? How the hash set will store these objects in a random order. There is something known as hash algorithm, guys. Okay. Internally, HashSet uses some algorithm known as hash algorithm. Using this algorithm, these objects will be intaken by this hash algorithm and will be decided. In which order they have to be set will be decided by this hash algorithm. We don't know. It's very technical, guys, to go inside the hash algorithm now. Okay, I'm not going to go inside the hash algorithm, but you just have to understand whatever the objects that you are inserting, they will not be saved in the same insertion order. Okay, they will be passed to this hash algorithm and will be stored in a random order like this. Okay, they will be stored in a different order. They will not be same as the insertion order. Okay, so here duplicates are not allowed and insertion order is not preserved. And one more thing is there, guys. Can we insert null? Yes, guys, we can insert null. H dot add of. If I try to insert this null, I can insert without any problems. I can insert. Okay. When you say right click run as job application and run it, you see null got inserted. Okay. Null got inserted without any problem. Null got inserted. Null means nothing. Okay. If you don't want to insert any object, you can insert null. Then we already use add method for adding the objects here, right? We have used add method of the collection interface, which is inherited by this HashSet grandchild class for adding the objects into the HashSet. Then how to retrieve them? Okay, how to retrieve the values? So let me make this example bit simple now. I'll make this generic type to string type so that only string values will be allowed. Okay, apart from string, if you try to store anything, that will not be allowed, guys. Okay. Here HashSet is provided with a generic type as string. That means only string objects are allowed. Only string objects are allowed. And now, guys, as you can see here, if I say h dot add of any other object, if I give Tarun, it will be stored because Tarun is all Arun. I will give Arun here. Arun will also be stored because it is also a string object. But if I try to add something like integer object or something, I'll get a compiler error. Okay. Other than string object, if I try to provide anything here, I'm going to get a compiler error saying that you have to provide string. Instead, you provide some integer object. Okay, you cannot provide integer object here because the generic type that is specified for this HashSet is of string type. Okay, only string objects are allowed. What if you want to only store integer objects? You have to say integer, guys. Then you will get the compiler errors if you try to add the string objects. Here, instead of Varun, you have to give someone. Instead of Tarun, you have to give something like integer object like 5, okay, and 7. These are wrapper classes, guys. You can give wrapper classes like integer, or you can give something like string, okay, or you can give object if you want to store different type of objects. Okay, object will allow you to store any type of object, a string object or integer object or double object or any type of objects will be allowed by this object. Okay, this is one thing. Now, guys, that's fine. Let's keep this aside. I'll say string or object, anything is fine here. H dot add of. I'm just adding some objects here. Say Arun. Okay, H dot add of Varun. Then H dot add of Tarun. Okay. So how to retrieve the values? As you already know, HashSet doesn't follow any indexing concept. Okay, HashSet doesn't follow any indexing. It doesn't have any index. There is no index concept. Like array list follows the index. Okay, the first object will be stored into the index 0, second object into the index 1, third object into the index 2. But coming to the HashSet, there is no indexing concept. Okay, all these objects will be stored randomly using the hash algorithm of this HashSet, right? And the insertion order is also not preserved. Right click run as Java application. As you can see, first Arun Varun Tarun is there. Here Tarun Arun Varun has come. Okay, so that is going to happen. But still, how to retrieve? Is there any method to retrieve? There is no method, guys, because HashSet is inheriting. HashSet is a child class of the set interface, which doesn't have any predefined methods, and HashSet is also is a grandchild of this collection interface. So it inherits the child it inherits all the predefined classes methods of this collection interface. All the predefined methods of the collection interface are part of the can be used by the HashSet because HashSet is the grandchild of the collection interface. Is there any method here to retrieve the values? Add is for adding, remove is for removing, clear is for clearing, iterator is for iterating through. Okay, contain size. There is no such method, guys. In collection interface also there is no method for retrieving these values. Then how to do that? There are few ways, guys. Okay, the ways is like we cannot use for loop. Normal for loop we cannot use. There is no indexing concept. Int I is equal to 0, I less than some index. That's not possible. So only way is to go for the for each loop. For what's the for each and everything is in here. Let's try, guys. Object I'm just guessing. Object can take anything. Object temp colon have to give this HashSet. I'm trying the for each loop. Okay, this is accepted. and system.out.println temp. Have to print this object one by one. Okay. You already know about how to use a for each loop, right? So we have to this for each loop will have this hash set. Okay, this hash set will have all this value, all these objects. This hash set will assign one by one object to this which are there in this hash set into this temp. Okay, in every iteration, one by one value will be assigned to this object, and that object will be printed. Okay, so you already know about for each loop, so I'm not going to explain for each loop again. Okay, just understand this usage of this for each loop with the hash set like this. Okay, right click, run as job application. You see, first Tarun got printed, then Arun got printed, and Varun got printed. Okay, so this is the only way. Or you can use another way, guys. That is, there's a method in the collection interface known as iterator method. Iterator method is a predefined method of the collection interface. Okay, so iterator method is a predefined method of which interface? Collection interface. And this HashSet is a child class which is inheriting, which is the child class of the collection interface. HashSet is a grandchild class of the collection interface. That means this iterator method can also be used by its grandchild, that is HashSet. So when the iterator method is used, this iterator method will return iterator interface will be returned. Okay, an object of the iterator interface will be returned. Using the object reference of this iterator interface has its own methods like has next and next. These are the two methods that we generally use with the. These two methods belong to the iterator interface and we generally use, guys. Okay, using this has next and next predefined methods of this iterator interface will iterate through this HashSet. Okay, let me show you how this will be done. First of all, iterator is the predefined method of the collection interface, and this method can be used with the HashSet, right? So let's use that iterator method with the HashSet. So h dot iterator. I'm able to use the iterator method with the HashSet. This is the first thing that you need to do. And as I mentioned, what this iterator method will return? It will return iterator interface. So let's say if I say itr is equal to, okay, over the mouse, the return type of this iterator method is iterator interface. Okay, over the mouse and say create local variable. Iterator interface has been written. It is of string type because HashSet is also string type. Okay, so fine. Now we got the object reference of this iterator interface. So this using this object reference of this iterator interface, we can access the predefined methods of the iterator interface. What are the different predefined methods of the iterator interface? As next and next. So we can use some while loop. While itr dot first method has next I will use. Okay, dot has next. Itr dot has next. If it has next, then system dot out dot println itr dot next. Sorry, I have to type next here. Dot next. Okay, next. So second method. So how this while loop is going to work? Let me explain. So here in this, let's say this is HashSet. Let's say this is HashSet, and in this HashSet there are three objects stored. One is Arun, right? One is Arun, randomly stored. Other one is Varun, and other one is Tarun. Okay. So first, what will happen is itr dot has next. This itr object reference will be somewhere here. Okay, somewhere pointed to here. I cannot explain this perfectly, but just understand at a high level, guys. So itr is referring to this HashSet, but not referring to any object. Now, when you say itr dot has next, there are how many elements? How many objects are there in this HashSet? 3 objects. So this has next will return true because there are some objects inside the HashSet. So this has next will return true. When has next return true, we'll go inside the while loop, and then itr dot next will happen. So itr dot next, this cursor should point to this object or this object or this object. We don't know. Okay, HashSet has internally has some hash algorithm. Okay, HashSet which uses the internally uses the hash algorithm will pick one of this one in a random way. Let's say Tarun is picked first. So this cursor will go to Tarun first. Okay, Tarun will be referred first. So Tarun will be printed. Okay, Tarun will be printed. Then once the Tarun got printed, again it will come to the itr dot hash next. After Tarun is done, right? Tarun has been printed here. So Tarun is done. Now itr dot has next. How many other objects are there? 2 objects are there. Okay, so this will again return true. We'll go inside the while loop. Then itr dot next. Now using the hash algorithm, HashSet will pick a random object. Let's say it's gonna pick Arun this time. Okay, so this cursor will move to the next picked object by the hash algorithm of the HashSet, that is Arun. Okay, so now Arun will be printed. After that, after Tarun and Arun, so Arun is also done, right? Arun is also done here. What's left? Only one object left. Since there is an object left, hash next will return true because there are objects left in this hash set. And itr dot next. Only remaining object is Varun. So this cursor will move to the cursor referring to this itr will move to the Varun. Okay, and here Varun will be printed. And since Varun is also done, Varun will be striked off. Let's say, okay, visually. Now again, control will go to the hash next. Are there any other objects left? No. So it will return false and will come out of this while loop. Okay, this is how we can use iterator method. Okay, of the collection interface with this hash set for retrieving all these values one by one. Okay, other than for each loop, we can use iterator method and hash next and next methods of this iterator interface to retrieve all these objects of this hash set one by one. Okay, so let's run this and see whether this is working or not. Right click run as Java application. As you can see, first Arun, then Arun, Varun. Okay, we have retrieved this all these objects of this hash set with the help of this while loop. Okay, which uses this iterator method and iterator interface and its predefined methods like hash next and next. Okay, fine. So this is the only way, guys. Okay, using either for each loop or iterator methods, we have to retrieve the objects. We have to retrieve the objects. So, and along with this, along with all these things, HashSet has also has a child class. Okay, so if you go to the collection framework back, under set interface, we have this HashSet, and this HashSet has a child class known as LinkedHashSet. Okay, this HashSet has a child class known as LinkedHashSet, which I'm going to explain in the next video, guys. Okay, I'm going to explain this LinkedHashSet in the, which is a child class of the HashSet in the next video. Fine. So apart from that, there's nothing to be explained about HashSet, guys. This is how we have to work with the HashSet. Okay, it uses the predefined methods of the collection interface to get the things done. Okay, as explained, and it doesn't allow you to allow the duplicates, and it doesn't store any insertion order, and null values or null objects can be inserted, null can be inserted, right? All these things are enough for understanding the HashSet, guys. So in the next video, as I mentioned, LinkedHashSet will be explained. LinkedHashSet is the child class of the HashSet, which I'm going to explain in the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 228 of Java for Tester series, that is LinkedHashSet. So what is LinkedHashSet? LinkedHashSet is a predefined class in Java. LinkedHashSet is a predefined class in Java, guys, and it is the child class of HashSet class, which belongs to collections framework. LinkedHashSet is a child class of the HashSet class, which belongs to the collections framework, and it is a predefined class in Java. So let me show you visually. So if you go to this collections framework, as you can see here, we have the collection interface, map interface, and other miscellaneous interfaces and classes. And if you expand this collection interface, you'll get 3 child interfaces, that is list, set, and queue. And if you expand this set interface, you'll get this HashSet, which is a child class of the set interface. And this HashSet has another child class. Okay, HashSet is a child of the set interface, and this HashSet has a child class known as LinkedHashSet. So what is LinkedHashSet, guys? LinkedHashSet is one of the predefined classes in Java, and it is a child class of the which class? HashSet class. Okay, the child class of the HashSet class, which is a child class of the set interface, which is a child class of the collection interface. So guys, as we already know in the previous videos where I explained, we already know that set interface doesn't have its own specific methods, and HashSet class also doesn't have any own methods. Okay, this both set interface or HashSet predefined class doesn't have their own methods. Similarly, LinkedHashSet also doesn't have any its own specific methods. Okay, all these three like set interface, HashSet, the predefined class, and LinkedHashSet predefined class. All these three doesn't have their own specific methods. So what these interfaces and the child interfaces and classes are doing, they are simply inheriting the predefined class of this grandparent collection interface. So collection interface has this all predefined methods. All these methods are being inherited by this set interface, HashSet class, and LinkedHashSet class. Okay, as this particular child interfaces and classes doesn't have their own specific methods, they are simply inheriting the predefined methods of the collection interface as they are the child interfaces or classes of this collection interface. Okay, fine. So that's one thing. Now what exactly is LinkedHashSet? This is all good. This is all good. LinkedHashSet is a predefined class in Java, and it is a child class of the HashSet class. And and LinkedHashSet inherits all the predefined methods of the collection interface because it is a grandchild of this collection interface. That so far so good. But still, what exactly is LinkedHashSet? In order to understand the LinkedHashSet, we need to compare two things, guys. One is HashSet, which is a parent class. Okay, HashSet is a parent class of the LinkedHashSet. On the right side, I will compare LinkedHashSet. If you understand these two things, you will understand the difference between this. If you understand the difference between this HashSet and LinkedHashSet, then you will understand this LinkedHashSet better. Okay, so HashSet and LinkedHashSet both are same, guys. Only one small difference is there. That is here insertion order is not preserved. Okay, so when you insert some objects into this HashSet, they will be stored into the memory in a random way. Here random order using some hash algorithm of this HashSet will be there. But coming to the LinkedHashSet, here insertion order is preserved. Okay, so when you have to use LinkedHashSet, when you want to group individual objects, okay, when you want to group individual objects by not allowing duplicates and not storing in the insertion order. Okay, so in this case, let me come again. Here LinkedHashSet, when you have to use LinkedHashSet, when you want to group individual objects by not allowing the duplicate objects, but you want the insertion order need to be preserved. This is a condition, guys. Okay, in this case only you have to use LinkedHashSet. So when you have to use the LinkedHashSet, when you want to group individual objects and by not allowing the duplicate objects, you don't want the duplicate objects, okay, to be inserted, and at the same time the insertion order need to be same. Okay, the insertion order need to be same or preserved. In this case, we have to go with the LinkedHashSet. Here, when you have to go with the HashSet, almost same, guys. Here also grouping. When you want to group individual objects, okay, and you don't want the duplicates not allowed, but insertion order is not preserved. Okay, here insertion order is preserved, here insertion order is not preserved. Okay, here HashSet don't allow duplicates, here LinkedHashSet also don't allow duplicates, but here insertion order is preserved, here insertion order is not preserved. That's the only difference, guys. When you come across a kind of situation where you want to store, you don't want to store the duplicate objects, but you want the insertion order to be same or insertion order to be preserved, then you will go with LinkedHashSet instead of the HashSet. That's the only difference, guys. Very small difference between the HashSet and LinkedHashSet. In LinkedHashSet, we have the insertion order as preserved, and in HashSet, we don't have the insertion order as preserved. Okay, insertion order is not preserved in case of HashSet, but here duplicates are not allowed. Here also duplicates are not allowed. Okay, fine. So let me practically show you. So how to do that? Let's create an object for the LinkedHashSet class. LinkedHashSet LH is equal to new LinkedHashSet When I try to create an object, it will ask you to import this LinkedHashSet predefined class from the java.util package. Let's do it. Once that is done, you can simply say lh.add. Okay. Here duplicates are allowed or not? Duplicate objects are allowed or not? Not allowed. Here also not allowed. In HashSet also duplicate objects are not allowed. In LinkedHashSet also duplicates are not allowed. I'm just saving Arun. Lh.add. Here I'm saying Varun. Lh.add. Here let's say Tarun. Okay. Arun, Varun, Tarun. So when I say system.out.println, okay, here duplicates are allowed or not? Duplicates are not allowed. So what will happen when I try to add duplicates? It will not give you any compiler error. Similar to HashSet, it doesn't give any compiler error, but thing is that it will be ignored. Okay, duplicate objects will be ignored. So even though I am giving a duplicate Arun object here, Arun object is already there, and in the fourth position also I am trying to give the duplicate object. Okay, when I try to run this, when I try to print this LH, you will see that duplicates will not be allowed. This duplicate object will be ignored. Okay, similar to HashSet, this will be ignored, and the insertion order will be preserved, guys. First inserted object is Arun. So when I print this here, when I print this linked HashSet, first Arun will be retrieved and printed. Then Varun will be retrieved and printed from the linked HashSet. Then Tarun. So it is not random order, guys. Okay, same insertion order. Okay, same insertion order will be there. Insertion order will be preserved. Right click, run as Java application. You see, first Arun is there, so Arun is there again. Varun is there, Varun is there. Tarun is there, Tarun is there. Okay, and duplicate object is not inserted, it's ignored. And similar way to the hash set, they will return you Boolean value that is false. If you try to do so, this particular method, which is trying to add the duplicate object, will return false. All the remaining objects which are adding the non-duplicate objects will return true, which I already explained in the hash set. The same thing will happen here, guys. So if I remove this linked and if I make this normal hash set, so let's see the difference. Okay, here before I run this program, let's see the previous output. Insertion order is preserved, guys. Arun is there, Arun is there, Varun is there, Varun is there, Tarun is there, Tarun is there, and duplicate is not allowed. But when I make it hash set, will I get the same insertion order? No, guys. Okay, you see, first Tarun came. Here Arun is there, Tarun came. Varun is there, Arun came, and Tarun is there, Varun came. Okay, insertion order is not preserved in case of hash set, but coming to the linked hash set, insertion order is preserved. That is the only difference between the remaining things. Everything is same, guys. Only the difference between the HashSet and linked HashSet is in linked HashSet, insertion order is preserved and duplicates are not allowed. In HashSet, insertion order is not preserved and duplicates are also not allowed. Okay. So guys, that's all about the linked HashSet. We are done with the linked HashSet, guys. And one more thing I forgot to explain here is like you can even add the null. Okay, it's same as a HashSet. You can insert the null objects also. That's let me demonstrate. Add null. If I add, it will be inserted. Okay, null object null will be inserted. Okay, there is no restrictions for the null. Right click, run as Java application. You see, null got inserted into the linked HashSet, which is similar to the HashSet. Only difference between the linked HashSet and HashSet is insertion order. Okay, insertion order is preserved in case of linked HashSet, which is not in case of HashSet. That's the only difference. So that's it, guys. The next video session, I'll explain another concept of the collections framework, that is sorted set interface. Okay, as you can see, set interface has this hash set and linked hash set child classes. Along with that, this set interface also has the sorted set interface as a child interface. Okay, this particular thing I'm going to explain in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 229 of Java for tester series, that is sorted set. So what is a sorted set? Sorted set. Sorted set is a predefined interface in Java. It's a predefined interface in Java, and it is a child interface of set interface. Okay, it's a child interface of which interface? Set interface, which belongs to which framework? Collections framework. Collections framework. So what is sorted set, guys? Sorted set is a predefined interface in Java, which is a child interface of which interface? Set interface, which belongs to collections framework. Let me show you this visually. As you can see here, this is a complete collections framework we have, and have this collection interface, map interface, and other miscellaneous interfaces and classes under this collection framework. When you expand this collection interface, it will give you 3 child interfaces, that is list interface, set interface, and queue interface. And when you expand this set interface, okay, when you expand the set interface, you'll get the sorted set interface. The sorted set interface is the child interface of the set interface, and the set interface is the child interface of the collection interface. So what is sorted set? Sorted set is a predefined interface in Java, and it is the child interface of which interface? Set interface, and grandchild of the collection interface. So as already explained in one of the previous videos, that set interface doesn't have its own specific methods. Okay, set interface doesn't have its own specific methods. Okay, so this child interface, which is inheriting the set interface, okay, can inherit any methods? No. The reason here is set interface doesn't have its own specific methods. When there are no specific methods for the set interface, how can the child interface, that is sorted set interface, can inherit some methods from the set interface? That's not possible. But guys, sorted set is a child interface of set interface. At the same time, sorted set is a grandchild of this collection interface. Does collection interface has any specific predefined methods? The answer is yes. Yes, collection interface has many predefined methods. Okay, all these predefined methods are inherited by the sorted set. Okay, so sorted set inherits the predefined methods of the collection interface. But coming to set interface, as there are no specific methods for the set interface, nothing will be inherited. No method will be inherited from the set interface by the sorted set. But sorted set interface inherits all the predefined methods of the collection interface. Okay, and all these methods, okay, is empty, size, contains, iterator, and all those stuff are inherited by this sorted set directly from the collection interface, but not from the set interface, which doesn't have its own specific methods. Fine. So far, so good. Another question arises here is, does sorted set, apart from this inherited methods from the collection interface, does sorted set interface has any of its own specific methods? Yes, sorted set has its own specific methods. Okay. So at the same time, sorted set inherits methods of collection interface also. Okay, there's a combination. Sorted set inherits the methods of the collection interface. At the same time, sorted set has its own specific methods. Okay, sorted set has its own specific methods. Before I show you the different specific methods of the sorted set, okay, let me explain few things more about this sorted set. Okay, let's understand sorted set in a better way. Before I go to this specific methods of this sorted set, let's understand the sorted set in a better way. Then we'll move to the methods. Okay. So in order to understand the sorted set method, in order to understand the sorted set in a better way, we have to compare 3 things. Okay. As you can see here, under the set interface, we have this HashSet class, LinkedHashSet child class, and then sorted set interface, right? If I compare this HashSet, LinkedHashSet, and sorted set, you will understand the sorted set in a better way. Okay. So let's start that. First thing is, we have HashSet. HashSet is a predefined class, and middle will keep this LinkedHashSet, another predefined class, and third thing we'll keep that as sorted set. Sorted set is an interface. Okay. The first difference between this HashSet, LinkedHashSet, and sorted set is this is an interface remaining toward the classes, right? This is a difference. First difference. From the heading itself, you got a difference. But the main thing that you need to understand the difference between this HashSet, LinkedHashSet, and sorted set is here HashSet duplicates not allowed. Okay, duplicates are not allowed for the HashSet. Are the duplicates allowed in LinkedHashSet? Same thing, guys. Duplicates not allowed here also. What about sorted set? Same thing here also. Duplicates not allowed. So there is no difference. In case of duplicates, either HashSet class or LinkedHashSet class or SortedSet interface doesn't allow the duplicates. What about the insertion order? Here, insertion order is not preserved. Okay, that means the order in which you are inserting the objects, the same order, the objects will not be stored, guys. Okay, in the insertion order, the objects will not be stored. Instead, the objects will be stored inside this hash set in the form of random order. Okay, they will be stored in some random order. But here, in case of linked hash set, there is a difference between hash set and linked hash set, that here insertion order is preserved. Okay, objects will be stored in the same order in which they are inserted. But coming to hash set, they are random order. What about sorted set? What about sorted set? Here, there is no concept of the insertion order, guys. Instead, the objects will be stored in some according to some sorting order. Okay. So according to some sorting order. What is that sorting order? We'll explore more in the coming videos. But here insertion order is not preserved. That is, objects will be stored in some random order. Here insertion order is preserved. That means objects will be stored in the same insertion order. But in case of sorted set interface, objects will be stored in some sorting order. Okay. Let's take an example of some default sorting order. What is the default sorting order, guys? In case of numbers, okay, ascending order is the default sorting order. Okay. For example, if you have the numbers like 5, 7, 1, 3, and if you want this number to be sorted in some default sorting order, they will be sorted in ascending order. That is, default sorting order in case of the numbers is ascending order. Okay. That is, first 1 will come, then the next bigger number, that is 3 will come, then 5 will come, finally 7 will come. This is the ascending order. What about alphabets? In case of alphabets, alphabetical order. For example, if you have something like Arun, Varun, Tarun, and if you have to store, if you have to sort these objects in alphabetical order, then first what will come, guys? First Arun will come, then Tarun will come, right? After A, T will come in the alphabets. Then Varun will come. This is alphabetical order. Okay, this is alphabetical order. This is ascending order. So default sorting order comprises of this ascending order for numbers and alphabetical order for this kind of text. Okay, but there are other types of sorting orders also. Okay, there are other types of sorting orders. This is if you don't specify any particular sorting order, by default there will be default sorting order, that is ascending order for numbers and alphabetical orders for this kind of text objects. Okay, so now let's get back. That is, here duplicates are not allowed in each and every case, that is hash set or linked hash set or sorted set. But coming to the insertion order, here random order, here same insertion order will be stored, whereas coming to sorted set, they will be stored in some sorting order, otherwise some default sorting order. If you specify the sorting order, they will be stored according to that sorting order, otherwise default sorting order will be followed in case of sorted set. Hope you understood. Okay, now let's find out the sorted sets interface specific methods. Earlier I mentioned, right? Sorted set is a child interface of this, grandchild interface of this collection interface. It inherits all the predefined methods of this collection interface. These are all the predefined methods of the collection interface which are inherited by this sorted set. Apart from that, sorted set has its own specific methods. What are the specific methods of the sorted set? These are all the specific methods of the sorted set. First object, okay, first method, last method, head set method, tail set method, subset method, and comparator method. These are all the different predefined methods which are specific to the sorted set. Okay, which are specific to the sorted set. So I'm not going to practically demonstrate all these methods, guys. Okay, I'll explain the reason. So can we create objects for this sorted set interface? The answer is no, guys, because sorted set is an interface. For interface, you cannot create objects. Interface, no objects. In Java, you cannot create objects for an interface. If you try to do so, you'll get compiler errors. Let's say if I try to create an object for this sorted set, which is an interface in Java, like this, I'll get compiler error because in Java, Not only the sorted set interface, guys, any interface, if you try to create an object like this, you will get a compiler error. Let's import this sorted set interface from java.util package. Still you are getting this error, guys. Okay. Still you are getting this error. That is when you hover the mouse on the sorted set, it says that, it clearly says that cannot instantiate the type sorted set. That means you cannot create objects for the interface like sorted set, which is not possible at all. Then how? Then what we are going to do is these predefined methods of the sorted set. The only way is that we have to create an object for the child class or grandchild class of the sorted set and then use this predefined methods of the sorted set. That means if you go to this collection framework, as you can see, sorted set is an interface and navigable set is a child interface of the sorted set, and this tree set is the child class, grandchild class of the sorted set. So in order to use these predefined methods of the sorted set, which are specific to the sorted set or which are inherited from the collection interface, we have to create an object for the grandchild class of the sorted set, that is TreeSet. TreeSet is a class which is inheriting or which is a child class or grandchild class of the sorted set. So we have to do something like this. New TreeSet. We have to create an object for TreeSet. Hover the mouse on TreeSet and select import TreeSet from java.util and assign this object of this TreeSet. Okay, assign the object of this TreeSet to the variable of the sorted set. This is only possible. Okay, you cannot directly create an object for the sorted set interface, guys. Instead, you can create an object for one of the child classes of the sorted set, that is TreeSet, and assign that object to the variable of the sorted set. Using this object reference, you can access all the predefined methods of the sorted set. This is the only way. Okay, fine. Next thing here is that's the reason, guys, I'm not going to practically demonstrate all the predefined methods of the sorted set here. In the upcoming videos, where I'm going to take this subject of TreeSet, where I'm going to explain about this TreeSet predefined class of collections framework. There I'm going to explain or practically demonstrate all these predefined methods of the sorted set. Till then, let's keep it normal. Okay, fine. Next thing here is, apart from all these things that I explained about the sorted set also has a child interface. Okay, sorted set also has a child interface. That is, sorted set has a child interface known as NavigableSet. Okay, so sorted set has a parent interface, that is set interface, grandparent interface as collection interface, child interface as NavigableSet, and grandchild class as TreeSet. This is the hierarchy, guys. Okay, so NavigableSet is the child interface of the sorted set. Anyhow, I'm going to explain about this NavigableSet in the next video. Okay, in the next video I'm going to cover this NavigableSet interface, which is the child interface of the sorted set. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 230 of Java for Tester series, that is NavigableSet. NavigableSet. NavigableSet is the predefined interface in Java, one of the predefined interfaces in Java, and it is a child interface of sorted set interface. Okay, child interface of the sorted set interface, which I have explained in the previous video. I already covered sorted set interface in the previous video, guys. Okay, and this navigable set is the child interface of the sorted set interface, which belongs to which concept? Collections framework. Okay, this interface belongs to collections framework concept. So let me show you visually, guys. As you can see, this is the entire collections framework we have, and out of all these root interfaces and classes we have here, if you expand this collection interface, it has some 3 child interfaces. Out of that, let's expand this set interface. Okay, and set has the child interface as a sorted set, and sorted set has the child interface as the navigable set. Okay, navigable set. So what is navigable set, guys? Navigable set is the child interface of the which interface? Sorted set interface. Okay, navigable set is a child interface of the sorted set interface. That's the first thing that we have to know. Okay, so this is the position of this particular interface in the collections framework. Navigable set is a child interface of the sorted set interface, which is a child of the set, and then collections framework. This is a hierarchy, guys. Next thing is, why we need this navigable set, guys? Already sorted set is there. Whatever the child class that is implementing this, whatever the child class that is inheriting or implementing this sorted set, okay, That's enough, right? A child class can inherit and implement this sorted set. That will be enough. But why the navigable set has come in between the sorted set and the tree set? Okay, there is a reason behind that, guys. Okay, let me explain. So sorted set, the main reason why we have navigable set apart from this sorted set, why we got this navigable set in between the sorted set and this in between the sorted set interface and this tree set class, for which we can create an object and utilize all the predefined methods of the sorted set. Okay, why the navigable set is there in between this tree set and the sorted set? Why tree set has two parents? Okay, parent and grandparent. Why the navigable set? There is a reason, guys. Okay, as we already know, as I already explained in the previous video of sorted set, in sorted set duplicates are not allowed. Okay, this is the first thing. Duplicates are not allowed in the sorted set. Second thing here is, whatever the objects that you insert into the sorted set, okay, there will be some sorting order. Okay, sorted set will follow some sorting order. Okay, either the sorting order is default sorting order, objects added to the sorted set will follow some default sorting order, or some customized sorting order. Okay, I didn't explain so far. I didn't explain how this default sorting order works and how this customized sorting order works, because sorted set is an interface, guys. Sorted set is an interface. I cannot create an object for the sorted set because it's an interface in Java. All the interface in Java cannot be created object with. Okay, so how to utilize the sorted set then? In order to utilize the sorted set, we have to create an object for the tree set. Okay, child class or grandchild class of this interface we have to take and then create object and then utilize this mechanism, right? Tree set actually inherits all the things of the sorted set. So if you create an object for tree set, it will actually follow the sorted set mechanism. That is, duplicates will not be allowed. Same time, some sorting order will be followed. That means the objects added to this tree set, okay, the objects added into the tree set by default will be stored in some sorting order. Default sorting order means if you insert some integer objects, okay, if you insert some integer objects into the tree set or sorted set, they will be inserted in, by default they will be inserted in ascending order. Lowest number first and then such kind of thing. Okay, greater number next. That is ascending order. What about if you insert some string objects into this sorted set or some tree set child class which is implementing the sorted set? In that case, all those objects will be inserted in alphabetical order. Okay, this is a default sorting order, guys. You don't have to do anything. Simply insert the objects into the sorted set, that is tree set, which actually implements the sorted set. Then all the integer objects will be inserted in ascending order. All the string objects will be inserted in alphabetical order. I'm going to practically demonstrate this when I explain this tree set, guys. I'm going to explain this tree set in the upcoming videos. Till then, just understand this concept just understand these things at the concept level. Okay, practically I'm going to practically demonstrate how inserting the integer objects will store these objects in the ascending order inside the tree set, and how inserting the string objects into the tree set will do the sorting order in alphabetical order and store them in the tree set. All those things I'm going to practically demonstrate with tree set because I cannot demonstrate with sorted set, which is an interface. Okay, fine. So at concept level, this is the thing. Duplicates are not allowed and sorted set will follow from some sorting order. Okay, so all those things are good, right? Sorting purpose, everything is ready. Everything is there with the sorted set. But still, why we have to go with the navigable set? Navigable set is a child interface of the sorted set. Okay, which is coming in between this sorted set and tree set, just because of one reason known as it has some specific methods for navigation purpose. Okay, these methods which are specific to the navigation purpose are there in the navigable set only. They are not there in the sorted set. Okay, here no navigation specific methods. Okay, no navigation methods are there in the sorted set. To fill this gap, the Java developers have introduced this navigable set in between the tree set and sorted set, along with the sorted set related things. Okay, which is actually lacking the navigable, which is actually lagging the navigation methods. Okay, navigation methods are not there in the sorted set. Okay, So to overcome that gap, Java developers have introduced this navigable set, which has this method specific to the navigation purpose. Okay, what are these navigable methods and how they can be used for navigation purpose? All those things I'm going to explain practically when I practically demonstrate this TreeSet, guys. Okay, till then just understand these concepts only. Okay, practically I'm going to practically mention or practically demonstrate them to you, all the navigable methods and how the sort set predefined methods works, and all those predefined methods of the sorted set and navigable set specific methods like navigation methods. All those things I'm going to practically demonstrate to you in the next video session, where I practically demonstrate the tree set. Okay, so that's fine. Now you understood the difference between the sorted set and navigable set, where navigable set has some specific methods for navigation purpose, which sorted set doesn't have. That's the reason navigable set has been introduced into this hierarchy and also in between the sorted set and tree set. Okay, sorted set doesn't have this navigation methods. Okay, navigation purpose methods are not there in the sorted set. They are only available in the navigable set. How these navigation purpose methods are different from the sorted set methods, that thing I'm going to practically demonstrate while explaining the tree set in the next video session. Till then, just understand these things at the concept level only. For now, let's go through the predefined methods of the sorted set. Okay, first, last, head set, tail set, subset, and comparator. Okay, these are all the predefined methods of the sorted set. Okay, how can I use this predefined methods? I cannot practically demonstrate this for you now because sorted set is an interface. I cannot create an object and demonstrate this. Okay, we have to wait till I explain. We have to wait till I explain this tree set, for which I can create an object and demonstrate all these inherited methods from the sorted set. Okay, because tree set is a grandchild of the sorted set. All the predefined methods of the sorted set interface can be utilized by this object reference of this tree set class. Okay, so we have to wait till tree set. Then only we will understand the sorted set interface. Coming to the navigable set, as I mentioned, has the methods which are specific to navigation purpose. Okay, these methods which are specific to this lower, higher, floor, ceiling, pole first, pole last, descending set. All these methods are specific to this navigable set, and few of these methods are specific to the navigation purpose, are can be used for navigation purpose. These navigation purpose methods are not there in the sorted set. So when I explain about this tree set, where I can create an object using that object reference, I can inherit the predefined methods of the sorted set. At the same time, I can inherit the predefined methods of this navigable set, which can be used for navigation purpose. So I can demonstrate both the predefined methods of the sorted set and navigable set. So all these things, I'm going to practically demonstrate in the tree set, guys. That is in the next video session. Okay. Till then, just have this idea of sorted set, predefined methods, navigable set, predefined methods, and the collection framework, the hierarchy of the navigable set, which is there in between the sorted set and tree set. Okay, all these things just have a high level idea about. Okay, fine. So we cannot create objects for the navigable set, and hence we cannot utilize these predefined methods directly. I cannot even practically demonstrate them for you right away. Okay, because these are all the predefined methods of the navigable set, which I cannot practically demonstrate now for you. Okay, next thing. Next thing here is, as I already mentioned, navigable. What child class of this navigable set is TreeSet. Okay, navigable set interface has a child class known as TreeSet, which is also a grandchild of the sorted set. Okay, all these three things, that is sorted set, navigable set, TreeSet, together, I'm going to practically demonstrate in the next video session as part of the TreeSet. Okay, as part of the TreeSet, which can inherit all the predefined methods of the navigable set and sorted set. All the properties of this sorted set, navigable set, everything will be followed by this tree set, guys. Okay, so we'll get a complete clarity on the sorted set, navigable set, and tree set in the next video session, where I'm going to practically demonstrate this tree set in detail. Okay, so this is all about the navigable set, guys. Hope you understood. Okay, so hope you understood these concepts. So these concepts, I'm going to make them practical in the next video session, that is tree set. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 231 of Java for Tester series, that is TreeSet. So what is TreeSet? TreeSet is a predefined class in Java, which is a child class of navigable set interface I already covered this navigable set interface in the previous video, guys. And here, TreeSet is a child class of this navigable set interface. And it is a grandchild class of sorted set interface. Even the sorted set interface also I covered as part of one of the previous videos, guys. Okay. I covered navigable set already and sorted set also. Okay. So coming to the TreeSet is a predefined class in Java, which is a child class of the navigable set interface and grandchild class of sorted set interface. Let me show you visually. So this is a complete collections framework where we have the root interfaces as collection, map, and other stuff. So if you expand this collection, you will get the child interfaces of this collection interface, that is list, set, and queue. Expand this set interface, guys, you'll get this sorted set. Under sorted set, we have this navigable set. You already know all these things because I already covered this in the previous videos. Now, when you expand this navigable set, then you will get the tree set, guys. Okay. So tree set is a child class of which interface? Navigable set interface. Tree set is a child class of the navigable set interface, and it is a grandchild class of this sorted set interface. Tree set is a grandchild class of this which interface? Sorted set interface. Okay, grandchild. So what is the advantage of this tree set class? Okay, for having this parent as navigable set interface and grandparent as sorted set interface. The only advantage that TreeSet will get is all the predefined methods of the sorted set and navigable set can be utilized by the object reference of this TreeSet. Okay, by creating an object for this TreeSet, we can utilize, okay, we can use the predefined methods of this parent navigable set interface and grandparents that is sorted set interface related predefined methods also. Okay, parents navigable set interface predefined methods and grandparent that is sorted set interface predefined methods. All these predefined methods we can utilize with the tree set. At same time, from the sorted set, this tree set will inherit some properties like sorting. Okay, there are different type of sortings, that is default sorting and customized sorting. All these sorting features will be inherited by this tree set. At same time, navigable set is intended for the navigation purpose. Okay, it has some specific methods specific to navigation related methods are there with the navigable set. Okay, all those predefined methods can be utilized by this tree set. Okay, so let's understand more about this tree set, guys. Okay, in order to understand this tree set, I have to explain about this sorted set, navigable set, and then I have to compare that with the tree set. Okay, so let's start that. Let's do that. Okay, so let's remove this part because we need more space. Here we have sorted set interface, guys. Okay, sorted set interface. In middle we have navigable set interface. Okay, and we can keep here TreeSet. TreeSet is a interface or class. It's a class, which is a TreeSet is a predefined class, which is the child class of the navigable set and grandchild of this sorted set. Right. So now let's understand more by providing these lines here. So let's start with the sorted set. So coming to the sorted set interface, duplicates are allowed or not? Duplicate objects are allowed or not? Sorted set, okay, in sorted set, duplicate, okay, duplicates or duplicate objects are not allowed. Okay, duplicate objects are not allowed in the sorted set. The same thing will be the same thing. Okay, here also navigable set also same thing. Duplicate objects are not allowed. This set is also child class of the sorted set. It also has the same property, that is duplicate objects are not allowed. Let's try that. Let's check with this set and see whether the duplicate objects are getting allowed or not. Okay. So for that, let's go to this Java program. Sample Java project is there with the sample class and sample main method. Inside this main method, I'll write some logic for this tree set. Okay. I would like to show you. I can create an object for the tree set. I cannot create objects for the navigable set because navigable set is an interface. Same time, sorted set is also an interface. For interfaces, we cannot create objects in Java. So, but tree set, which is a child and grandchild of this navigable set and sorted set, can be created an object. Okay, we can create an object for the tree set. Let's try to create an object for the tree set. Tree set. I will say T is equal to new TreeSet. Okay. Hover the mouse on this TreeSet and import this TreeSet predefined class from the java.util package. After importing that, what we have to check, guys? What we have to check? We have to check whether TreeSet allows duplicate objects or not. Let's try to do that. T dot add. Okay. T dot add. Let's try some integer objects. 9. Then T dot add some 1. Then T dot add some 8. So far I didn't add any duplicate objects. If I print this, what are these objects? 9, 1, 8 are there. They will be printed. Okay. The objects added to the TreeSet will be printed. Okay. 9, 1 and 8 got printed. Fine. That's good. But what if I try to add a duplicate object here? Okay. So far there were no duplicate objects. But if I try to add a duplicate object like 9, okay, will I get a compiler error? No, you will not get any compiler error. But when I run this program, okay, this duplicate object will not be inserted into the TreeSet. Okay, you will not see the duplicate object in the TreeSet. Only these 3. Only once it will be added to the TreeSet, guys. Okay, even though it's not giving the compiler error, you will not get any compiler error, even though the object will not be inserted. You see, only the unique objects got added. 1, 8, 9. The duplicate object 9 didn't get added twice. Here only 1 9 is there. I'm expecting 2 9s. That will not be possible because the reason here is SortedSet or NavigableSet or TreeSet doesn't allow the duplicate objects. Okay, doesn't allow the duplicate objects. You will not get the compiler error. But even after inserting them, there will be no use. Okay, they will not be inserted into the TreeSet. They will be inserted only once. Unique objects will be inserted. If you try to insert the duplicate objects, they will not be inserted. That's the one thing. Okay, that's clear. Second thing we need to know here is SortedSet. Is there any insertion order? If you insert some objects, in which order? If you insert some objects, will they be inserted in the same way they got inserted? For example, if you inserted some object 1, object 2, object 3, object 4, will the same insertion order will be stored in the SortedSet? No, guys. Insertion order is not at all compatible here. Okay, it's not applicable actually. So SortedSet follows sorting order. Instead of we talking about insertion order, we have to talk about the sorting order. Okay, whatever the objects you are inserting, they will be sorted out. Okay, whatever the objects that you are inserting into the SortedSet, they will be sorted out according to some sorting order. They will be sorted. Okay, so what type of sorting will be there? By default sorting order will be there. Okay, by default sorting order will be there. That means if you are inserting some integer objects, okay, like this, let's say you have inserted some integer objects, right? 9, 1, 8. Okay, by default these objects will be sorted according to the sorting order of the SortedSet. They will be sorted, and in which order they will be sorted? Default sorting order. For integers, the default sorting order is, for integer objects, the default sorting order is ascending order. Okay, ascending order. The same thing will be followed by this TreeSet, guys. TreeSet also does the same thing. Okay, TreeSet which is the grandchild of the SortedSet, also follows the same sorting order that is followed by the SortedSet. Okay, that means by default sorting order will be there followed by this TreeSet. That means if you try to add different integer objects, let's say 9, 1, 8, 2, okay, whatever the objects you add of say 25, T dot add of 13, like this, different integer objects I added, right? Now if I print this TreeSet, in which order all these objects will be you have inserted the integer objects in this order. First 9 you have inserted, then 1, 8, 2, 25, 13. But they will be stored internally by this TreeSet in which order? Some sorting order. That is default sorting order. If you don't specify a particular sorting order, TreeSet will consider the default sorting order, which is nothing but for integer objects, the default sorting order is ascending order. The ascending order, you know, right? In mathematics, the least number, that is 1, will come first, then second, then it will store after 1 to 8 will be stored, then 9 will be stored, then 13 will be stored, then 25 will be stored. That is the ascending order. Let's see that whether we are getting an ascending order in the output or not. You see, 1, lowest number is 1. Then after that we have 2. The next big number is 2. Then next big number is 8. Then next big number is 9. Then next big number is 13. Then next big number is 25. So this is ascending order. Default sorting order of the tree set for the integer objects is which sorting order, guys? Ascending order. Okay. So that is nothing but this ascending order. This has been inserted. This feature has been inherited by the tree set from which interface? Sorted set interface. Okay. As tree set is a grandchild class of the sorted set interface, this default sorting order has been inherited. Similarly, we get a doubt where, okay, what if these are not integer objects? If you got some string objects, okay, if you insert some string objects, in which order, how this default sorting order will behave with these string objects? Simple, guys, alphabetical order. You know about the alphabetical order, right? The same thing will be followed by tree set also. Okay, tree set, which is the grandchild of the sorted set, will also follow the same alphabetical order. Let's find it out. So here, instead of these objects, I'll add some names, or even alphabets also I can add as strings. Okay, so let's give some names, guys. So I'll give some Varun here, Venkat, or you'll give some different names. Mahesh, okay, Mahesh, Chandu, Kishore, okay, Swapnesh. Here I am giving my name, that is Arun. Then T dot add of another name also I'll give, that is Tarun. Like this, okay. So here I am inserted some string objects. So in which order? You have inserted Varun first, then Mahesh, then Chandu, Kishore, Swapnesh, Arun, and Tarun. But while these are getting stored into the tree set, they will be sorted out. In which order? In the default sorting order. And default sorting order for the string objects is alphabetical order. Okay. So alphabetical order, Arun will come first, right? Then Chandu, like that. Okay. Let's see which order they will be printed. You see, Arun, Chandu, then Kishore came, then Mahesh, Swapnesh, Tarun, and Varun. Okay, this is the alphabetical order. A comes first in alphabets, coming compared to the C, like that. Okay, so this is the default sorting order. And apart from this default sorting order, we have customized sorting order. Okay, customized sorting order. So if you don't specify anything inside this tree set constructor, okay, if you don't specify anything inside this tree set constructor, that will be considered as a empty constructor. Empty tree set constructor means default sorting order. Okay, empty constructor means default sorting order. For customized sorting order, we have to provide something inside this constructor. That thing I will not explain now, guys. Okay, I'll explain it later. So we also have this customized sorting order. If you don't want the default sorting order, then we'll go for the customized sorting order. For example, if you want this integer objects inserted into the this tree set to be in descending order, can you do with the default sorting order? No, it's not possible. You have to go for customized sorting order. Same time, if you want to have this string objects, okay, not in a reverse alphabetical order, okay, will that be possible with this default sorting order? No, it's not possible. So we have to go for the customized sorting order. Okay, so how to implement this customized sorting order with this preset, I'll be explaining in the end of the session. Okay, at the end of the session I'll do that. Okay, so for now let's understand this preset more. Okay, now you got something like duplicate objects are not allowed, sorting order is there in sorted set. Same time preset also duplicate objects are not allowed, but the same sorting set which is there in the sorted set interface is also with the preset. You understood to that point. Okay, but coming to the navigable set, navigable set interface has something that sorted set doesn't have. That is, it has navigation related methods. Okay, there are some methods. There are some methods specific to this navigable set. Okay, which are whose purpose is for navigation related methods. Okay, they will help you in navigating. Okay, navigating through the objects that are inserted into this tree set. Okay, for navigating through the objects which are inserted into the tree set, we need some methods. So that methods are only there with the navigable set interface and they are not there with the sorted set interface. Okay, this navigation related methods which are specific to the navigable set are there in the navigable set interface only. Okay, as tree set is also child class of this navigable set, all these predefined methods of this navigable set can be utilized for navigation purpose by this tree set. Okay, that thing also, how to navigate and all those things I will explain later in a practical way. Fine. For now you understood the tree set at a high level. Okay, in comparison with the sorted set, navigable set, tree set is something like this. Uh, Along with this, duplicate objects are not allowed and sorting order and all the stuff. Tree set also has some other things to understand. Next thing that you need to understand about tree set is heterogeneous objects are not allowed. Okay, heterogeneous objects are not allowed. Why they are not allowed? You cannot sort them. What is the main purpose of tree set, guys? If you insert some objects into the tree set, they will be sorted. The output they will be sorted. You see, here Arun came first. In alphabetical order, they got sorted. But if you have heterogeneous objects, string object, numerical object, and double object, Boolean object, if you have such kind of heterogeneous objects, can we sort them? Is it possible to sort? That's the reason, guys. Tree set doesn't allow you to insert heterogeneous objects. If you try to do so, what will happen? You will get a compiler error. Okay. So let's say instead of the string object, if I add some 9, you will not get compiler error, guys. Sorry, you will get runtime error. Okay, 3.52. And if I give some boolean value true here, okay, let's see what will happen now. Let's run this. TreeSet will not be able to sort this heterogeneous objects, guys. That's the reason it will give you a runtime error. Okay, you see, runtime exception case, that is class cast exception. Okay, so you cannot have heterogeneous objects. If you try to add the heterogeneous objects into the tree set, because heterogeneous objects cannot be sorted. With the help of the tree set, we cannot sort the heterogeneous objects. That's why in the runtime you'll get this kind of exception. Okay, in the runtime you'll get the exception. That's the problem. So you should not be adding these heterogeneous objects into the tree set. Either you have to add the integer objects like this. All objects should be integer objects, or all objects should be string objects. Okay, all objects should be string objects. Okay, so another thing you need to understand, that is all the objects that you insert here. For example, if you are inserting all the objects as some string objects, okay, let's move back. If you are inserting all the string objects, okay, so this string object, let's go to the string object. Let's search for in the API, Java 8 API, let's go for the string object. That is string class. Okay, it's not string object, string class. Let's find the string class in the API documentation of the Java 8. Control F and search for string. Simply search for the string class. Okay, so if you observe, string is a predefined class in Java and it has some implemented interfaces. One of the interface that string class is implementing, string implements interface, that kind of thing. Okay, that is comparable. As you can see, there is a comparable. String class is implementing the interface known as comparable. Okay, similarly, let's go to another one, that is if you instead of string objects, if you give some integer values like this, okay, 9 1 7 3 25 13, okay, 8, will this be sorted, guys? Will this give any error? Any compiler error will come with this? No, integer objects are allowed. What is the reason for allowing these integer objects? The reason here is, again, if you go to this API documentation and search for integer, you have to find the integer class. Predefined integer is a wrapper class and is a predefined class in Java. And this one also has a comparable. String class also has a comparable interface. String class is also implementing the comparable interface, and integer object is also implementing the comparable interface. But if I try to search for something known as string buffer, Okay, if I search for string buffer, is it implementing the comparable? No, string buffer is not implementing the comparable. So guys, the thing that that I wanted to explain here is, so whatever the objects that you want to give here, okay, whatever the objects that you want to insert here, that may be integer objects or string objects, but you cannot insert string buffer here. Okay, you should not be inserting the string buffer here. If you try to insert the string buffer objects like this, it will not work, because string buffer class in the Java documentation is not implementing the comparable interface. Okay, all the classes which are implementing the comparable interface, those are only allowed here for sorting purpose. Okay, other things like string buffer etc will not be sorted, guys. Okay, string buffer, Varun, let's give these three things and see whether this thing is working or not. You will get a compiler error, runtime error, guys. Okay, you see, cannot cast to comparable. So since string buffer class is by default not implementing the comparable interface, that's why we are getting a compiler error here. In place of this, if you give integer objects, it will work, because integer wrapper class is Java API. Okay, Java API is implementing which interface? Comparable interface. So that is one another rule, guys. Okay, comparable interface should be implemented by the classes of these objects that you are inserting here. Since integer class in Java is implementing the comparable interface, those are comparable here. You see, it will work. And if you give the string objects or string also, same thing. It's implementing the comparable interface. Okay, it will also work. String objects will also work, because string class is implementing the comparable interface in Java. Okay, so this is another rule, guys. Okay, this is another rule you have to keep in mind as part of TreeSet. Okay, it's working. So like that. Fine. Next thing, null insertion is not allowed. Okay, if you try to insert null, for example, you have added three string objects. Now if you try to add some null here, okay, wherever if you try to add null here, you will get a null pointer exception. Earlier it was working. Now if I run this after adding null, you will get a null pointer exception. You cannot add null into the tree set. Okay, null cannot be added into the tree set, guys. That is another thing that you have to remember as per the tree set. So these are all the things. These are all the rules and regulations of the tree set, guys. Okay, duplicates are not allowed. If you try to add the duplicates, compiler error will not come, but they will not be really inserted into the tree set. Okay. Second thing is, all the objects that are inserted into the tree set will be sorted. Okay, according to the, by default they will be sorted according to the default sorting order. For integers, ascending order will be the default sorting order. For all string objects, that will be the alphabetical order will be the default sorting order. Customized sorting order I'll explain soon. Okay, in the same video itself I am going to explain the customized sorting order. Okay, it will take some time. Fine. Heterogeneous objects are not allowed. If you try to add some heterogeneous objects for this particular tree set, the sorting will not be possible. That's why heterogeneous objects cannot be added. Okay, if you try to add them, tree set will accept. But when you run the heterogeneous objects using the tree set, in the runtime you will get an exception. Okay, and next thing is, all the objects that you are inserting into the tree set, okay, their classes should implement comparable interface. For example, string buffer, which is in Java, is not implementing the comparable interface. If you try to add this string buffer objects into the tree set, you'll get the runtime exception. Okay, when you run the program, you'll get the runtime exception. Fine. Finally, null insertion is not allowed. Okay, so if you try to add null anywhere in the tree set, you'll get null pointer exception. So these are the few things that you have to know about the tree set, guys. Okay. Next thing here is, already explained about the default sorting order. Okay. For default sorting order, empty tree set is required. The constructor of the tree set should be empty. Okay. For default sorting order. So if you keep this while creating the object, if you keep this tree set constructor empty, then if you insert some integer objects, they will be sorted in ascending order. If you insert some string objects, they will be sorted in alphabetical order. Okay. So that is the default sorting order which I already covered. Next thing is how this is happening then. How the TreeSet is able to sort these things. We have to know this thing, guys. Okay, we have to know how the TreeSet is internally sorting this integers into the ascending order and string objects into the alphabetical order. How these things are sorted by the TreeSet internally, that we need to understand now. Let me explain. So TreeSet internally uses a method known as compare to method. Okay, there is a method known as internally. This is not external, guys. Okay, you have to understand internal. I'm only talking. This is not visible. So when you say TreeSet T is equal to new TreeSet, and when you say default sorting order will be there. This is the default sorting order. Okay, when default sorting order is being done. Okay, when you say T dot add Arun, Varun, Tarun, and all the stuff, and when you print it. Okay, when you print this program, otherwise we'll take another one, guys. 9 integer objects. Let's take. Okay, so some 3, some 7, here 1, 25, 8, then let's take something like 13, 16, then finally let's take 5. Okay, these are the different integer objects we are adding into the tree set. While inserting, are these integer objects in any ascending order? No. But when you run this and when you print this tree set, they are being stored in the inside the tree set in the form of ascending order only, because here tree set is empty constructor here, which actually follows default sorting order. Default sorting for the integer, default sorting order for the integer objects is ascending order. When I run this, I'll get the ascending order, right? All the objects will be inserted in ascending. You see, least number has come first and the greatest number has come last. This is ascending order. Fine. But how this is happening internally? How TreeSet is able to sort these integer objects into the ascending order? Okay, internally. The answer is internally this add method. When add method is called, it will actually call this compare to method. Okay, compare to method belongs to which interface? Comparable. There is an interface known as comparable interface. Okay, I think I have listed down that particular thing in the collections framework. Let's see. Yeah, comparable interface. Okay, so there is an interface known as comparable interface, and it has a predefined method known as compare to method. Okay, TreeSet is internally calling this compare to method for sorting this integer objects. Compare to method is a predefined method of the comparable interface. Okay, so fine. That's good. So let's comment out all this part from here to here, and let's try to use the comparable. Let's try to implement this compare to method. Okay. So compare to method is internally used by the TreeSet, right? It's not visible, but let me make it visible for you. Okay. So I commented out all this program. Now I'm going to use compare to method. So if I say system.out.println, okay, 3 dot, sorry. So I have to take something here. Before this, I have to say integer a is equal to some 3. Integer b is equal to some 5. System.out.println a dot compare to b. If I write something like this, okay? If I say write something like this, what will happen? How this compare to method will work? So a, so you have to know something here, guys. Okay. So compare to has some return type called int. So this, when you print this a dot compare to, when you hover the mouse on compare to, it will return you some int. Okay, some int. That may be a positive number, negative number, or 0. Okay. This int value returned by this compare to will be either positive number, negative number, or 0. Okay. So here, when I say here a is coming before b. Okay. A is coming before b. So what will be printed, guys? So here, let's run this. Right click run as Java application. So don't have to understand what exactly will be the output, guys. So some negative value 1 is coming. Okay, negative value is coming. Okay, when a is smaller than this b, then you are getting -1. Okay, fine. When I say a dot compare to, sorry, b dot, okay, b dot compared to a, then I'll get a positive value, guys. Some positive value I'm going to get. Okay, right click, run as Java application. Okay, like this kind of technology is being used by this compared to, guys. Internally, this TreeSet is calling this compared to. If it gets negative value, it will do something. It will get some positive value, it will do something like that. Okay, if this method, when you say t dot add, it will, this value will be added, it will be compared with some other value. Okay, so that will be done with the help of, internally done with the help of compare to method. Okay, the compare to method will actually compare it. If it gets some negative value, it will do something. If it gets some positive value, it will do something. Okay, you don't have to understand the logic. Okay, so simply you are going to get the negative value, positive value, and also. And what if all these two values are same? It will return you 0 also. Okay, a dot compared to, you don't have to write again, simply remove these things. You'll get the value as 0, guys. When both are equal, when a and b are equal, and you are comparing using the compare to method of the comparable interface, okay, which is actually done by the TreeSet internally when these objects are getting inserted. Okay, so it will return 0. Okay, 0 will be returned to this add method. Okay, 0 will be returned to this add method, which is calling this compare to. So based on that my negative value or positive value or 0, the sorting is going to happen internally. Okay, this thing you have to understand, guys. This thing you need to understand. Because of internally using the compare to method of the comparable interface, the sorting is happening in the default sorting order way. Okay, so that thing only you need to understand. You don't have to dig much deeper. Okay, that's not required for us. You don't have to understand in detail, guys, how the -1 will be taken into consideration and all those stuff. Okay, so finally only we'll use something. We'll create an object for the TreeSet and insert objects, integer objects, and TreeSet will take care of the sorting order. By internally what's happening, it's calling the compare to of the comparable interface. Okay, of the comparable interface, and because of that sorting is happening. That's one of the reason, guys. That's one of the reason. If you say new string buffer, okay, new string buffer of Arun, will this work? No, string buffer is not implementing the comparable interface. So hence this compare to method cannot be called. That's why all the classes in Java which are implementing the comparable interface, for them only sorting is possible. That's why new string buffer is not allowed. Only integer objects or string objects are allowed. String class in Java and integer wrapper class in Java both actually implement the comparable interface which have this compare to method. Because of the sorting is possible. Otherwise, if you say new string buffer and all, if you try to add such kind of objects, you are going to get a runtime error, right? Runtime exception you are going to get. That's the reason, guys. Okay, that's the reason you have to understand this internal concept. Fine. Let's move ahead, guys. That is enough. Okay, that's enough. Next thing here is now so far what we did, guys, only up to default sorting order I explained, right? Now I am going to explain how to do customized sorting order with the help of TreeSet. Okay. So what are the benefits of customized sorting order? In default sorting order, only two things are there. One is ascending order for integer objects and alphabetical order for the string objects. But if I want descending order, can I use default sort order? No, it's not possible, right? I have to implement something known as customized sorting order. I have to implement. Okay, customized sorting order I have to implement with the TreeSet. For that, this constructor should not be empty. Okay, this TreeSet constructor, if it is empty, it is default sorting order. Okay, if it is not empty, then we are going to use customized sorting order. So how to use a customized sorting order? Okay, for that we have to focus on something known as comparator interface. There is an interface known as comparator interface. Again, if you go to the collections framework, under the sorting, you have the along with this comparable, which is actually meant for the default sorting order, which is internally taken care by the TreeSet as part of the default sorting order. One of the predefined methods of the comparable is compare to method, okay, which is internally taken care for sorting of the default sorting order of the TreeSet, right? Now we are talking about the customized sorting order, which is being taken care by the comparator. Okay, for this comparator to be implemented, we have to we have to focus on comparator, guys. Okay, we have to use comparator for getting the customized sorting. How to do that? Here, no internal working. Okay, coming to the comparable, it is internally the objects are getting sorted, right, with the help of the compare to method of the comparable interface. But here, explicitly, we have to use a comparator for customized sorting. We have to explicitly use this comparator interface. How to explicitly use? For this, we have to create another class, guys. Okay, create anything. Okay, create any class. Say, you can even say class A. Okay, give any name you want. Okay, click on finish. After finishing, say implements. Okay, which interface we have to implement, guys? For customized sorting, which interface we have to implement? Comparator interface we have to implement. So comparator you have to say. Okay, comparator. For the mouse, import this comparator interface from which package? Java.util package. And again, when you implement that, all the unimplemented methods of this comparator has to be implemented inside this class, because class is implementing this interface. If there are any unimplemented methods without any body, you know about the interfaces, right? So if this in the interface, only the methods without any definition will be there. Since this particular class is implementing this interface, all the methods which doesn't have any body inside this comparator interface has to be implemented here. That's the reason we are getting a compiler error here. So simply what we are going to do is hover the mouse on this class and select add unimplemented methods. You see, whatever this compare method belongs to which interface? Comparator interface, which is just defined inside the comparator interface. Now since class is implementing this comparator, okay, we have to implement. So the definition and the body will be there here. Okay, the definition that was specified in the comparator is like compare object1 object2. Okay, so we have to return something. So let's auto generate the code, so no need to worry much, right? So once you do this, okay, what you have to do is, this is enough, guys. You have to create a class and implement a comparator interface. And when you implement the comparator interface, it's predefined method, that is compare method, has to be implemented by the class which is implementing the comparator interface. Up to that, we did. Okay, we have auto generated the code for the compare method of the comparator interface after implementing by this class. Up to that, it is enough, guys. Now let's go to demo class. And here, if you keep this constructor empty, what will happen? Default sorting order will be implemented on these objects. But what if I provide some object for this class A, new class A, I will say. Okay, here class A is implementing which interface? Comparator interface. That's why I'm saying new class A. Okay, new class A. I have to pass this object of the class A, which is implementing the comparator interface. Okay, so then customized sorting will start, guys. Okay, so here now let's this will allow the customized sorting. Okay, customized sorting. But we have to write some logic inside this. Okay, inside this compare method of this comparator interface, have to write a logic. Okay, for sorting. For example, if I write, I'll remove the return. Okay, so here these are integer objects, but I am getting them in the form of objects here. Okay, so what I'm going to do here is this object I'll typecast into the integer again. Okay, integer integer I1 is equal to, okay, I object I will say, otherwise I1 also you can say, not a problem. Okay, is equal to, I'll typecast this O1, I will typecast. Okay, here like this. I'm just converting this object into the integer. That's it. Okay. Second thing, integer, or else you can typecast like, first you can typecast integer. You have to typecast this object into the integer type. Okay. So I'll save into the I2. Second value, second integer object value. Okay. So hover the mouse, create local variable, integer will come. Now I can compare. Okay. So the previous topic I explained about one of the method of this comparable interface, right? What is that method, guys? Compare to method. What it will do? It will compare one object with another object for sorting purpose. I'll do the same thing, guys. Okay, I'll say return I1 dot compare to of I2. Okay, I'm comparing this I1 with I2. That's it. What will happen, guys? This is same as the default sorting order. Whatever that default sorting order, if you don't specify this thing in the constructor, whatever the default sorting order will be done here, this will be calling the which method? compared to method of the comparable interface. Okay, comparable interface. The same thing is happening here also. You are returning the same thing. So if you do the same thing, if you implement the same logic here, the default sorting order actually implements, you'll get the same output. That is, after implementing this customized sorting order also, okay, after implementing this customized sorting order also, all these objects will be inserted in ascending order only, because still the logic is here it was internal. I just made it external, but same logic is there. This used to be the internal logic of this default sorting order, which I made it external in the customized sorting order. That's it, nothing more. Okay, if I run this code, right click run as Java application, I will get the same ascending order. You see, ascending order is there. But can I make it descending, guys? Is it possible to make this particular order to descending? Yes, you have to change this logic inside this compare method of this comparator interface. Okay, how to do that? Instead of saying I1 dot compare dot I2, have to say I2 dot reverse way. I2 dot compare dot I1. With this simple change in the logic, the things will change, guys. If I run this code, right click run as Java application, you see descending order we got. Did we get this descending order with the default sorting order earlier? No. Now I am getting it because I just changed the customized sorting. This is customization, guys. Have customized the sorting. If I say I1 dot compared to I2, I'll get the ascending order. If I say I2 dot compared to dot I1, I'll get the descending order. So I'm able to customize. This is known as customization of the sorting. Okay, one of the customization of the sorting. So what about these are integer objects, right? These are the integer objects. Fine, let's do more customization for the sorting order here. Okay, so all the integer objects ascending order is done. If I say object one dot compared to object two in this compare logic, right? When I say descending order, I have to give something like, I have to customize this compare method by saying I2 dot compare to dot I1. That will actually customize this in a descending order like this. Next thing here is I want the objects to be inserted only in the insertion order. Okay, so I want to get the same insertion order here. Okay, here 9 is there, 3 is there, then 7 is there. I want to get the same insertion order here, 9, 3, 7. I want to print. Then guys, okay, then you have to simply return some positive value. Okay, let's return some positive value, whatever it is, whatever the objects you send, simply return the positive value and let's run it. What will happen? Let's see. You see, the same insertion order is reserved. Okay, if you want the TreeSet to reserve the insertion order, this customization sorting, you have to simply return +1 irrespective of these objects. Okay, that has been passed to this compare method. You don't have to do anything. Simply return +1. Whatever the output is there, you have to return +1. Okay. What if I want the reverse of this insertion order? I want 5 first, then 16. Here we got 9, 3, 7. Instead, I want to get 5, 16, 13, 8, 25, 1, 7, 3, 9 like that. Okay. For that, simply you say -1. Okay. Return -1. If I run this, I'll get the reverse order. Reverse insertion order I'm going to get. You see, reverse. So 5 was inserted last, I'm getting it first. 16 was last but one, second position, like that. Okay. So this is another way. Now this is how, guys, we can customize the sorting order. Okay. By using what? By using what customization of the sorting order is possible in TreeSet? We have to go with the comparator interface. Okay. We have to create a class, any class which implements this comparator interface, so that you can implement this compare method of this comparator interface. Inside that compare method of this comparator interface, you are going to write the logic. Okay, logic depends. Logic depends. If you want ascending order, you will go with the compare to method of this comparable again. Okay, descending order also compare to method of the comparable. If you want same insertion order, you have to return +1. If you want a reverse insertion order, you have to return -1. Okay. Next, what next? Same thing you can apply for the string objects also, guys. Okay. Same thing you can apply for the string objects. Instead of this objects, if I say t dot add of, I'll say Varun, t dot add of Arun, t dot add of Tarun. Okay, like this. If I give something like this, three objects are there. Okay, and I have the customization. Customized sorting is also there. Now here I will say return I1 dot compare to I2. I1 dot compare to I2. If I give something like this, what will happen, guys? Default sorting order. This is the logic of the default sorting order, right? This is the logic of the default sorting order. Here, this one will be compared with this one, something like that. Okay. Default sorting order. In default sorting order, it uses the compare to method internally. Here we have explicitly provided. That's the only thing. Customization is done. That's it. Okay. We'll get in the alphabetical order. Okay. We'll get the results in the alphabetical order now. Okay. Let's save it and run it. You'll get the result in alphabetical order. Okay. So there's something wrong here. Sorry, I did something mistake. As you can see here, we got the objects. I typecast it into integer here. Here, these objects are string objects, right? These are the string objects. I have to say string here. Okay, I have to typecast using string now. Then only I can compare. String, string. Okay. So now let's see. Now let's run this. Right click run as Java application. You see, sorted. They got sorted in ascending alphabetical order. I want the reverse of this alphabetical order. What I have to do, guys? The same thing that we did for the integer objects. That is, here instead of I1, I will say I2. Instead of I2, I will say I1. That's the only difference. It will give you the reverse of the alphabetical order. Okay, last will Arun, Tarun, Varun. Okay, earlier Arun, Tarun, Varun was there. Now Varun, Tarun, Arun is there. Okay, same things you can apply, guys. Okay, same logic. If you say return plus one, what will happen, guys? If you say return plus one, what will happen? The same insertion order will be preserved. First Varun, Arun, Tarun will print out now. Okay, right click run as Java application. Varun, Arun, Tarun. If I give return minus one, what will be done? Reverse of this insertion order. That is, Tarun will come first, then Arun will come, then Varun will come. Right click run as Java application. Tarun, Arun, Varun. Reverse of the insertion order will be there. So this is how, guys, we can customize the sorting order with the help of TreeSet by using the comparator interface and its method known as compare method. Okay, we have to implement the compare method of this comparator interface explicitly. Okay, not internal, explicitly, to customize the sorting order. And at the same time, we have to change the constructor. TreeSet constructor should be different here. Okay, it should have some class which is implementing the comparator interface. Okay, like this. Coming to the comparable interface, it is internal. Okay, it is internal. If in case of default sorting order, if you don't provide any empty TreeSet here, it will be default sorting order, and internally this program is using the compare to method of this comparable interface. Okay, this is for default sorting order, and this is for which order, guys? This is for customized sorting order. You have to know the difference between comparable and comparator. Okay, comparable for default sorting order, which is used internally only. Comparator for customized sorting order, which you have to explicitly mention in the programs. Okay, that's the differences between the comparable and comparator. Okay, for sorting purpose in the case of TreeSet. Now, guys, sorting wise, we are done with the TreeSet, guys. We have learned a lot about the TreeSet so far, but there are few things that are left. That is, this TreeSet is a child class of the NavigableSet and is a grandchild class of the SortedSet. That means all the predefined methods of the SortedSet and all the predefined methods of this NavigableSet can be utilized by this TreeSet. Okay, let's do that. So for that, I'll go back, guys. Okay, I'll remove this. I will make this okay. For avoiding the confusions, what I'm going to do is I'll go with the default sorting order. Okay, I'll go with the default sorting order, and I'll not require this class. I'll delete this. Sorry. Don't save. Delete. I only have this demo class, and it is a normal tree set. If you insert something like this, tree dot add of, okay, some 9. If I say t dot add of integer objects, I'm inserting, guys, 3. T dot add of 6. T dot add of, okay, T dot add of 1. T dot add of 13 or 25. T dot add of 13. T dot add of 8. T dot add of 2. Okay, like this different integer objects I inserted so far. Okay, what will happen when I print it, guys? What will happen when I print it? This is a default sorting order. This is a default sorting order. Empty tree set is there. All the objects, integer objects, will be stored in the tree set in the which order? Default sorting order for the integer objects is ascending order. So ascending order will come as the output. Okay, let's get the ascending order as output first. 1, 2, 3, 6, 8, 9, 13, 25. Ascending order is done. Now let's start implementing the predefined methods of the sorted set. Okay, on such kind of sorted order, let's try to implement this predefined methods of the sorted set. So let's start using the first method. Okay, first. So system.out.println t dot on the tree set. I am saying first. I'm calling the first method of the. This first method belongs to which interface? Sorted set interface. Okay, I'm utilizing that in the tree set because tree set is a grandchild of the sorted set interface. I can use it. Okay, I can call this first method using the object of the tree set. Okay, so what will be the result, guys? After sorting, whatever the first object is there, that will be result. That means here this has to be sorted like this. After sorting, what is the first object here, guys? 1. So here 1 should be printed. Okay, that is the purpose, guys. After sorting, it will consider that first. So 1. Next one. Similar method, last is there. Okay, very easy methods, guys. T dot last. After sorting, what is the last object? After this is a sorted. This is a sorted, right? After sorting, this is the thing. In alphabetical order, it got sorted. And after sorting, what is the last object? 25. 25 will be printed here. Right click, run as Java application. You see 25 got printed. Let's go to the next method. Okay, let's go to the next method, that is HashSet. System.out.println t.HashSet. If I give some number like, 9 or anything, yeah, 9 is better. If I give some number like 9, what will happen, guys? T.HashSet. All the objects after sorting before 9, whatever are coming, that is 1, 2, 3, 6, 8, that will be printed, guys. T.HashSet of 9 means before 9, how many objects are there? 1, 2, 3, 6, 8. Okay, those should be printed. So right click, run as Java application. You see, before 9, how many are there? 1, 2, 3, 6, 8. So 1, 2, 3, 6, 8. This is the purpose of the HashSet. It will retrieve all the objects after sorting all the objects which come before the 9. Okay. So 1, I don't have to print the output. You understood it. Okay. System.out.println. If I say another method is there, that is tail set. Okay. Tail set. T dot tail set. So I give the same 9. Okay. For headset also I gave 9. But what happened with the headset? Less than 9, whatever the objects are there, they got printed here, right? But coming to the tail set, okay, here less than 9. Okay, simply I will write a comment as less than 9. Less than 9, after sorting, whatever the objects that are less than 9, that will be printed. Okay, but coming to the tail set is an opposite of the head set, guys. It is greater than or equal to 9 also. Okay, here equal to is not there with headset, but coming to the tail set, equal to is also there, greater than or equal to 9. That means 9 is there, starting from 9 and then greater than 9, that is 9, 13, 25 should be printed. Greater than or equal to 9, that is 9, 13, 25. Let's run this. 9, 13, 25. Okay, before 1, 2, 3, 6, 8. Now 9, 13, 25, greater than or equal to 9. That's how the tail set works. Then we have subset. System.out.println t dot subset of, okay, subset of 2 and 9. If you have to give 2 objects, guys. Okay, how this logic works? Greater than or equal to 2 and less than 9. This is how it works. Okay, greater than or equal to 2 and less than 9. So greater than or equal to 2, 2 will be retrieved. Then 3, 6, 8, but less than 9. not equal to 9. Up to 2368 only will be retrieved, guys. Okay, 2368. Let's see that whether we get 2368 in the output or not. 2368 got printed. So this is how this predefined methods of the sorted set will work. The purpose of this sorted set predefined methods is to retrieve the objects. Okay, based on our requirement, we can retrieve the objects. Either we can retrieve the first sorted object, either we can retrieve the last sorted object. Okay, like that. Okay, now we are done with the predefined methods of the sorted set. Now I'm going to demonstrate the predefined methods of the navigable set because child class. TreeSet is a child class of navigable set. So all the predefined methods of the navigable set can be utilized by this TreeSet. So what I will do here is I will say system.out.println and I will just put a line here, okay, just for separation. Again, I'll print the T. If I print T, all the ascending order objects will be retrieved, right? So right click run as Java application. Again, we'll get the same output. Initially, whatever the output we got, the same output we'll get. That is 1, 2, 3, 6, 8. Ascending order, the objects will be retrieved. Fine, printed. Now let's on this particular set, let's start using this predefined methods of the navigable set. Let's start with the lower guys. Okay, lower. So if you remember, navigable set has some specific methods which are related to navigation purpose. Okay, so one requirement I want to ask you, that is I want to get this only 8. Okay, I want to retrieve only 8 from this sorted set, sorted objects. Okay, these are the sorted objects, right? These are sorted by the TreeSet. I want to only get this 8 object. What to do, guys? Can I retrieve this object 8 using any of these methods of this sorted set interface? It's not possible. Only first and last are possible, but remaining they will be coming in groups like this. Okay, only first objects, last object it is possible, but in between objects, can I navigate and get this object in between using the predefined methods of this sorted set interface? It's not possible. Only first and last of the sorted set can we can get. Other 3 methods will actually retrieve the set of objects, not single objects. But if I have a requirement where I want to retrieve only this 8, what I have to do? What I have to do? For that, we have to navigate. We have to navigate to 9 and then retrieve this 8. Okay, we have to navigate using the navigation methods which are there in the navigable set interface and retrieve this 8. Let me explain. Okay, so by using this method known as lower, let's go with the lower guys. Okay, system.out.println. I will say something like this: system.out.println t dot lower of object. This object I will give as 9 guys. Okay, here what I am saying to this lower method is navigate to this 9. First navigate to this 9. Okay, I have navigated to this 9. After navigating, find the greatest. First, it's kind of confusing guys, but let's understand. Okay, t dot lower of 9. So I am saying that go to 9 and all the objects should be, and search for all the objects, navigate through all the objects which are less than 9. Lower of 9 means it should be less than 9, right? These are all the things. 1, 2, 3, 6, 8. How many objects are there which are lower than 9? 5 objects. Out of all these things, retrieve the greatest object. Okay. First of all, it should be less than 9. Okay. All the objects which are less than 9 are 1, 2, 3, 6, 8. These are the different objects which are less than 9. And find the greatest. And then find the greatest. First, find all the objects which are less than 9 using this lower method. If you say lower of 9, it will find all the integer objects which are lower than 9. That is 1, 2, 3, 6, 8. Out of all these integer objects which are lower than 9, find the greatest. What is the greatest out of this 1, 2, 3, 6, 8 guys? 8. So it will print 8 guys. Now I am getting the value as 8. This is how we have to use the lower method, okay, of the navigable set for navigation purpose. You got the output as 9, 8. Okay, fine. Then let's go with another navigation method, that is opposite of the lower is higher. Okay, let's go with that. System.out.println t dot higher of 9. If I say 9, okay, What does this mean? I'm asking to find all the objects which are greater than 9. Here greater than 9. What are the different objects which are greater than 9, guys? After sorting, greater than 9 is 13 and 25. In that, find the list. Find the list. Okay, in the greater than 9 objects, that is 13 and 25, which is the list number? 13. After 9, we are navigating to 13. With the help of 9, we are navigating to 13 with this logic. Okay, like this, it will work. Fine, it is also done. So did I run? Yeah, let me run this. Right click run as Java application. You will get the output as 13. Okay, whatever the object we want to retrieve, we are able to navigate to that part using these navigation methods of the navigable interface and retrieve them. Okay, using this kind of logics. Next thing is we have something known as floor. Okay, floor. System.out.println t.floor of 9. This is also similar to lower case, but there is a class. Okay, that is less than or equal to 9. Okay, and find the greatest. This is the only logic. And find the greatest. Here less than 9, but here floor for lower it is less than 9, but floor it is less than or equal to 9. That means less than or equal to 9. Okay, so 9 and less than 9, that is 1, 2, 3, 6, 8, 9 are there. How many are there? 6 objects have been retrieved, and out of all the 6 we have to find the greatest. 1, 2, 3, 6, 8, 9. Which is greatest? 9 is greatest, so output will be 9. Okay, right click, run as Java application. 9 will be out. What if I give something like 10? Okay, it will be like less than or equal to 10. Do you have the 10 object here? No, but still it will work. Okay, so it will check for the objects which are less than or equal to 10. Is there any 10 here in this sorted sorted objects? No, 10 is not there, but less than or equal to 10 equal to is not there, but less than 10 is there. So it will consider 1, 2, 3, 6, 8, 9. Out of which is greatest? Out of this list values, which is greatest? List of 10 values, which is greatest? 9 is greatest. So again 9 will be printed, guys. Okay, right click run as Java application. 9 will be printed. Similarly, an opposite method also there for floor, that is ceiling. Okay, ceiling. System.out.println t.ceiling of, if I give something like 9, what will be the result? Internal logic will be something like this: greater than or equal to 10. Sorry, 9 I have given, right? Greater than or equal to 9. Okay, it works similar to higher, that is greater than 9, but here equal to is addition. And find the list of the found objects we have to find. Okay, so greater than or equal to 9 and find the list. Greater than or equal to 9, that means 9, greater than 9 is 13, then 25. These are the 3 objects that will be retrieved. Out of these 3 objects, we have to find the list. What is the list out of this 9, 13, 25? 9. So 9 will be printed. Right click, run as Java application. Okay, 9 is the output. What if I give 10 here? So here greater than or equal to 10 will be there, and we have to find the list. So greater than or equal to 10, is 10 there here? No. Greater than 10 is 13, 25. Out of 13, 25, which is the list one? 13. So 13 will be printed. You'll get the output as 13. Right click, run as Java application. Output will be 13. Next thing. So next thing, these are the navigation methods, guys. Lower, higher, floor, and ceiling are the navigation methods. Okay. So these are specific only to the navigable set, which are not there in the sorted set. Okay. If you want to navigate somewhere and retrieve only specific elements, you have to use any of these 4 navigation methods of this navigable set. Okay. And remaining things we have is, let's do with this descending set. Okay. Straightforward methods, guys. That is system.out.println. If I said t dot descending set. So by default, the sorting order will be ascending, right? Sorting order will be ascending. I can convert it into descending with the help of the descending set method directly. Okay. Here, ascending order is 1, 2, 3, 6, 8, 9, 13, 25. Descending order is 25, 13, 9, 8, 6, 3, 2, 1. That is possible with the help of descending set. Okay. So right click, run as Java application. You see, descending order. All the objects got printed in descending order now. Okay, because of this method. Fine. So descending set is also done. Next thing here is poll first and poll last. So if I say poll first, what will happen? T dot poll. I'll remove this, guys. Okay, I will remove this descending so that it will be confusing. What I will do is again I will print T. Okay, here system.out.println. I'll get the ascending order again. Okay, so run it. Right click, run as Java application. After ascending, this is our original ascending order we got here. Okay, now I'm going to apply poll first and poll last on this ascending order. System.out.println. If I say T dot poll, T dot poll, poll first. Okay, what will happen here, guys? Okay, if I say T dot poll first, when these are sorted, when these objects, all these integer objects are sorted in inserting order, what is the first object, guys? 1. Okay, 1 will be retrieved. Poll first will retrieve this 1. At same time, it will remove the 1 from the this tree set. 1 will be removed from the tree set, guys. After polling, if you print the tree set, the 1 will not be there. Okay, here 1 will be retrieved by the from the tree set, but 1 will not be there. The first object after sorting will be retrieved. That is 1 will be retrieved and printed here by the poll first. But after this poll first, if you print the complete T again, then 1 will not be there in that list. Okay, fine. Let's run this. Right click, run as job application. So out of this complete tree set objects, poll first has printed this 1, has retrieved this 1 from this. At same time, it has removed the 1 from the complete tree set. Now 1 is not there in this tree set. You see, only 2, 3, 6, 8, 9, 13, 25 is there. That is actually poll first. Similarly, another method is there, that is poll last, which works reversely. Okay, system.out.println. Last will be removed. Okay, here poll first will remove the first object of the sorted, then poll last will remove the last object. So that means poll last, out of the remaining objects inside the tree set, the last object is 25. After sorting, last object is 25. Poll last will retrieve this 25 and print it here. Println will print the object that is retrieved by this poll last, that is 25 will be retrieved by this poll last and will be printed by this println here. Okay, here 25 will be printed. At same time, poll last will remove this 25 from the tree set. So if I try to print the tree set again after poll last, 25 will not be there in the list, guys. Okay, 25 will not be there in the tree set. So run it. 25 is not there in the tree set. Only 2, 3, 6, 8, 9, 13 are there. Poll first has removed the 1 from the tree set and poll last has removed the 25 from the tree set. And also it is retrieved at the same time. Okay, here 1 got retrieved. So these are all the predefined methods of the navigable set, guys. Okay, these are for the navigation purpose and these are for other purposes. Okay. So guys, hope you understood the tree set. Okay, hope you understood the tree set. Last but not least, you can even add the generics here, guys. For example, if you only want to add the integer objects, simply add the generic here. Generic concepts I will explain in the upcoming videos in a detailed way. Like this, you can add the generics. Okay. Already explained about the generics as part of the array list and other things of these collections framework videos. Okay. You can refer to them if you want to understand what exactly the generics are up to this mark. Okay. If you mention this generic here, only integer objects are allowed. To try to add any string objects, it will give compiler errors. Okay, fine. If you want to add any string objects here, you have to provide string here. Okay, if you want add heterogeneous objects, you have to provide object here. Okay, in place of this generic, you have to add the object class or integer class or string object class or any other wrapper class based on the type of objects you want to add. Okay, that's all about the generics. So guys, that's all about the tree set. We are done with the tree set. So far, I explained this collection as part of the collection interface. I already covered all these classes. Okay, all these things are covered as part of the list interface and its child classes are covered already in the previous videos. Now coming to the set, also I completed everything, that is set interface and its child classes and interfaces and classes, everything is covered as part of the set. So do I have to cover the queue? Do I have to cover the queue? No guys, I'm not going to cover queue because queue is not that much used as part of the tester concept or beginner way of understanding the things. Q is not required to understand. Okay, so I'm not going to cover Q in my videos. So directly I'm going to jump to the map interface. I'm going to jump into the map interface. So this is another first half is done, guys. Now, okay, I completed the first half, like list interface and its child classes I completed, and set interface and its child class and interface also completed, and Q is not required to learn. So this first half is completed. First half is completed under the collections framework. We are left with the second part, that is map interface and its child classes or interfaces. Okay, there are many child classes and interfaces for this map, which I am going to cover in the coming videos. I'm going to start the next video session. I'm going to start with the map interface first. This particular thing, map interface first. Then I will go with the upcoming videos. I will go with the its child classes and interfaces. Okay, one by one. So these are the different things I'm going to cover next. And coming to the other, enumeration is covered as part of one of the collection, and iterator is also covered. List iterator is also covered. Sorting wise, comparable and comparator also covered. Okay, and collections class a bit covered, and arrays class I didn't cover. Okay, these two things are left. Okay, collections class and arrays I need to cover, which I will be doing after completing the map. Okay, I'll be covering this the remaining utility classes like collections and arrays in detail after completing the map interface and its child classes and interfaces. Okay, which I'll be starting next. So guys, in the next video session, I'll start with the map interface. That's the plan, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 232 of Java for Tester series, that is map interface. So what is map? What is map? Map is a predefined interface in Java. Okay, map is the predefined interface in Java, and it is one of the root. Okay, it is one of the root interfaces of collections framework. So what is map, guys? Map is a predefined interface in Java, and it is one of the root interfaces of the collections framework. Let me visually show you. This is the entire collections framework. As you can see, when you divide the collections framework at a high level, okay, it can be categorized into these three categories only. One is collection interface category, other category is map interface category, and other miscellaneous class and interfaces which form the collections framework. Okay, here as you can see, everyone believes that collections framework means collection, right? It's not like that. Collection is not only the root interface, but there are other root interfaces in parallel to the collection interface, that is map interface. Till the previous videos, I collected almost all topics or all the class and interfaces which form this collection interface. All these things I covered in the previous video. Okay, so all these parts, all these things I covered as part of the previous videos, which is the first half, guys. We can say that collection interface is the first half of the collections framework, whereas map interface is the other half. Okay, it is also the root interface, guys. Okay, what is the root interface of the collections framework? There is no single root interface for the collections framework. There are multiple root interfaces. That is, half portion will be covered by collection interface and half portion will be covered by the map interface. So map is another root interface. That's why I'm saying here, map is a predefined interface in Java, and it is one of the root interfaces of collections framework. Okay, one of the root interface of the collections framework. Fine. So what next? Next thing here is, you can see here, this map interface is not the child interface of the collection interface. Instead, collection and map interface are like siblings. They are at the same level. Under collections framework, map is not the child interface of the collection, or collection is not the child of the map. Both collection interface and map interface are the root interfaces of the collections framework. They are at the same level. Okay, they are at the same level. Fine. So let's understand more about map, guys. Okay. Now you understood the position of the map interface in terms of the collections framework, right? Now let's understand more about the map interface. So when we have to go for maps, if you want to represent, okay, if you want to represent a group of objects as key value pairs. Okay, if you want to represent a group of objects as key value pairs, then we have to go for map. Okay, what do I mean? For example, let me give an example, guys. So here, one side we have keys and other side we have values. Okay, key and values. Say key here, let's say key is 1. Okay, value is some Arun. Say key is 2, value is Varun. Key is 3 and value is okay Tarun. Key is 4 and value is some Motori. Okay, like this. So these are the keys, unique values, unique objects you can say. Okay, these are the values. So here we have key and value pairs. First key value pair is 1 and Arun is the first key value pair. Second key value pair is 2 and Varun. Third key value pair is 3 and Tarun. So it may not be 1, guys. It can be 101 also. Up to you. Okay. 101, 102. Like this you can create. Not a problem. Okay. These are keys, guys. It's like roll numbers or something like that. Okay. It's like roll numbers or ID card numbers for employers. ID numbers for employers, employee IDs and all those stuff. Okay. Are the nothing but keys. Whereas values are names in this example. In this example, these are names. Let's say this is employer. Okay. This is employees objects, let's say. Okay. So on the right side we have employee names. On the left side we have employee IDs and employee names. Such kind of things we can create or represent as a group. All these things can be represented as a group. You see here, different objects are there and we have represented as a single entity. Okay, single entity. So we are grouping different objects as key value pairs, where if you have such kind of requirements where, okay, if you have such kind of requirements where you want to represent a group of objects as key value pairs, then you have to use what, guys? You have to use collection or map. You have to use map, guys. Okay. So if your requirement is to represent a group of objects as key value pairs, then you have to go for maps. Here keys are objects, guys. Okay. This is an object. This is an object. This is an object. This is an object. And values are also objects. This is another object, another object, another object, another object. How many objects are there in this example? 8 objects are there. They are represented as key and value pairs, and they are grouped together into a single entity. We have grouped them. All the different objects we have grouped them into a single entity in terms of key value pairs, and all these key value pairs are objects. Okay. This kind of requirement, if you have to represent the group of objects as key value pairs like this, then we have to go with something known as maps. Okay, that's the reason maps came into picture, guys. Okay, that's the reason maps came into picture. Fine. Next thing here is, so here what can be duplicated and what cannot be duplicated in terms of maps. Here keys are there, here value objects, here key objects are there, value objects are there. Can keys be duplicated? No. Keys need to be unique, guys. Okay. There are few rules for maps. Okay, if you are representing some objects as keys in maps, okay, these keys are unique. Keys should be unique, guys. If you try to duplicate any of these keys, you will get compiler error. Okay, but values are not unique, guys. Okay, values can be duplicated. You can duplicate the values. Why? Because you can differentiate these values with the help of keys, because keys are anyway unique, guys. With the help of these unique keys, you can differentiate the duplicate values, right? If you have 101 Arun and 103 also is Arun, let's say. Okay, let's assume that 103 is also Arun. So here this Arun is different from this Arun because this Arun has a key as 101, this Arun has a key as 103. This can be differentiated. That's why values can be duplicated but keys cannot be duplicated. Keys need to be unique in maps. Okay, that's another thing you have to remember as in terms of maps. And guys, this first key value pair. Okay, this is a set of key value pair, right? One key is there, one value is there. Together we can call this. Together we can call. Okay, together we can call a key and value pair. This combination of key and value as an entry, guys. Okay, how many entries are there in this example? 4 entries are there. Okay, first key value pair is one entry. Again we have the second key value pair here. This is another entry. Third key value pair is there. Combination of key and value is third entry. Okay, and the fourth key value pair we have. This is the fourth entry. So we can redefine this definition, guys, for the map. That is, earlier what I said about map. Map is nothing but a representation of group of objects as key value pairs. You can also say this as map is nothing but a group of entries. Okay, a group of entries. Map is nothing but a group of entries. Okay, group of entries. So each entry will have, where each entry is a key value pair. Okay, so what is entry, guys? Entry is nothing but a group. Entry is nothing but a pair of key value pair. Okay, key value pair together is known as entry. That's the reason we can say map is a group of entries where each entry is a key value pair. Where each entry is a key value pair. Fine. So this is a terminology you have to remember, guys. Okay, in terms of maps, you have to remember this entry terminology. Okay, you have to remember this entry terminology. Okay, keys, values, entry, all those things you have to remember. Okay, where keys are unique, values can be duplicated, and okay, that's it. Okay, that's it. Fine. Next thing. Next, let's move to the next thing to understand more about maps. Okay, map interface. So map has several child interfaces, guys. Okay, map has several child interfaces and child classes also. Map interface has several child interfaces and classes. Let me explain them. Okay, here on the top we have map interface, right? Map interface is one of the root interface, right? So here collection interface is another root interface. In parallel to that, we have map interface in the collections framework. Fine. Under map interface, we have a child class known as HashMap. HashMap is one of the child class of the map interface, and this HashMap has another child class known as LinkedHashMap. Okay, LinkedHashMap is a child class of the HashMap, and here we have another child class for the map interface, that is weak HashMap. Okay, then we have this map interface another child class known as identity HashMap. Is another child class, okay, of this map interface. Then we have HashTable. Remember, guys, here T is small. Okay, here T is small. Now all the other classes and interfaces which are there in the collections framework, not only in the map interface but also in the collection interface and its child interfaces and classes. Okay, all words are like this. First word is capital letter and second word also capital letter. But coming to HashTable, here first word H is capital, but the second word's first letter is not capital, guys. Only this is only there for the HashTable, guys. In HashTable, you have to remember that the T is not capital letter, it's small letter. Okay, this is very important, guys. Okay, this is very important. Let me mark it so that it is different compared to other class and interfaces naming conventions. HashTable has a T as small. Okay, and it has a child class. HashTable is a class or interface. It's a class, guys. Okay, it's a class. Let me put a C here. Okay, HashTable is a class, and it has a properties class. Okay, it has another child class known as properties class. HashTable has a child class known as properties class, and it has a parent class also. The name of the parent class is dictionary class. Dictionary class. And which is a abstract class, guys. It's not a normal class, it's an abstract class. Okay, abstract class. Fine. Apart from this, are there any other things in HashMap? Yes, there is one more thing. Okay, so let me take like this. Okay, so map has HashMap, weak HashMap, identity HashMap. HashMap has this linked HashMap. Map interface has this HashTable, which has a parent class as dictionary, abstract class, and properties class as a child class. Now map also has a child interface known as sorted map. Okay, this is a child interface, and it has another child interface known as navigable map. Navigable map child interface, and it has a child class known as tree map. Okay, tree map is the child class of this navigable map, and sorted map, which is the child of this map interface. So this is the hierarchy, guys. This is the hierarchy of the map interface. Okay, this complete thing is map interface and its child classes and interfaces. Map, HashMap, linked HashMap, weak HashMap, identity HashMap, HashTable, properties class, dictionary abstract class, sorted map interface, navigable map interface, tree map class. Okay, all these things I am going to cover in this video series, guys. In the upcoming videos, one by one, I am going to cover this child classes and interfaces. Okay, so several child classes and interfaces. Okay, these are the different child classes and interfaces. Now let's move to the next one, that is what is the difference between the collection interface and map interface. Okay, if you understand this, we'll understand map more, guys. Okay, so it doesn't take much time because I already covered a lot of things about this map and its hierarchy and all those stuff. Okay, so let's take a new. Here let me explain the difference between the collection interface and this side the map interface. Okay, what's the difference between the collection interface and the map interface? Let me explain. So collection interface has its own hierarchy, right? If you go here, collection has its own hierarchy, map has its own hierarchy, collection interface has its own child classes and interfaces, map interface also has its own child classes and interfaces, right? But what exactly the collection interface and its child interfaces and classes are meant for? They are meant for grouping objects, individual objects as a single entity. Okay, if you want to group individual objects as single entity, okay, it's like this. All in this grouping part, okay, we are grouping individual objects as a single entity. Let's say these are all the objects, you are simply grouping them. Okay, for such kind of requirements, we will go for collection interface and its child interface and classes. Coming to the map, okay, the difference here is map interface and its child classes and interface are meant for grouping, okay, objects as key value pairs, okay, into a single entity. Here also single entity, that means here also single entity is there, but the objects are grouped as key value pairs. That is, here individual objects will not be there. Here individual objects are grouped, but here key value objects are grouped. That means key value, one is key, another one is value. Sorry. Okay, let me copy paste. Grouping the key value pairs like this. Okay, grouping the key value pairs like this. Here key object will be there, value object will be there. Together entry, right? All these entries are grouped together into a single entity. Okay, into a single entity. In terms of map and its child classes and interfaces, okay. So what will be done, guys? Group of key value pair objects will be grouped into a single entity. Okay, that's the difference between collection. Here individual objects are grouped. Here key value key value pair objects are grouped into a single entity. That's the difference, main difference between collection interface and map interface. All the child classes and child interface of the collection interface will follow the same routine, same thing, and whereas map interface and its child class and child interfaces will follow this key value pairs, okay, grouping part, okay. So that's the main difference. Second thing here is collection interface has its own specific methods, okay, its own type of methods, you can say its own type of specific methods will be there in the collection interface. Here map also has its own type of specific methods, okay. Let's take an example, guys. For example, if you go to this collection interface, what is the method for adding the objects, guys? Add of objects. But do we have the same method in the map interface? No, guys. Map interface has its own specific methods, okay, which are different from the collection interface, okay. So all the child classes and interfaces which are implementing this collection interface actually use this add and this kind of methods for performing the operations on the objects. But coming to the map interface, they have their own setup, okay. We are nowhere going to use the add method for adding the objects, okay. But in map interface, it has its own specific methods like put, okay. Using put, we are going to add, guys. Instead of using add, which is there in the collection interface, okay, this add method is being used by its child class and child interface of the collection interface. But coming to the map, okay, all the child classes and the child interfaces of this map interface along with this map are going to use this methods known as put for adding the objects, not the add method, okay. Like that, methods which are specific to map need to be used by its child classes and child interfaces along with the map interface, okay, for performing the operation. These are the different okay methods: put, put all, get, remove, contains key, contain value, is empty, size, clear, key set, values, entry set. These are all the different predefined methods of map interface. Map interface also has a child interface known as entry interface, okay, from where we can get something known as get key, get value, and get set value, okay. So let's see where exactly this entry is there. Go to Java 8 API, search for map interface. Simply search for map interface, guys. You have to find map. Yeah, I found it. Map is an interface. So sub interface, where is that? Map interface. Do we have anything like entry? Let's see whether we have anything like entry here. I'm not finding anything. So let's find in a reverse way, like let's find entry interface, okay. Let's find the entry interface. Control F, entry, search for entry. Okay, not finding the entry also. Is that, yeah, there was something like entry, right? So map.entry, something was coming. Yeah, this one, map.entry. Let's find it. So map.entry is there, okay. So entry is also an interface which is related to map, guys, okay. If you are, if the child classes are implementing, okay, are implementing or inheriting child class or child interface of the map interface, if they are implementing this map interface along with this all these predefined methods, okay, we can also get the predefined methods of this entry interface, that is get key, get value, and get set value, okay. We can also use this for our purposes, okay. These are all the predefined methods which are related to map, guys. All the child classes and interfaces of the map interface, okay, are going to use these predefined methods. So I'm not going to explain, okay. I'm not going to explain or practically demonstrate this map specific methods now, because there is a reason behind that. Because map is an interface, guys. Can we create objects for the interfaces in Java? It's not possible. So I cannot create an object and use this predefined methods of this map interface for practical demonstration here, okay. So we have to wait for some time, guys, because as you can see here, the collections framework, we have this map. When you expand this map, we got all these child classes and child interfaces, okay, of the map interface, and we have to use one of the child class of this map interface for creating an object. We have to create an object for one of the child class of the map interface. Let's say HashMap is one of the child class of the map interface. If you create an object for the HashMap, okay, using that object, we can access all this predefined method of the map interface and this other methods also. Okay, so while I explain this hash map, I'm going to cover all these predefined methods of the map interface, guys. Okay, so let's wait for that thing. So when I'm going to explain this hash map, then in the next video session, guys. Okay, so I'm going to cover this hash map in the next video session where I'm going to practically demonstrate all the predefined methods of the map interface. Okay, using this hash map class, which I'm going to explain in the next video session. As we cannot create objects for the map interface, as objects cannot be created for interfaces in Java. So let's wait for that hash map video session where I'm going to practically demonstrate all the specific methods which are related to map interface. So guys, that's it about the map interface. In the next video session, I'm going to cover HashMap class, which is the child class of the map interface. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 233 of Java for Tester series, that is HashMap. So what is HashMap? HashMap is a predefined class in Java. Is a predefined class in Java. There are many predefined classes in Java, and HashMap is one of them. And it is the child class of which interface? Map interface. HashMap is a child class of map interface. So let me show you visually, guys. Okay, how HashMap is the child class of the map interface, and it belongs to which framework? Which concept, guys? Collections framework. Okay, HashMap is a child class of the map interface and it belongs to collections framework. So let me show you visually, as I mentioned. So this is the entire collections framework, and on the root we have this collection interface and map interface as the root interfaces. And if you expand this root interface, this map interface has several child classes and interfaces. And out of all these child class and interface for this map interface, HashMap is one of them. Okay, HashMap is one of the child classes of map interface which belongs to collections framework. So what is the benefit, guys? What is the benefit of having this HashMap as a child class of the map interface with respect to collections framework? The only benefit that will happen here is, as you can see, map interface has many or several predefined methods. Okay, map interface has several predefined methods. As this HashMap is a child class of this map interface, if you create an object for this HashMap, using that object reference, we can use all these predefined methods of the map interface. Okay, as HashMap is a child class of the map interface, HashMap inherits all the predefined methods of the map interface. Okay, we just need to create an object for the HashMap, and using that object reference, we have to call all these predefined methods of the map interface. In this video session, I'm going to practically demonstrate each and every predefined method of this map interface by creating an object for the HashMap. Okay, but at the later point of time. So for now, let's move on with the HashMap. Okay, let's find out more about the HashMap before I practically demonstrate all these predefined methods of the map interface. Okay, using the object of this HashMap. Fine. So next thing. So similar to map interface. Okay, HashMap groups the objects as key value pairs. So in the previous video, I explained about the map interface, right? So the whole concept of the map interface and its child classes or interfaces. Okay, the whole concept behind this map interface and its child classes or interfaces is that, okay, they will group the objects, okay, as key value pairs. Okay, if you want to group the objects as key value pairs, then you have to go with the map interface and its child classes or interfaces. Okay, then you can group the objects as key value pairs. Same thing applies to the HashMap, which is a child class of the map interface. Okay, it's a child class of the map interface, using which we can group the objects as key value pairs. But there is a difference between the map interface and HashMap, guys. Okay, map interface and interface, guys, you cannot create an object for the map interface. Because of that, you cannot actually perform anything, right? So you have to go for any of the child class of this map interface, that is nothing but HashMap. For HashMap, as it is a predefined class, you can create an object for the HashMap, and using that object reference, you can perform all this kind of activities. Okay, which map interface actually provides. Okay, but using HashMap, we are able to execute that. We will execute that. Okay, let's do that. Fine. So the same thing, the same behavior of the map is there with the HashMap because it will group the objects as key value pairs. Fine. So if you remember in the previous video, I explained about this key value pairs. Okay, let me explain again as the context is there. Let me explain again as part of the HashMap again. So in HashMap or map, whatever it is, okay, all the objects will be grouped into a single entity like this. Okay, single entity. Inside this entity, all the objects will be grouped, but not individually, guys. Objects are not grouped individually inside this single entity. Rather, they will be grouped as key value pairs. Okay, key and value. Each and every object has a key value pair. Each and every object has a key value pair. So let me copy paste. So these are all the individual objects. These are not individual objects, guys. These are dual objects. One pair of objects, you can say. Key object, value object. Together they form key value. Okay. Here this is key object. This is value object. Together they form key value like that. Key and value like this. Okay. All the objects are grouped together as a single entity as key value pairs. Using HashMap, we can group the objects as key value pairs like this. Okay. If you go to the previous topic, that is collection. Okay. Not map, guys. This map and HashMap looks like this. But coming to the collection interface and its child classes or interfaces, how the objects are grouped, guys. Here collection interface also groups the object as a single entity. Okay. Like this. Let's say this is a single entity, and inside that individual objects will be grouped, guys, not key value pair objects. Okay, here key is an object and value is also an object. A pair of objects will be there. Okay, in case of HashMap and map, the pair of objects will be there like key value pairs. But coming to the collection, all the objects will be like this, guys, individual objects, only one object. Okay, object 1, object 2, object 3, object 4, object 5, object 6, object 7. But coming to here, objects will be grouped in the form of key object and value pair objects. Okay, this together one. Okay, we generally call this key value as entity. Okay, entity. Yeah, just let me check. So we generally call that as not entity. We generally call that as entry, I guess. Entry. Is that entry? Okay, it's called as entry, guys, not entity. Okay, entry. Entry 1, entry 2, and another entry is here. Entry. This is another entry. Okay, like this, different entries. Okay, key value. This is object 1, object 2, object 3, object 4, object 5, object 6, object 7, object 8. Together key value objects are together called as entry. Okay, so map and HashMap is a group of entry objects. Okay, entries, group of entries. Okay, group of entries. Whereas collection is a group of individual objects, group of individual objects. So hope you understood HashMap now. Okay, which groups the objects as key value pairs inside a single entity. Okay, into a single entity. So let's find out more about the HashMap. So now let's move to the practical mode, guys. A lot of theoretical part has been already done. If it's still this is not clear, you can actually go to the previous video where I clearly explained about the map interface. Okay, all these concepts are covered entirely clearly inside this map interface video, which is there in the previous video. Okay, of this video series. Now, hoping that you understood this concept of map, HashMap, and collection interface, individual objects, and all those stuff. Let's move to the HashMap practical demonstration. Okay, let's move to the practical demonstration of the HashMap now. Fine. So this is a sample Java project. We have a sample class. Inside that we have a sample main method. Inside this main method, I'm going to write the code. So before I perform anything on the HashMap is a predefined class. So I can create an object. Okay. So I can create an object. So let me create an object for the HashMap. HashMap HM. I'm saying you can say H also. Okay. Anything. It will be easy if you put H because you don't have to type much. HashMap H is equal to new HashMap. Okay. Hover the mouse on the HashMap and select import HashMap from the java.util package. After importing this predefined class from the util package, then you can take this object reference H. So as I mentioned already, HashMap is the child class of the which interface? Map interface. Map interface. And map interface has many predefined methods. So what is the predefined method out of this map interface, which is able to add the objects? Okay, add the objects. Not to add the objects, we have to use a method known as put. In case of collection interface, there was an add object, okay, add method. But coming to the map interface, we have to use put for adding the objects. So here, since HashMap is the child class of the map interface, we can use the object reference of this HashMap to actually use that put method of this map interface. Okay, let's use this put method. Okay, h dot put. Here, as I already mentioned, HashMap or map, okay, will store the objects. Will store the objects and group the objects as a key value objects pairs. Not single. If you are trying to add, you have to add them as key value pairs. Not only individual objects cannot be added, guys. Okay. If you say h dot put, you'll know that. Okay. H dot put. You see, put object key, object value. You have to insert key and value together. Okay. This key is an object and value is also an object. So let's take some example where I will put something like 101 and the value as key object as 101 and value object as Arun. Okay. Okay, let's assume that Arun is an employee in a company and his employee ID is 101. Okay, like that. Okay, let's assume that example. H dot put, again put of object key object comma value object, where I'll give another employee ID, employee's ID, that is 102 and value as, let's say, Varun. Then H dot put another employee details I'm adding as key value. One is 103 and his name is Tarun, let's say. To add such kind of objects, to add such kind of key value objects, we have to go with HashMap, guys. There is no other way. Okay, none of this collection interface or collection interface related child classes can provide this facility, guys. Only map and its child classes can have this facility of adding the key value pairs. If your requirement is key value pairs, you have to go to the map and its child classes for implementation purpose. Okay, so that's where the map and its child classes like HashMap has to be used. Okay, fine. So let me print, guys. So what will happen? This got added to the HashMap. This got added to the HashMap. Okay, all these key value pair objects got added to the HashMap. If I print it, I will find out. Okay, in order to find out whether this key value objects have been really added to the HashMap, I need to print. Okay, I'm printing the object reference of the HashMap. So if I do that, if I run this code, observe that it will be printed like this. Okay, so how it got printed, guys? Open curly brace and ending curly brace. In between that key value. Okay, 101 is equal to Arun, like this. Okay, 101 is equal to Arun. Then comma. This is one key value pair. Okay, key object is equal to value object, like that. Okay, then 102 is equal to Varun, comma 103 is equal to Tarun. Okay, 103 is equal to Tarun. Like this, they got added. You see, these three key value pair objects got added into the HashMap. This proves that. Now let's move to the next one, guys. Can we add duplicate keys? Okay, so as mentioned here in our example, we have taken this particular example, guys. Okay, let me say file new. In our example, we have this particular example where we have different keys and values, 1, 2, and 3, let's say. Okay, on the one side we have the keys and on the other side we have values. One of the key we have is 101 and its value is Arun, and the second key we have is 102. We have added is 102. Okay, and the value is Varun. And another, in our example, we have 103 as key and value as Tarun. Okay, this is the example we have taken. So these are keys, these are values, right? Values. Can we duplicate keys? Can we duplicate the keys? Can we duplicate the keys? No, guys. Keys cannot be duplicated. Keys should be unique. Keys should be unique, guys. Okay. Duplicate keys are not allowed by HashMap. Duplicate keys are not allowed by HashMap. Coming to values, can I duplicate? Can we duplicate values? Yes, values can be duplicated. Okay. The reason behind that is, as the keys are already unique, you can duplicate the values. Arun can be there at 101 and 103. They can be Arun at 101 can be differentiated. Okay, can be differentiated by the 103, right? This Arun is having employee ID as 103. this Arun is having the employee ID as 101. They can be differentiated with the help of keys. So duplicated values are allowed. Okay, but duplicate keys are not allowed. Only unique keys should be there. Keys should be unique. Values can be duplicated. Okay, this is how it works. So what if still if I try to duplicate the keys, am I going to get any compiler error? Okay, if I try to duplicate the keys, am I going to get any compiler error? The answer is no, guys. You're not going to get any compiler error. Instead, instead the value which is at a particular key will be replaced, okay, with the new value. So let me show that. Let's say here you already have h dot put is equal 10 Arun, put of 102 Arun, h dot put of 103 Tarun. If I try to duplicate this key, let's say I would like to duplicate the key like 101. Okay, if I put something like h dot put off, okay. So first I will print it. So without any duplication, I will try to print it. As you can see, you will get an output, right? Before duplication, you are going to get an output like 101 Arun, 102 Arun, 103 Tarun. Now after printing it, I am trying to duplicate h dot put off, sorry, h dot put off object key object comma value object. I am trying to duplicate the key. I am going to take the exact key 101 and put it here. And here I am trying to provide a different value. Let's say here I'm trying to provide a value like my last name, that is Moturi. Okay, fine. What will happen, guys? Will I get any compiler error because I'm trying to duplicate the key using the put method? No, guys, no compiler error. But this original value Arun, which is there at 101, will be replaced by this Moturi. Okay, you got my point, right? Duplicate keys are not allowed. Only one key is allowed. If you still try to insert the same key, then old value will be replaced by this new value. That is going to happen. So after duplicating this key here, if I try to print, you will see the difference. Okay, Arun will not be there. After duplicating the key, Arun will not be there. Instead, the new value Moturi will be there. You see, 101 was Arun earlier, but 101 is Moturi now. Okay, it got replaced. Old value got replaced. Fine. So that's how it works, guys. Okay, that's how it works. Next. So what if I print? Okay, if you are duplicating, the old value got replaced, right? Okay, old value is getting replaced, right? I want to get the replaced value. Okay, old replaced value I want to get. For that, what I will do here is, I'll remove this. I'll simply print out all these statements. Okay, that means I will say system.out.println. Instead of simply adding the objects, I will try to put that into this addition statement to the print statements. Okay, system.out.println again. This h dot put of Varun. So let me put it into the print statements. Another system.out.println. Let's put this into the print statement. System.out.println h dot put of duplicated value. This is okay. So guys, the first statement, am I adding any duplicate key? No, this is the first key and object key and value I'm adding. So there is no possibility of duplication. So if there is no duplication being done by this put statement, the return type of this put is null. Okay, null will be returned, guys. Okay, if you're not duplicating, null will be returned. But guys, that particular return null will be printed by this println statement now. Okay, here in the second statement 102 and Varun, it's a unique key. Still you will get the same null result because it's unique. Coming to 103, this is also unique. Again null. But coming to the fourth statement 101, already 101 is there. But you are adding the 101 again, duplicating the key now. So what will happen when you duplicate? First thing is that this will be duplicated. Okay, 101 will be duplicated. That's fine. No compiler error will come. But the old value object of this 101 key will be replaced by the new object value, that is Moturi. In place of Arun, Moturi will come. Same time, this method, okay, after replacing this Arun with Moturi, okay, will return, this particular method will return the old replaced value. That is Arun got replaced with Moturi, right? So this Arun will be returned by this put method. So here Arun will be printed in the output. You can see that. In case of duplication, the old replaced value will be printed. Okay, old replaced value will be printed. And when you print the entire map, now, okay, you'll get the Moturi only. Okay, the new value Moturi will be there. Old value Arun was there. In place of Arun, Motori got updated, but Arun got replaced by Motori. That Arun will be written by this put statement, put method when you are doing so. Okay. So when you print this put statement, put method, then you will get this old replacer value. Okay. In place of Arun, this Motori got. You can simply say that h dot put of, okay, got replaced. Okay. That means Arun got replaced. Arun got replaced. You can say that. Right click run as. You'll get the output like this. You see, Arun got replaced with Motori. Arun got replaced with Motori. So that thing you can do. Next thing here is next method, guys. Okay, let's go with the next method. So finally, that's okay. Simply we have to say h dot put of. Okay, if you go back, h dot put of 101 is equal to Arun. Okay, h dot put of 102 is equal to Varun. H dot put of 103 is equal to Tarun, like this, right? These are three key value objects I added using the HashMap. Fine. System.out.println, and when I print h, all these objects will be key value pairs will be printed in this way. That's fine. Fine. Now I want to retrieve this key value pairs. How to retrieve? So there is a method known as for retrieving. This for adding. For retrieving in map interface, there is a method known as get method. Okay. Get of key method is there. Okay. Let me show you. System.out.println h dot get of key. You have to provide the key. If I provide the key as 102, what will be the output, guys? H dot get of. Get will retrieve the value of this particular key that you provided here. That is 102 you have provided. Its associated value. Its corresponding or associated value is Varun. So here Varun should be retrieved. Similarly, if I say system.out.println h dot get of 101, what should be retrieved? Which value should be retrieved? 10 key has the associated value object as Arun. So Arun has to be retrieved and printed here. Okay. This will retrieve the value Arun and println will print it. So if you run this, you see Arun will be printed. Like this, you have to use the get. Fine. So what if I provided wrong key? Let's say instead of this 102 or 103, if I give 105, the key itself is not there, right? In the hash map, only 101, 102, 103, three keys are there. But if you are trying to retrieve the value of the key object which is not there, that is 105 object which is not there in this hash map, you'll get the null as the result, guys. Okay, null as the result. Either you'll get the associated value object, or you'll get the, if it is not there, then you'll get the null object. So right click run as Java application, you'll get the null object. Okay, this is another thing. Next thing is removing. Okay, so far we have retrieved and we have retrieved, right? So before removing, I will simply print the hash map. Okay, so if I print all the objects that are added, that is Arun, Varun, Tarun with the keys 101, 102, 103 will be printed now. Okay, let's run this. Before removing, okay, before removing, I'm printing. Okay, three objects, three key value pair objects, that is 101 Arun, 102 Varun, 103 Tarun got printed. Now what if I use the method known as remove method? Okay, h dot remove also belongs to this map interface, guys. Okay, inherited from the map interface. Hash map is inheriting this remove method from the hash map interface. So remove is another method. So h dot remove of, you have to provide the key again. Similar to get, you have to provide the key again. For example, if I provide the key as 101, what will happen, guys? Okay, remove the key of 101. This will get removed. Okay, in the object, in this hash map, there were three key value pair objects. One set, second set, third set, right? Entry, first entry, second entry, third entry are there. Okay. Now if you say h dot remove 101, so this particular entire entry will be removed. Okay. So now after removing, let's print it. After removing this entry using this key, let's print it. Let's print the same hash map. You will see only two entries will be available now. That is Varun entry and Tarun entry are there. But this 101 Arun entry got removed. Okay. This is how we have to use the remove method. Okay. We have to use the remove method. And it also has a return type, guys. Okay. Retrieves the, you see, h dot remove is returning you some object. Let's say I'll say r is equal to, okay, over the mouse and say create local variable. Okay. Now system.out.println simply say R. R is the object. R plus got removed. Okay. So what got removed, guys? That will be printed now. As you can see that. Okay. Right click, run as Java application. Arun got removed. Okay. So Arun got removed, got printed. So this value object is getting returned. Whatever the remove 101 means, it is removing the value object, that is Arun. So that remove method is returning you that object. Okay. This is how we can utilize if you want. Fine. Next thing. Next method is contains key method. Okay. Contains key method. How does it work? I'll remove all this stuff. So now we have three objects. So system.out.println h dot contains key of, if I say 102, is key 102 available here? True or false? Contains key will return boolean value, that is either true or false. If this 102 key is available in this hash map, it will return true. Since 102 is there, 102 is available in this hash map. As you can see here, 102 key is available in this hash map. We are going to get the result as true. So run this, right click, run as Java application. True is the result. What if I give some key object which is not there? Let's say 109. Is 109 available in this hash map? No. If I run this, I'll get the result as false. I'll get the result as false because 109 is not there. That's how we have to use contains key. Okay, contains key. Now another method is there similar to contains key, that is contains value. Okay, so if I say system.out.println, if I say h dot contains value, here we are going to pass value, guys, not key. If I give something like Tarun, okay, is Tarun value object available inside this hash map? Yes, it is there here. Okay, it will return boolean value true. Okay, run this, right click, run as Java application. True will be returned. What if I give some name like Motori? Is Motori value object available in this hash map? Arun is there, Varun is there, Tarun is there, but Motori is not there. So when I run this, you will get the result as false. False will be done. Okay, false will be coming. Next one. Next one here is empty. Is empty. Is empty method is also there in the collection interface, right? Similarly, it will work in the map interface also. Okay. Okay. Even map interface also has the same is empty method. So using which you can say whether the given map is or map or its child associated child class is empty or not. System.out.println, I will say h dot is empty. Is this hash map empty? No, it has some objects. It has some key value objects. So it's not empty. If it is not empty, what should be done? It should result false. Okay, false should be coming. Right click, run as Java application. Okay, false should be the result, guys. What if I comment all these things? What if I comment all these objects, key value objects? So in this case, is the hash map empty now? Yes, it's empty. Okay, true will be the result. Right click, run as Java application. You'll get the result as true. So this is how you have to work with the is empty method. Okay, which is similar to the collection interface also. Next one. What is next? Next one is size. If you want to find the size of this hash map, by looking at this, you can say what is the size of this hash map. 1, 2, 3. 3 is the size. So system.out.println h dot size. The result will be 3 key value pairs are added, guys. Okay, so it will be 3. Size of the hash map is 3. You'll get the result as 3. Next thing, clear method. Even size method is also there, guys. Okay, size method is there here in the collection. Also, we have the size method. Okay, there are some common methods between the map interface and collection interface. Coming to clear, okay, we also have some clear method in the collection interface also. There are some lot of common methods between map interface and collection interface, guys. Okay, clear method is also there. So, what is the purpose of the clear method, guys? Clear method will clear all these objects. Okay, before clearing, I will try to print the hash map. So, how many objects will be there? How many entries will be printed here? 3 entries. Okay. So right click, run as Java application. You see 3 entries, 1, 2, 3. Okay. Now I'll simply say h dot clear. And if I say system.out.println h, so all these objects, all these entries will be cleared by this clear method. Okay. After clearing, there will be nothing else. Empty hash map you will get. The output you'll get the empty hash map. You see, empty hash map is dead because clear method has cleared all the objects, wiped out all the objects. Next one. Fine. Next one is key set. Okay, we have a specific method for this map interface, that is key set. Okay, key set will retrieve all the keys. Here in this example, 101, 102, 103 are all the keys, right? I want to retrieve all the keys without object values, only key objects I want to retrieve. Okay, that is possible with the help of key set. So system.out.println, if I say h dot key set will retrieve all the keys, only 101, 102, 103 will be retrieved without object values. Okay, right click run as Java application. 101, 102, 103. Similarly, we can also retrieve all the values separately. Okay, all the value objects also we can retrieve. For that, there is a method known as values. Okay, values. So system.out.println h dot values. It will retrieve all the value objects from this hash map. Okay, only value objects. Right click run as Java application. Fine. Coming to previous one, that is key set. That is h dot key set. It will retrieve all the keys only, right? All the set of keys will be retrieved. 101, 102, 103 will be retrieved. The return type is set, guys. That's why the return type is set. Okay. From hash map, we are retrieving all the keys, and the return type of this key set is set. Over the mouse and say create local. This is set. You can get something like this. Okay. So key set. Set of keys will be coming. Set of keys will be coming. You know about the set, right? Set belongs to collections framework. Under collection interface, we have list set interface. Okay, this set has been returned. Okay, by that method. Fine. So next thing here is it returns a set. Key set will return the set of keys. Okay, it will retrieve all the keys from this hash map and return them in the form of a set of keys. Okay, it will come as a set of keys like this. Similarly, values will return what, guys? When you say values will not return set, guys. Okay, 1, 2, 3. All these three values will be returned in the form of collection. Collection will be the return type. C is equal to collection interface. Okay, create collection C. Where is the collection, guys? Where is the collection? Here, this is the collection. Okay, this method of the hash map is returning the values in the form of collection interface object. Okay, you can apply all the methods of this collection interface. Earlier methods, earlier also same thing, right? Set interface. Fine. Next one. Next one is insertion order is not preserved. Okay, it looks like the insertion order is preserved, right? If I say H is the insertion order preserved, guys, if I run this, right click run as Java application, it looks like first Arun has been inserted here, Arun is coming. Here Varun has been inserted here, Varun is coming. Here Tarun has been inserted, Tarun is coming. We thought like that, right? 101, 102, 103, 101, 102, 103. What if I put this here at the beginning? Okay, H dot put of 103 Tarun. If the insertion order is preserved, first 103 Tarun should come, then 101 Arun should come, 102 Varun should come, right? So if I run this, you will not get that output, guys. Okay, insertion order is not preserved. This is still 101 Arun, 102 Varun, 103 Tarun is coming. How this is happening, guys? Is the insertion order preserved? In case of hash map, insertion order is not preserved. Okay, but based on this hash algorithm, okay, based on the hash algorithm, which is applied on keys. Okay, we don't know what exactly the hash algorithm is there, how the hash algorithm works, and we don't have to worry about that. Okay, HashMap will take care of this hash algorithm. Okay, HashMap internally uses this hash algorithm and applies that on the keys. Whatever the keys you are providing, that hash algorithm will be applied on the keys, and then those objects will be key value objects will be inserted according to that hash algorithm. We don't know what exactly the hash algorithm, how exactly the hash algorithm will work. Okay, but you need to understand that HashMap internally uses hash algorithm for inserting the objects according to the keys. Okay, hash algorithm will be applied on the keys for inserting this kind of key value objects. Okay, so that's the reason whatever the insertion order is, that is not coming here. Okay, they are the objects, key value objects are inserted in the way of using the hash algorithm applied on the keys case. Okay, so you should know that. Next thing, Next thing is duplicate keys are not allowed and duplicate values are allowed. Okay, already explained what will happen when you try to duplicate a key, right? To try to duplicate a key, the older value object which is there with the same duplicated key will be replaced with the new value object that I already explained. But what if I don't duplicate the key, but I try to duplicate the object? That is, if I say h dot put of 104, key is a 104. I am not duplicating the key, guys, but I am trying to duplicate the value object. Will there be any problem? There will not be any problem, guys. Okay, all 4 key value pairs, that is 4 entries, will be recorded. That is stored into the hash map. Okay, because key is unique. Key is unique. It's HashMap doesn't bother about the values whether they are duplicate or unique. Okay, only keys should be unique. That's the only purpose of the HashMap. Okay, so right click run as Java application. You see 4 entries are there now: 101, 102, 103, 104. 101 also has the Arun object. 104 also has the Arun object. Okay, this Arun object has been differentiated by these keys. Okay, this first Arun value object has been differentiated by 101 key, and the second, this fourth or second occurrence of this Arun object has been differentiated by this 104 key object. Okay, like this. In HashMap, only the value objects can be duplicated, but not key objects. Okay, fine. Next thing, guys. Next thing. Okay, so far so good. Next thing is retrieving all the entries using entry set. Okay, there's one more method. Okay, there is one more method under the map, that is entry set. This is entry set. What actually it does? Okay, what actually the entry set does? Till now, we have either retrieved keys or retrieved values, right? But now, if you want to retrieve all the entries, how to do that? Okay, if you want to retrieve all the entries, then we have to use something known as entry set. Okay, entry set. System.out.println. Sorry, not system dot. Control Z. It's something. Control Shift O. Done. Okay. So I'll remove this. So if I say h dot entry set, system.out.println h dot entry set, what will happen, guys? All entries, okay, all entries, entry 1, entry 2, entry 3 will be returned by this entry set. Set of entries will be there. Okay, it will be returning the set of entries. You see, set of entries are there now. Okay, first entry, second entry, third entry inside a set. Here you see you are not getting the curly braces. For hash, if you are printing the hash map, you will get the same square brackets. No, you'll get the curly braces. Okay, so like this, the curly braces will be there. But here, as you are printing the entry set will retrieve all the key value pairs. That is entries. Entries will be retrieved. So entries inside a set of entries will be printed here. Okay, if you are printing the set of entries, it will be like this. Okay, so let's see the difference. Right click run as Java application. You see, this is hash map inside the curly braces. Entries inside the curly braces are there if you print the hash map. But if you print the entry set returned, okay, entry set returned entries, they will be printed in the set, because this entry set, the return type of this entry set is a set, guys. Okay, over the mouse you will know that set is the return type. Okay, over the mouse and say create. You see set. So simply I'm just printing the set, which is nothing but set of entries. One entry is 101 Arun. Second entry is 102 Arun. Third entry is 103 Arun. Okay, right click, run as Java application. You see, 3 entries are printed here in the form of set. Okay, so that is actually about the entry set. We can do more, guys. Okay, if you have this entries, okay, if you have this, there are 3 entries here: entry 1, entry 2, entry 3, and you are able to get that entries into the form of set like this. Okay, so here each and every entry is a object in the set. Okay, object in the set. Now I want to iterate through this set. Okay, you already know, right? For if you want to iterate through the set, which method you have to use? For set, if you have a set is a, let's go back here. Set is a child interface of the collection interface. Collection interface has a method known as iterator method, okay, which is inherited by this set interface. Using that method, we can iterate through the set, right? So if you go back, collection interface is there, okay. There is a method known as iterator method, okay. Iterator method belongs to which interface? Collection interface, okay. This iterator method, the return type of this iterator method is iterator interface, okay. The return type of this iterator method of this collection interface is iterator method, iterator interface, okay. It has this iterator interface, this iterator interface has its own specific methods, okay. They are, what are they, guys? Has next is one of the method of this iterator interface. Another method is next, okay. We can use this predefined methods of this iterator interface for iteration purpose, okay. Okay, so what I'm going to do here is, as set has already come, I will say s dot iterator, okay. I can use this iterator, I can call this iterator method using the object reference of the set, because set is the child interface of the collection interface, which has a method known as iterator method. So child interface can use this method. That's fine. S dot iterator. What is the return type of this iterator method, guys? Iterator interface. You'll see that. Hover the mouse on this iterator. Iterator interface is the return type. I'll simply say ITR is equal to, okay. ITR is equal to, ITR is equal to. So hover the mouse on this ITR and say create local variable. Iterator is the interface. Okay, fine. Now, what are the methods? What are the predefined methods of this iterator interface? Has next and next. I'm going to use this methods of this iterator interface with a while loop. That is while ITR dot has next. Okay, using the object reference of this iterator interface, I'm calling this as next, because as next and next belongs to the iterator interface. If ITR dot has next, I'll print here in the set. What are there, guys? What are there in the set? In the set, what are there? Set of entries. Entry 1, entry 2, entry 3 are there. Okay. So if you print it out, you will get that. System.out.println simply says, okay, simply says it will print the set of entries. First entry, second entry, third entry will be printed. You can see that. Right click, run as Java application. Before iterating, I'm just printing the entries, guys. 3 entries are there in the set. Okay. So using the iterator, we can iterate through these entries, right? So ITR will be provided with each and every entry once. Okay. ITR.next. So what will happen? I will tell you. So earlier the control will be there here, guys. Okay. So this is now let me move into the, sorry. This is first entry. This is second entry, and this is third entry, right? They are saved into the set now. They are saved into the set. Okay. Initially, the cursor will be there here, guys. Okay. When you say, when you don't do anything, the cursor will be there here. Once you say while ITR dot has next, okay, it will check whether there are any entries here or not. How many entries are there? 1, 2, 3 entries are there. That means this has next will return true. If it is true, we'll go inside the while loop. We'll go inside the while loop. Now I'll say ITR dot next. Okay. When I say ITR dot next, what will happen, guys? When I say ITR dot next, what will happen? This cursor will come to the first entry. This cursor will point to the first entry. Okay. First entry in the set will be pointed out. So that cursor, okay, is pointing to this particular entry. So there are few more methods, guys. Okay, let me explain. Map interface has other methods also. Get key, get value, get set value are there. I'm going to practically demonstrate these things now. After while iterating only, I will demonstrate this. Okay, get key, get value. So what is entry interface then? Map interface as another interface known as entry interface. This is a internal interface. Okay, inside this map interface, we have this entry interface. It is something like this, guys. Okay, for example, if you have interface map is there. Inside this interface, okay, there is another interface known as entry. Okay, like this. Okay. So map interface, inside the map interface, we have the entry interface. How to access this entry interface? In order to access this entry interface, you have to say map.entry. Okay, you cannot directly say entry, guys. Okay, because entry interface is inside the map interface. So you have to say map.entry. Okay, in order to name this, you have to say map.entry. Entry inside the map interface. Okay, if you want to use this map, you can directly say map. But coming to the entry, which is there inside the map, you have to say map.entry. Okay. So guys, when I say itr.next, okay, I want to on this particular, when I say itr.next, what will be retrieved, guys? The cursor will be pointing to this first entry. So here, entry 1, that is this 101 Arun will be there. Okay, entry 1 will be there. Okay, entry 1 will be there. But on this entry, I want to apply these methods. Get key, get value, set value methods I want to apply. Okay, how to apply this? Using the how can I apply this? How can I access these methods of this entry interface? Okay, I have to access this entry, right? In order to access this entry, I have to say what? Map.entry I have to say. I cannot directly say entry. I have to say map.entry. Okay, so for that I have to first typecast this. Okay, this will be in entry format. Some object format is there. I want to convert this object format into which format? Map.entry format, so that I can use, I'll simply say E, guys. E is equal to map.entry. Okay. Hover the mouse on this map and say import this map from the java.util package. Okay. Now hover the mouse on E and say create local variable. Entry. Okay. So either you can say map.entry or entry. Anything is fine here. Now using this E, I can call using this object reference of map.entry. I can call its methods, entry interface methods like get key, get value, get set value. Okay. I can call. So let's do that. System.out.println E dot get key. You see, I'm able to access. Okay, from the entry interface, I'm able to access the get key. This is the process, guys. Okay, system.out.println E dot get value. Okay, get value. So this itr.next has entry. Entry is nothing but a key value. In order to segregate this key and value from this entry, I have to use this method known as get key and get value. Okay, which is there in the map.entry. Entry is the child interface, not child interface, internal interface of this map interface. Outer interface is map, inside interface is entry. So in order to access that, we have to use map.entry. All these concepts are like clubbed together, guys. You will get the result. Okay, you have to understand each and everything. System.out.println. I just segregate this. Okay, so that every time this iterates, this separation will be printed. Okay, so let's do. So let's see. Let's iterate through this loop and see what will happen. Initially, when HashNext has been done, the cursor has come to this first entry set. Okay, E1, entry one has been there. Okay, that when you say itr.next, guys. Okay, initially when itr.hasNext, it said yes, there are 3 objects, 3 entries are there. So true. Then we went inside the while loop. Now itr.next will point to this first entry, and we are converting that into the map.entry type so that we can access get key, get value. Okay, so when this get key will, for the first entry, what is the get key? For the first entry, what is the get key? 101. So get key will print 101 here. After that, get value. What get value will print? Get value will print Arun. Okay, key object of the first entry and value object of the first entry will be printed. After that, separation line will be printed. Then again, control will come to the has next. Yeah, first entry is done. So how many objects are left? 2 entries are left. So again true. So itr.next cursor will come to this part, this portion. Now 102 Varun is there. Okay, this is the entry 2. itr.next will retrieve entry 2. Now entry 2 is the focus. When entry 2 is there, okay, when you call get key from entry 2, key will be retrieved. That is after 101, 102 will be retrieved, right? Then here Varun will be retrieved. Then separation line. Then again we'll go to the hash next. Any other objects are there? Yes, these two entries are done. Only one entry is left. So this will return true. itr.next will move the cursor from here to the last entry. that is last entry, E3, let's say. Okay. So again, get key will retrieve 103 key object from the entry, third entry, and Tarun object value from the third entry, and separation will be printed. Again, control will go to the hash next. All the three entries are done. Are there any other entries? No. This will become false. Okay, this will become false. So if you run this code, you'll get the same output, guys. Whatever I'm saying, you will get the same output. Right click, run as Java application. You see, originally this is a set of entries, right? Set of entries. We have iterated through this set. Initially, get key, get value, get key, get value, get key, get value. Okay, three entries separately printed. Okay, fine, like this. Same time, I want to do something. There's one more method also. This entry interface also has another method known as set value. What actually it does? It will replace this. Okay, so what it does is system if I will write something like this. If e dot get key, okay, if e dot get key dot equals, if e dot get key object equals, let's say 101. Okay, if it equals 101, okay, then e dot get key, if it is 101, here 101, 102, 103 will come during the iteration, right? If 101 is there, what I want to do is I want to set something, e dot set value, okay, value of that object to, let's say, Motori, okay, the key having 101, original value is Arun. I'm setting that to Motori, okay. Let's see whether, if I now after this while loop, okay, after this while loop, I'll simply print system.out.println HashMap. I'll simply print the HashMap. Here, set value will replace this Arun with Motori, guys. Okay, so Motori will be replaced. Arun will be replaced with Motori. If I run this code, right click, run as Java application. You see, 101 is called Motori is there. Earlier, 101 is called Arun was there. Now 101 is Motori is there. Using the set value, we can replace the objects also. Okay, according to the keys. Fine. So these are all the methods of the map interface and its internal interface known as entry interface, guys. We can use all these predefined methods with the child class, that is child class of this map interface, that is HashMap. Okay, not only this one, you can also use with the other maps also. Okay, other child classes also. Fine. Actually, I demonstrated all these things with the most popularly used map, that is HashMap. Okay, HashMap is most popularly used. That's why I practically demonstrate all these predefined methods of the map interface with the HashMap class. Okay, so guys, this is how we have to use. Okay, this is how we have to use all the predefined methods of the map interface and its internal interface known as entry interface. Okay, entry interface. Finally, we are left with only one topic. I'll clear all this stuff. Okay, simply we have this hash map and we have inserted three key value pair objects, right? System.out.println h. If I run this code, I'll get the output, right? I'll get the hash map printed. That's fine. But guys, there's a concept known as generics. Okay, that is, you're getting some warnings here. As you can see here, you're getting some warnings here. The reason here is you didn't provide the generics. You provide these generics like this. Okay, how many objects are there here? 2 objects. So you have to provide 2 classes inside this generics. That is, first thing is integer object. So you have to say integer, comma, second type of object that you are providing the key value pairs is string. So string you have to say. Okay, integer string. Here you don't have to provide, you simply say greater than, less than, greater than, that will be enough. Okay, so here first is integer, second is string. So you have to provide the generics like this for the hash map. Okay, I'm going to explain more about generics in the upcoming videos, guys. Okay, I'm just going to take a good number of sessions on the generics. So till then, this will be enough. Okay, and what if I change this to string? I'll get the compiler error, guys. Okay, I'm going to get the compiler error like this. So here, if you in the generics, if you provide string, here the key also should be string, guys. Then only it will be accepted. For example, if I change it to Motori, then it will be allowed. You see, compiler error has been gone because this is string, this is key is string type, and value is also string type. Okay, so again, if I change it to integer, again I'm going to get a compiler error in the only one step. That is because this is string object, but here I am saying integer object. I have to provide the integer object like this. What if I want to provide any type of objects? Object you can provide. Okay, either wrapper classes or string classes or object class you have to provide. Object means Either you can provide integer object, string object, boolean object, anything you can provide. Nothing will happen, guys. Okay, nothing will happen. Heterogeneous objects are allowed. Heterogeneous key value objects are allowed in the hash map. So you can put that as object also without any problem. Object means any type, any type. Okay, but you cannot provide int or float, something like that. You cannot provide, guys. Primitive data types are not allowed. Okay, only wrapper classes or other classes or object class. Okay, anything is fine as part of generics. Anyhow, I'm going to cover generics in detail in the upcoming videos where you'll understand more about this generics. Okay, for now this will be enough for your understanding. Fine, this is all about the hash map, guys. Hope you understood. I have explained the hash map in a detailed way because hash map is really very important and mostly used one as part of the maps. Hash map is mostly used, so better to know all these things with the help of hash map, guys. Okay, so that's it, guys. That's all about the hash map. In the next video session, I'm going to explain about the child class of this hash map. Hash map also has a child class, guys, that is LinkedHashMap. You can see here in the hierarchy collections framework. Under map interface, we have HashMap. If you expand this, you will get a LinkedHashMap. Okay, LinkedHashMap is the child class of the HashMap. This LinkedHashMap and how it is different from the HashMap, all those things I'm going to explain in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 234 of Java for Tester series, that is LinkedHashMap. So what is LinkedHashMap? LinkedHashMap. LinkedHashMap is a predefined class in Java. A predefined class in Java, and it is the child class of which class? HashMap class. Okay. In the previous video, I explained about HashMap is. Okay. And the child of this HashMap is nothing but LinkedHashMap, which belongs to collections framework. Okay, which belongs to collections framework. So what is LinkedHashMap? It is a child class of HashMap class in collections framework. Let me show you visually. This is the entire collections framework where we have the root interfaces like collection and map and other miscellaneous stuff. To expand this map, you will find this HashMap, okay, which is a child of this map interface. And you expand this, you'll find the LinkedHashMap, which is a child of this HashMap. Okay, so what is LinkedHashMap? LinkedHashMap is a child class of HashMap, which is a child of map interface, which belongs to collections framework. Okay, this is a hierarchy. This is a place where LinkedHashMap belongs to collections framework. So what exactly is LinkedHashMap then? Okay, this is all good, but what exactly is LinkedHashMap? In order to understand the LinkedHashMap better, we need to compare this LinkedHashMap with the HashMap, that is its parent. Okay, if we compare this LinkedHashMap with its parent HashMap, then you will understand how this LinkedHashMap is different. Okay, you'll understand this LinkedHashMap better when you compare this with the HashMap. So let me do it. Fine. So on the left side, I will say HashMap, okay, which is a class. And on the right side, I will say LinkedHashMap, okay, which is also a class. Which is also a class. And these both classes are the child or grandchild classes of the map interface. Okay, so they have the same properties. That is, they are meant for the same thing. That is, if you want to store a group of objects, okay, as key value pairs, right? I explained this in the previous videos, guys. Either map interface or HashMap class videos. That is the previous video. If you want to refer, you can refer where I explained. If you want to store the objects as key value pairs like this, okay, key value pairs, then you have to use something known as HashMap or LinkedHashMap or map. Okay, that's the main intention. Okay, group. The purpose is same, guys. But what's the exact difference between HashMap and LinkedHashMap? Difference here is insertion order is not preserved. Okay, as explained in the previous video, when I explained about HashMap, I explained that how insertion order is not preserved. Okay, the way, the order in which you are inserting the objects, the order in which you are inserting this key value pairs, okay, will not be the same as the storage, how the hash map is storing. Okay, the order in which the hash map is storing is not same as the order in which this key value pairs got inserted. Okay, that's why we say insertion order is not preserved. But coming to LinkedHashMap, insertion order is preserved. This is the only difference, guys. Remaining everything is same. Okay, if you compare this hash map with linked hash map, everything, total everything is same. Only the except difference is here insertion order is not preserved. The way you are, the order in which you are inserting the key value objects will not be the same as the way in which those key value objects are stored inside this hash map. Okay, but coming to linked hash map, here insertion order is preserved. Okay, insertion order is preserved. Okay, remaining everything is same. You can use all the predefined methods of the map interface with this linked hash map. The way I explained with the hash map and all the stuff, everything is same, except this is the only difference. If you understand this, linked hash map is done, guys. Okay, learn hash map and learn how this linked hash map is different. Then linked hash map is done. So here insertion order is preserved, whereas hash map insertion order is not preserved. Let me practically demonstrate. Okay, I'll show you first how the insertion order is not preserved in hash map and how it is preserved in linked hash map. Okay, fine. So system.out.println, sorry, not system.out.println. Let me create a object for the hash map. Okay, first I'm explaining hash map, guys. In order to understand linked hash map, you need to understand the hash map. Okay, so h is equal to new hash map. Fine. I'm just creating an object for the hash map. Hover the mouse, import it from the java.util package. Now using the object reference of the hash map, I'll simply say h dot put. Okay, I'm just inserting the objects. So first I will insert something like 103. Okay, 103. Inserting some another value object, that is Arun. Then h dot put of key value pairs, guys. This key object and value object. Okay, and here 101 Arun. H dot put of, okay, some 99, some 99. Sorry, this is not done. H dot put of some 99. Here I am saying some Varun, let's say. Okay, so three key value pair objects. System.out.println, if I say h, okay, in what order these objects, this key value objects will be inserted in the hash map. Okay, the order will be first Arun, then Tarun, then Varun, right? But how they will be stored in the hash map? They will be stored differently. Okay, insertion order is not preserved in case of hash map. Okay, so if I run this, right click run as Java application. Okay, here 103 Arun was there. Okay, if the order is same, here 103 Arun should come here, but here 99 Varun came. Then 101 Tarun came, then 103 Arun came. Okay, insertion order is same as the output, right? That means here insertion order is not preserved in case of hash map. What's happening here is hash map internally uses some hash algorithm and applies it on the key objects. Only keys, only this hash algorithm will be applied by the hash map on this key objects. Okay, and based on that algorithm, this order will be stored in the storage order will differ. Okay, here this order is nothing but hash algorithm applied order on the keys. Okay, based on the hash algorithm applied on the keys, this order has been defined by this hash map. Okay, we don't have to learn about the hash algorithm, guys. Okay, that's out of our reach. Fine. Now the next thing is coming to the linked hash map. Here insertion order is preserved. Simply I will change this to linked hash map. Okay, I'll change the normal hash map to linked hash map, which is a child class of the hash map class, right? Over the mouse, import this linked hash map from java.util. Again, do the same thing. Linked, L-I-N-K-E-D. Okay, spelling. Over the mouse. Okay, done. Fine. Now, insertion order should be preserved this time. Okay, because this is linked hash map. Insertion order is preserved. The way in which you are inserting, the order in which you are inserting this key value objects, the same order in which they will be stored inside this linked hash map. Okay, so right click run as Java application. You see, first 103 Arun, here also 103 Arun. Then 101 Tarun, 101 Tarun, 99 Varun, 99 Varun. Order is same. Okay, insertion order is preserved in this case of linked hash map. That's the only difference, guys. Remaining things, everything is same. Okay, both hash map and linked hash map are almost same except this difference. That is, here in hash map, insertion order is not preserved, and in linked hash map, insertion order is preserved. We have to use linked hash map in place of hash map when you need this insertion order. Okay, when we need this insertion order, we have to go with the linked hash map. If you don't need any insertion order, then you have to go with the hash map. Okay, so guys, this is all about the linked hash map. Okay, this is all about the linked hash map, and in the next video session I'll explain another child class of the map interface, that is identity HashMap. As you can see here in the collections framework, we have this identity HashMap, which is also a child class of this map interface. Okay, which I'm going to explain in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 235 of Java for Tester series, that is HashTable. So what is HashTable? HashTable is a predefined class in Java, and it is the child class of map interface. Which interface? Map interface, which belongs to collections framework. Okay, which belongs to the collections framework. So what is HashTable? It is a predefined class in Java, and it is a child class of map interface in collections framework. So let me show you visually. As you can see, this is a complete collections framework, which has the root interfaces as the collection and map and other category. If you expand this map interface, you will find this HashTable here. Okay. If you expand this map interface, you will find this HashTable. That means HashTable is one of the child classes of map interface. Map interface also has other child classes other than this HashTable. HashTable is one of them. Okay. HashTable is one of the child classes of map interface, which belongs to the collections framework. So let's find out. Let's understand more about this HashTable and how it is different from other things in collections framework. The first thing that you have to focus and carefully observe is HashTable. When I write HashTable, here T is small or capital. It's small, guys. Okay. If you take any other examples, I explained as so far as part of the collections framework. Let's say array list. Here L is capital or small? Capital. If I say linked list, here L is small or capital? Capital, right? If I take HashSet, this is capital. The second word, the first letter of the second word is always capital in all the cases. Okay, LinkedHashSet. Okay, even HashMap. In HashMap also M is capital. In LinkedHashMap. Okay, here H is capital, M is capital, like that. Okay, all the secondary or third ordered words are all starting with a capital letter. But only one predefined class in collections framework doesn't follow that kind of routine, guys. That is HashTable. You see here T is small, guys. Even though table is the second word in this class name, T is still small. You have to focus on this, guys. Okay, you have to focus on this. You should not be writing like this. This is wrong. Okay, this is not there. HashTable means T is small, guys. It's not capital T, will not work. Okay, you have to keep that in mind. That's one thing you need to know about the HashTable. Now, the other things are HashTable has any child classes or parent classes? Yes. Okay. So HashTable, let's say this is HashTable and its parent. HashTable is the child class and it has a parent abstract class, guys, that is dictionary. There's a parent abstract class known as dictionary. Okay. It is also a class, but abstract class. Abstract class in Java. This is normal class, this is abstract class. Okay. And also it also has a child class. Okay, HashTable also has a child class that is known as properties class. You can see that in the complete hierarchy also. If you go to this collections framework, if you expand this HashTable, properties is the child class of the HashTable. Okay, properties is the child class of the HashTable, and HashTable also has a parent class known as dictionary. It's an abstract class, guys, not a normal class. It's an abstract class. Okay, HashTable has a parent class known as abstract class known as dictionary, and is a child class known as properties. Same time, HashTable is the child of this map interface. Okay, HashTable also implements the interface and is also child class of this dictionary abstract class. Same time, it has a child class known as properties. This kind of hierarchy you need to understand, guys. Okay, so that you know the relationship between HashTable and different things in the collections framework. So far, so good then. Okay, next thing we need to understand is all these classes, that is HashTable, its parent class known as dictionary abstract class, and properties child class known as properties class, all are from the older version of Java. That is, they are legacy classes. Okay, These are not latest, guys. All these classes that I mentioned here in this hierarchy, that is dictionary, hash table, properties, are all legacy classes. They are from the older, okay, older generation classes. These are, okay. So people actually use HashMap. Okay, people actually use HashMap. They don't use HashTable because HashMap is latest when when compared to HashTable. HashTable is the older version of HashMap. Okay, older version of HashMap. So not only HashTable but also dictionary, but also properties. All are from the all are legacy classes, guys. They are from the older version. Okay, they're all from the older version, but they are still continuing in the collections framework. Okay, so now you understood what exactly these classes are, right? Legacy classes. They are older version classes. And now let's understand more about the hash table. You can understand more about the hash table by comparing that with the hash map. Okay, let's compare hash map. Hash map, it's also a class which is also under the map interface. And the other side, I'm comparing hash table. Okay, hash table is also a class, but it's a legacy class. Okay, as you can see here in the hierarchy, under map interface, we have hash map and hash table, which are the child classes of this map interface. Okay, but what are the differences? The main difference we have is a, okay, is a, this is synchronized. It has synchronized methods. It has synchronized methods. That means it is thread safe, guys. Simply you can say that it's thread safe. Thread safe. What does thread safe mean? Okay, that means the, okay, thread safe means if you create some object or anything, so from outside, okay, from outside, some threads will be accessing the resources of the hash table, right? From outside, the resources of the hash table need to be accessed by threads. So here only one thread is allowed at a time. Okay, it's single threaded, guys. Simply you can say thread safe or single threaded. Threaded. Okay, only one thread will access this resource of this hash table at a time. Okay, and multiple threads are not allowed in this case of hash table. It's the old one, right? It's a old class, legacy class, right? Hash table is a legacy class. Okay, legacy class where single threads are allowed to access the resources of the hash table. What is the drawback, guys, of single threads? Even though it is thread safe, it is slow, guys. Slow in performance. It's slow in performance, guys. Okay. But coming to hash map, it has unsynchronized methods. It is opposite to the hash table. It has unsynchronized. It is unsynchronized, guys. And it is multi-threaded. It's not thread safe, guys. It's multi-threaded. Okay. Multi-threaded. That means the resource of this hash map will be accessed by multiple threads at the same time. Concurrently, multiple threads will access the resources of the hash map. Okay. So what will happen when multiple threads will take care of this kind of access this kind of resources of the hash map? The performance will be high. Performance will be high in this case because it's multi-threaded and task will complete very fast. Okay, performance is high. But in case of hash table, it's an older legacy type. It's the latest case. Okay, hash map is latest. Okay, it belongs to the latest generations. Coming to the hash table, it's the older generation one. Okay, here single thread, here multiple thread. That's the only difference, guys. Nothing more. Okay, both HashMap and HashTable work in the same manner. Apart from this, there is no difference between the HashMap and HashTable. Okay, both are same. It is a legacy class which has only single thread and thread safe type and has synchronized methods. But coming to the HashMap, it's unsynchronized. It's multi-threaded and it's the latest one. And since it is multi-threaded, it's kind of speed in performance. Okay, fast in performance. Here, HashTable is slow in performance because of the single thread nature. Okay. These are all the differences you need to understand, guys. Apart from this, the functioning of the hash map and hash table are same. Okay, the functioning of the hash map and hash table are same. No difference. Okay, I'll show you. Let's create an object for hash table. Hash table t is equal to new hash table. Okay, it works similar to the hash map. For the mouse, import the hash table from java.util t.put key and object. Same key value pairs are there. Key value pair objects are there. Nothing more than that. 101. Here I will provide the value as some string, say Arun. T dot put of 102. I will say Varun. T dot put of 103. I will say Tarun, like this. Okay. Now system.out.println print the object reference of this hash table. That's it. It works similar, guys. Okay, there's no difference. You see, it got printed. Okay, insertion order is not preserved here also. Hash map also, insertion order is not preserved. In hash table also, insertion is not preserved. Same thing. Okay, no difference. Also, if you want to retrieve the values using the keys, what you have to do is system.out.println t dot get of key. Which key you want to give? Let's say you give the key as 102. Which value object will be retrieved? Associated with the key object, that is Varun. Varun will be printed here. The same thing. Okay, the same thing, guys. No difference. So right click, run as Java application. And all the other things, guys, not only this put to get, all the other methods will work with the hash table and similar to the hash map. Only thing is that it is a legacy class and whose performance is slow because it is single threaded and thread safe. Okay, thread safe and single threaded, because of that performance is slow. But hash map is kind of fast because it is multi-threaded and it is the latest one. Okay, so apart from that, you don't have to learn anything about the hash table, guys. Okay, hash table is similar to hash map. Only thing is it's older and is performance wise slow because of it is single threaded. Okay, fine. So that's all about the hash table, guys. In the next video session, I'll explain about the next class under this map interface hierarchy, that is properties class. As you can see here, we have the properties class. Okay, we have the properties class, which is the child class of the hash table. Okay, this thing I'm going to explain as part of the next video session. And also, I skipped this weak hash map and identity hash map, guys. Okay, I felt like we don't have to learn this. It's okay to learn it, but implementation wise, I felt like we generally don't implement anywhere this weak hash map and identity hash map to that extent. Okay, as part of the testers or beginners, these things have not to be learned. Okay, these things are not required to be learned. So I felt I skipped it. Okay, now properties will be properties class, which is a child class of the hash table, will be explained as part of the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 236 of Java for Tester series, that is properties class. So what is properties? Properties is a predefined class in Java. Properties is a predefined class in Java, and it is a child class of hash table class. Okay, which belongs to collections framework. So here hash table, I already explained this hash table in the previous video, guys. And this coming to the properties class, it is a child class of this hash table class. Let me show you visually where exactly this properties class falls into the collections framework. So this is a complete collections framework, guys. Under collections framework, we have a root interface known as map interface. If you expand that, it has some child classes and interfaces. As you can see, one of the child class of this map interface is the hash table class, and its child class is properties class. So properties class is the child class of the hash table class, which is a child class of this map interface, which belongs to the collections framework. Okay. So what exactly is the purpose of the properties class? What is the purpose of properties class? Where exactly we have to use the properties class? Why we need this properties class in Java programming? Okay, we need to understand that. For example, guys, if you are frequently updating some data, okay, if you are frequently updating some data, let's say there is some example data like username and password. Okay, if you are frequently updating this data, okay, updating this application data, in that case, guys, you should not be hard coding this data in the Java programs. In the Java programs, let's say this is a Java program. Okay, in the Java program, you should not be using this username and password. Okay, you should not be using this username and password. You should not hard code. I mean to say, you should not use hard coded data. Okay, why? Because tomorrow if this username and password will change, again you have to go to this source code and change it, right? Again you need to change the username and password here in this Java programs. Okay, if you are directly using the username and password in the Java programs, okay, and if tomorrow this username and password is changed for the application, then again you have to go to this Java program and update it manually. Okay, that is going to be a difficult process. Rather than that, you can separate this hard-coded data into a separate file known as, you can name this file as properties file. Okay, some file known as properties file. Okay, you can put this hard-coded data here. Okay, you can put this data here, which is frequently changing, and you can get rid of this hard-coded data inside the Java programs. If tomorrow this data gets changed, simply you can go to this properties file and update it, right? Rather than updating that manual inside this Java programs, okay, you can simply go to this properties file and update this username and password in this properties file. Okay, at a high level, guys, this is a high level picture. But guys, if I put the data, if I put this username and password inside this properties file, then how come my Java program will be able to access this data? Okay, for that, guys, okay, we have to access the data. The communication should be there, right? So from properties file to the Java programs and from Java programs to the properties file, there should be some communication. To facilitate such kind of thing, we need this properties class. Okay, what is the purpose of the properties class? To separate the hard-coded data into the separate text files like properties files, and later on for the Java programs to access the data from these properties files, or store the data into this properties file. For such kind of reasons, we need this properties class. Okay, by using this properties class, we can solve this. So let me practically show you so that you can understand more, guys. Okay, if I practically show you, you can understand more. Okay, properties also will look something similar to the key value, guys. Okay, they also look like key value pairs only. Why? Because, for example, username is there, username, and you have to give some value, right? Let's say Arun is a username. Okay, this is key and this is value, and here let's say password is there, and let's say 1234 is a password, like this. Okay, so here key and value, such kind of thing also applies for this properties class. Okay, because we are going to have the property name here, instead of key we'll call that as property name. Okay, property name, and this side we have the property value. Okay, so if you compare these properties with the hash map or any other things like under the map, you will say key and value, right? The same thing, same structure is that, but the names are different. Here you call this as property names, and this you call this as property values. Okay, so using this properties class, we can facilitate such kind of requirement where we can store the data in the terms of property names and values inside these properties files, and the Java programs, okay, Java programs will access these properties names and values from this property file, and at the same time it can store back also. Okay, there are good number of methods with the properties class which will facilitate such kind of thing. Okay, fine, let's move into the practical mode now so that you can understand all these concepts in a better way. So how to use the properties class? So you have to create an object, guys. Okay, properties p is equal to new properties, like this. You have to create an object for the properties class, then only you can use it. Over the mouse and import. Okay, so before actually the properties is there, let's say there is no properties. Okay, now let's say you have written some Java sample Java program here. Let's say string username is equal to Arun. Okay, I'm hard coding it. Simply what I'm doing, I'm hard coding the data in the Java program. String password, okay, is equal to 1234. Let's say, okay, 1234. Now I'll write this program. Okay, system.out.println login to the application. Just dummy code, guys. Okay, it's not real code. Log into the application using username, username plus username and username and password plus password. Okay, like this. Okay. So if I run this program, this may be a very simple program, guys. Okay. This is a very simple program. Log into the application using username Arun and password 1234. Okay. Username Arun and password 1234. This may be very simple program. In real time, the program will be very complex. Tomorrow, this data changes. This hard-coded data like Arun 1234. Tomorrow, instead of Arun, we have to give Varun. So what I have to do, guys? I have to come to this program and manually change this hard-coded data to Varun. Then only this application logic of logging into the application will work, right? Otherwise, it will not work. This is a very simple program. In real time, we'll have complex program, and it will be very difficult for you to come into the, go through the source code and change this kind of hard-coded values. Rather, if you create a properties file like this, okay, right click on the project and select new file option. Okay, give any name here, guys. Let's say details. You can give any name for this file. Okay, details dot extension should be properties like this. Okay, dot properties and click on finish. You see properties got created. Here instead of hard coding these things inside this Java program, I'm trying to move them into the properties file. How? I'll give the property name as this is the property name, guys. You see instead of key value pairs, we have property name and property value. Okay. So here property name is username is equal to value is Arun. Simply provide something like this, guys. Username is equal to Arun. Password is equal to 1234 like this. Okay. And this is string and this is string, guys. Internally, this will be treated as string only. Okay. So we'll come to know about that. Now you don't have to hard code here, guys. Okay. You don't have to hard code here like this. Okay. You just remove it. So I'm just segregating this. I'll just comment it out, guys, for a while. Okay. I'll comment it out for a while so that you'll know the purpose later. Okay. Fine. Now the thing is, all this hard-coded data like Arun and 1234 has been moved to the properties file like this. Now, guys, we have two things. Let me move it to the side so that you can see the properties file at the same time you can see the source code, right? Fine. Now we have the properties file where the frequently changing data is residing in the form of property name and property value. Property name and property value. Property name and property value. Like this, we can have good number of properties also. Okay, property names and values we can have. Now, guys, since I have separated this hard-coded data into the properties file, now I need to have something in Java programs where using which I can access this data. Whenever I want, I have to access this data, right? Such kind of program I need to have. To facilitate such kind of thing, we have a class known as properties class. Using this, we can do that. So let's get started. Properties. Let's create an object for the properties. Not to use that. Properties. New is equal to properties p is equal to new properties. Then so it's already imported, guys, java.util. If not, you can import it. Okay, over the mouse and select to import properties class from the java.util package. So once you have imported it, once you have created an object for the properties file, you need to load this file. You need to load this file, guys. For this, there are several. This properties class has its own specific methods like this. Okay, load, get property, property name, store, set property and store. This kind of methods are there, predefined methods of this properties. Using this, we have to load this file. Okay, in order to access this property names and values from this properties file, what I have to do, guys? I have to load this properties file. Then only I can access this properties from this properties file. So there is a method known as load method, using which I can load this properties file into the Java program. So this is the first step. P dot load. Okay, just select this input stream thing. So here I have to provide the input stream, guys. Okay, load of input stream I have to provide. So for input stream, we have something known as file input stream. This is a predefined class of Java, guys. Okay, I will explain more about this file input stream and all those things in the upcoming videos where I am where I will explain about file handling and all those stuff. Okay. File input stream FIS is equal to new file input stream, like this. Okay. Just create an object for the file input stream, because this load method requires you to provide this object of this file input stream. That's why I create an object for the file input stream. Okay. Don't think much behind that, guys. Okay. Simply hover the mouse on this file input stream and select file input stream of from java.io package. Okay. The error will be gone. And here I need to pass the path of this properties file into this file input stream. I have to provide the path of this properties file. So directly this particular details.properties is directly under the project. So I can directly provide the path as details.properties. Okay. Directly I can provide like this. Details.properties. Done. Now this file input stream object I will provide inside this load. That's it. Okay. Hover the mouse and select add throws declaration for now. Don't handle it. Let's make things simple. So I just added throws. Okay. Fine. P.load of FIS. What will happen, guys? Now using this load method, we have loaded this particular details.properties file into this Java program. Okay. The first step is done, guys. After loading, what I can do? After loading, what I can do, guys? There are other methods, guys. Okay. You can get the properties. Okay. That means using the property names, we can retrieve the property values. So let's say system.out.println p dot get the property is another method. Okay. You have to provide key here. Key means this property name. For example, if I provide the property name as username, what will be the output, guys? What will be the output? Using this username property name, the value that is Arun will be retrieved. Using which method? Get property method. Okay. And that retrieved property value will be printed by this println statement. Similarly, system.out.println p dot get property, same method. Okay. And here key, instead of username, I will give the password. Okay. Password. So one more thing, guys. These are like strings only. Okay. Username is a string and Arun is a string. Password is a string. It looks like number, but it is also a string, guys. Okay. So password, you have to put inside the double quotes and then you will get the password as 1234. Okay. 1234. You see, the return type is string only. It's not number, it's string. Okay. Fine. So if I run this program, I already loaded it. Okay. First method I did is I use this loading. Okay. We have to load this properties file into this Java program so that I can access. Without loading, I cannot access, guys. Okay. Without this load.fis, I cannot use this get property. This will not get property will not work, because without loading this properties file, how can you access this particular things properties from the properties file? Okay. First thing is that you have to load the properties file. Here we have loaded the properties file. Okay. In which we have the required properties. Next thing is we are retrieving the values. Okay. Property values using property names. Okay. We are retrieving the property values using the property names. Here we are providing the property names so that we can get the associated property values. Let's run this code, guys. Right click, run as Java application. You see, we got the values. Okay. When you have given the property name as username, we got the output as Arun. When we given the property name as password, we got the output as 1234. So we can simplify this. Okay. So we have commented out some program right here. String username is equal to Arun and string password is equal to 1234 and all those stuff. Okay. So what I'm going to do is I'm going to add this thing. Okay. Username is called, instead of hard coding here. Okay. Instead of hard coding here, what I'm going to do here is username is equal to p dot get property. That's it. Okay. I'm not hard coding here. Get property using the property name will get this value, username value, and pass it to the username. This is the purpose, guys. This is the purpose. Now, second thing is instead of directly hard coding the password like 1234 like this, we'll say p dot get property of password. That's it. This program will now work, guys. Okay. This program will now work. Just remove this comment. You see earlier how it used to work. The same thing, same way it will work. Log into the application using username Arun and password 1234. It's working. It's working, guys. Okay. So this is the purpose, guys. Next, we have few more methods with the properties, guys. That is, there is a method known as property names. Okay. So what I will do is I will remove all this stuff, guys. Okay, this is fine. After loading the properties file, I'll apply this property names. What actually it does? Okay, it will retrieve all the property names. How many property names are there? 1 and 2. Username is there, password is there. I want to retrieve them. Okay, so for that, I'll use a method known as p dot property names. This is the method property names. The return type of this property names is enumeration. Okay, so e is equal to, I'll say e is equal to, over the mouse on this e and select create local enumeration. Remove this question mark and all those stuff. Okay, now this enumeration, as I already explained in one of the previous videos, this enumeration e object has its own predefined methods. Okay, this enumeration is an interface, guys. If you go here into the collections framework, under other section, we have them some cursors, guys. Okay, some cursors are there. Out of them, we have this enumeration interface. Okay, this enumeration interface has its own predefined methods. What are they? There are two predefined methods. As more, we'll find it out. Okay, so we can simply write the logic and I'll tell you what are the methods. While e dot has more elements. Okay, this is one method. One method is has more elements. Okay, using the object of this enumeration interface, we can access this method. And next one is next element. Next element is another method. Okay, so if you are retrieving all the property names, how many came? Username is there, password is there. Has more next. Yes, two properties are there. So we'll go inside the while loop. System.out.println e dot next next element I will say. Next element will print the first element first. That is, first it will print username. Okay, property name is username, right? We are retrieving only the property names here. Okay, and using the object of this enumerations to retrieve them, username. Then the next iteration has more next. Yes, one more property is left. So again true. So next element is password. Password will be printed. So once this two property names got printed, again has more next will be verified. And are there any other properties left other than this username and password? No. So it will false. It will be false. It will result in false and it will come out of the while loop. Okay. Now let's run this program to see whether this property names is retrieving all these property names. And using this object of this enumeration, we are able to retrieve the values of property names or not. Okay. Right click run as Java application. You see both username and password, which are the property names, got retrieved using this mechanism. Next one, guys. That is, we are done with the load, get property, we are done, property names we are done. Now set property. Okay, set property. So let's remove this. After loading, I want to set a property. Okay, that means p dot set property. I'll give the key as username. Okay, user name. I have to put that in double quotes, guys. Username, I have to put that in double quotes. Username, and the value. What is the current value? Arun. But I want to change it to, sorry. I want to change this value to, instead of Arun, I want to change it to Varun. Okay. So that is the purpose, guys. What's the purpose of the set property? So before changing, I'll print system.out.println p. Okay. So I'll comment it out. So if I print directly this property, what will happen? All the properties will be printed, guys. Okay. So before I explain you about the set property, if I print this properties, you'll see the output. Right click run as Java application. All the properties will be printed like this. Username Arun is one property set and another one is password is equal 1234. But guys, after printing them, I am trying to set the property. Okay, I am trying to set the property. That is, I want to change something. Set property is used for changing the value of the given properties. I want to change the property value of this property name known as username. Okay, to from Arun to Varun I want to change. So after that I will print p. Okay, after that I will print p. So here earlier when I printed username is equal to Arun, password is equal to 1234 got printed. But when I run now, okay, Arun should be replaced with the Varun. Okay, Arun username is equal to Varun should be there instead of username is equal to Arun. Okay, right click run as Java application. You see, earlier username is equal to Arun, password is equal to 1234. Now username is equal to Varun, password is equal to 1234. Okay, here Varun got replaced. But guys, there is one class here, that is, did the property value change it in the properties file? Let's close this and open and see whether that it got reflected or not. You see still Arun is there. What is the problem then? Why it is still Arun? It has to be changed to Varun, right? By why the value is still Arun? Because I have used a set property. There is a class, guys. The class here is we have to use the store. Okay, we have loaded using load method. But we have, if you want this Java program to make changes to this properties file, after this kind of operations, you have to do, okay, you have to store it back. Okay, you have to use the store method to store these changes into the properties file. Otherwise, the changes will not happen to the properties file, guys. Temporarily, they will be displayed in the programs. Okay, but really, in the properties file, did the value change it? No, still Arun is there because this temporary change happened in the programmatical way. Up to Java program only it is applicable. The set property is only working up to the Java program, but it's not getting updated into the, okay, this change is not getting updated into the properties file. For doing so, we need the store method. Okay, how to use that? Let me explain. So here what I'm going to do here is, after this change, I'm going to use a store method, p.store. I have to say p.store, and we here output stream is required, guys. Okay, similar to file input stream, we have file output stream, guys. Okay, we have to use that method class, file output stream. FOS, okay, FOS is equal to new file output stream. Which file? I need to output the same details.properties file. Okay, I'll provide the same thing here and put a semicolon here. Now this FOS, I'll put it here. P.store of which file I have to store this change. I need to update this change into which file? This same details.properties file. Via file output stream, I have to do it because the store method is asking you to provide the file output stream object. So I have to create this and provide the path of this properties file here, and then pass this object reference of file output stream here. And here you can even provide comments, guys. Okay, so updated Arun to Varun, something like that. Okay, so p.store, that's it, guys. So now if I run this code, okay, if I run this code, what will happen? It will not only update in the Java program, but also this set property value, which is changing from Arun to Varun, will be updated in the properties file also. You'll see that in action. Okay, this is the last method, guys, of the properties file. Let's run this code and see whether that is getting reflected in the properties file or not. From the Java program to the properties file, Java application, it got updated in the program. Now you see, either you can refresh also. Okay, when you refresh and just try to open so that you can see the changes getting reflected. Earlier this Arun didn't get updated to the Varun. Now it got updated, and also the comment we have given here, updated Arun to Varun, is getting displayed here. Okay, along with the timestamp and all those stuff. So this is the thing, guys. This is how we have to work with the properties class and its predefined methods like load. Load is for loading the properties from the properties file to the Java program. What about store? Store is opposite, guys. For storing the updated things to the properties file. Okay, for storing the updated properties to the properties file. So load will come this side, store will go this side. Okay, that's the first thing. Get property will retrieve the property values based on the given property names. Property names will retrieve all the property names that are available in the properties. Okay, so these are all the things, guys. These are all the things. If you understand all these things, that will be done. Okay, that will be fine, guys. That will be enough. Okay, you don't have to do much. I practically demonstrated all the property class specific methods for you, and that's all about the properties class, guys. Okay, that's all about the properties class. Wherever you get a need where you don't want to hard code the frequently changing data inside the programs, then you can simply shift those hard coded data in the form of property names and property values into this properties file, and then implement this properties class, okay, and its predefined methods, so that you can load the data and to the programs and from the properties files, and update the data from the programs to the properties files, and you can do all the other retrieval and other operations. Okay, it's all about the properties class, guys. Hope you understood it. So that's it about the properties class, guys, and we are left with one more. Okay, the last concept of the collections framework I want to cover, that is how to convert the arrays into the list. Okay, how to convert the arrays into the list. Remaining everything I covered, guys. Okay, so far I covered everything about the collections framework as part of this video series. Only this part is left. Let me show you what I covered and all. So I'm not going to cover few things, guys. Okay, so that is I'm not going to cover the sorted map, navigable map, and tree map. These are not required. Okay, you can ignore them. So after skipping all these things, I just move to other part. Enumeration is covered in this properties. In this current video also enumeration is covered, right? So iterator is covered in one of the previous videos. List iterator is also covered, okay, as part of the previous videos. Comparable, comparator, all these things are covered, okay. Coming to utility classes, collections is also covered. For sorting purpose we can use as part of one of the previous videos. Now only arrays is left, okay. Remaining all are done, guys. If you come from the beginning, I covered list interface and its child classes. All these 4 child classes I covered. These 2 are important, guys. Array list and linked list are fine. You don't have to worry about vector stack, but still I covered vector and stack. Okay. Then coming to set, I covered HashSet, LinkedHashSet, SortedSet, NavigableSet, and TreeSet. All these are good, important, and really needed. So you have to learn everything. Okay. Coming to queue, you don't require queue. So as a tester, you don't require any queue concepts. As a beginner also, it's not required for you to learn queue. So even I skipped the queue. Coming to the map interface, okay, I covered map, hash map, linked hash map. That will be good. But coming to weak hash map and identity hash map, I felt like these are not required. Okay, so I just didn't cover them. Okay, so coming to the other thing, hash table. Even this is not required, but still I just wanted to cover because it's very simple. So I covered it up, and its child class is really required for us. In the current video only I covered this properties class, that is this properties class where you have to segregate the hard-coded data into the separate file and then access here and there. So I covered it in the current video session. And dictionary you don't require, it's outdated. Okay. So anyhow, dictionary also very similar to the hash map. Okay. You don't have to think what use it actually. Okay. If hash map is there, you don't need hash table and dictionary, guys. Okay. Hash map will take care of everything. But still these things are not required. Only properties will be good, guys. Okay, properties out of this legacy classes will be enough. Coming to sorted map, navigable map, tree map, it's like very big complex things, guys, and you don't actually require them. As part of testers or beginners, you don't have to implement such kind of things, so that's fine. Next thing is, we are done with all these things, and next thing is other. As part of while explaining all this collection interface and map interface, child classes and interfaces, I almost covered all these things. Okay, they are inbuiltly covered as part of explanation of this collection interface and map interface, classes and interfaces. Okay, enumeration was covered, iterator was covered, list iterator was covered, comparable, comparator both got covered. Okay, and finally utility classes, even collections also got covered as part of one of these sessions. And finally I'm left with one more topic, that is arrays, guys. Okay, arrays have to cover this. Okay, with this we'll complete the collections framework. Okay, whatever the collections framework knowledge that we require as a tester, that will be done with the help of this last concept known as arrays concept. Okay, let me explain this about this arrays class. It's a predefined class, guys. Arrays is a predefined class. Okay, it's not the normal arrays which I taught you in the previous sessions. Okay, it's the arrays class. It's a predefined class. Okay, which I will be covering in the next video session, guys. Using that arrays class, that too as part of collections framework, what we can do is we can convert the normal arrays into the list. Okay, normal arrays into the list we can convert. That particular small thing that I'm going to show in the next video session. So that's it, guys. See you in the next video session where I'll explain you how to convert the arrays into the list interface. Okay, list interface object. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 237 of Java for Tester series, that is converting arrays to list. So guys, can we convert arrays to list? Can we convert the arrays to list? Is it possible? Yes, guys, it's possible. So using what we can convert the arrays to the list? Let's take an example, guys. For example, we have a string array. Okay, let's take an example like we have a string array like this. S is equal to, and this is the array. Okay, so here I will say Arun, Varun, Tarun. Okay, these are the string objects we have, which are stored into this string array. Now I want to convert this string array into the list. Using what I have to convert, guys? Using what I have to convert? So in order to convert this kind of arrays into the list, there is a predefined class known as arrays. Okay, in Java, there is a predefined class. This is a class case. Okay, there's a predefined class known as arrays, and it has a predefined method known as a list method. Okay, for this purpose of converting this array into the list. Okay, into the list, we have to use this method known as list method. Okay, it's a as list method, which is a predefined method which belongs to the arrays. So arrays belongs to the collections framework, guys. Okay, arrays predefined class belongs to the collections framework. Let me show you visually. So let's go to this entire collections framework where we have this collection interface, map interface, and other section is there. Just open this other section. We have already covered the cursor sortings, and now let's go to the utility classes. As you can see here, arrays. Arrays is one of the utility classes, okay, which belongs to the collections framework. And this arrays predefined class has a predefined method known as a list, using which we can convert this arrays to the list. Okay, how to convert the arrays to the list? Using the predefined method known as list of this arrays predefined class, we can do that. Okay, we can do that. Let me practically show you how we can do this. It's very simple, guys. It doesn't take much time. So first, let's create an array. As I mentioned, string s is equal to, I'll store some array objects into the array like this. Better to provide either string class or wrapper class or object class, guys. Okay, don't provide primitive data types here. With primitive data types, you cannot convert, guys. Okay, you have to provide either string class or integer wrapper class or double wrapper class, whatever it is. It should be wrapper classes. Only classes should be there here. It should not be like this. Okay, it should not be like this. Instead, we have to provide integer. In case of integers, we have to provide like this. Since it is string, I'm just providing the string. String is a class, so not a problem. So Arun, Varun, comma, Tarun. Okay, like this. We have this integer. We have this string array. Okay, we have this string array. Now I want to convert this string array into what, guys? List. I want to convert this string array into what? I want to convert the string array into this object of this list. How to do that? For that, I will say there's a predefined class known as arrays. Dot I have to say arrays dot as list. Okay, arrays dot as list. Let's go to the Java 8 API. Java 8 API. Go here and search for arrays. Okay, just search for arrays here. Control F, arrays. Okay, arrays is a predefined class in Java, and it has some predefined methods known as list. What type of method it is? It is static method. That's why I can directly call this method as list with the help of the class name arrays dot as list, because this method is static type. Okay, that's why, guys, I'm saying arrays dot as list. In this, I have to provide the array that you want to convert into the list. Okay, for the mouse on this as list, as you can see, the return type is list, guys. So here I will say L is equal to, okay, L is equal to, for the mouse on this L and select create local variable. You see, list of string. Now we have converted this, we have converted the array, string array into the list, Let's print this out. Let's print this out. System.out.println L. I'm just printing this list. Okay. So let's see what will be the output. The output will be like this. Okay. It's a list. At same time, we can apply some list specific methods. Okay. So for example, if you go to this list, there are different methods, right? Add and all the stuff. Let's use something like get index. Okay. For retrieving the string objects from this list. So how to do that? System.out.println L dot get of 1. Okay, which value will be coming, guys? Let's see. So 0, 1, 2. Varun should be printed. Right click, run as Java application. You see, Varun got printed. Like this, guys, you can convert an array to a list. Okay, using a predefined method known as list, which belongs to the arrays class, which belongs to the collections framework. So guys, this is a very simple program on how to convert the arrays to list. We may be requiring this kind of programs in our automation frameworks or anywhere. Okay, so that's the reason I explained this session, guys. Okay, so that's it, guys. We are done with the collections frameworks. Okay, collections framework we are done with. Okay, we are not left with any other things. So all the required things have been covered as part of the collections framework. So the next thing here is reflection API. Okay, I'll explain about this reflection API. This is mostly used in the keyword driven frameworks. So that's the reason I'm going to cover this reflection API in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 238 of Java for Tester series, that is reflection API. Reflection API. Before I start explaining about this reflection API, let's find out whether this reflection API is part of collections framework or not. Is reflection API part of collections framework? What's the answer? The answer is no, guys. Reflection API is not part of collections framework. Okay. Reflection API is a separate topic. Okay, which doesn't belong to the collections frameworks in Java. Okay, it is a separate API concept which is not related to the collections framework. So guys, that's fine. It's not part of the collections framework, but what is the purpose? Okay, what is the purpose? What is the purpose of reflection API then? Okay, if reflection API is not part of collections framework, then what is the purpose of the reflection API? The purpose is to The purpose of the reflection API is to call the methods using the string text. Okay. By using the string text, we can call the methods when the string text and method name matches. Okay, this is a concept. So when the string text and method name have the same name, okay, when the method name is having the same name as this particular string text, then using this reflection API, we can make this string text call this method. String text can call this method. Okay, we can use the string text to call the method when the string text and the method name are matching. Okay, when the method name and string text are matching, we can use the string text to call this method, but not directly, guys. This is not possible directly. Okay, with the help of what this particular string text can call this method when they are matching in names, with the help of reflection API. Okay. Okay, with the help of reflection API, we can use the string text to call this method. When this particular method name and string text are matching, then only we can use reflection API to make the string text call this method. Okay, fine. That's fine. But what exactly is reflection API? Okay, we now understood the purpose of the reflection API. We now understood the purpose of the reflection API, which makes this particular string text call this method when the string text name is matching with the method name. But guys, what exactly is this reflection API consist of? Reflection API contains a predefined class known as method class. In Java, there is a predefined class as method. Okay, there's a predefined class with the name method, which belongs to the reflection API. This particular method class again has a predefined method known as invoke method. Okay, invoke method. This invoke method belongs to which class? Method class. This both belongs to reflection API in Java. Okay. With the help of this predefined class and its predefined method known as invoke method, okay, we can make this particular string text call this method when the string text is matching with the method name. Okay, then only it is possible. Okay, and this reflection API consists of this method class and its invoke method, using which this entire concept of reflection API is possible. Okay, so let's move into a bit practical, not fully practical. Let me show something here. So let's say I have a method known as public static void main. That's void method A. Let's say, what's the method name, guys? What's the method name? Method name is method A, right? This is the method name. And at the same time, we have something like string, some str is equal to some method A. Okay, string str is equal to method A we have. Can you say, guys, can you say what exactly is matching here? What exactly is matching here? Can you compare these two things? That is string text. This is the first thing is a string text. Okay, string text is string str is equal to method A. And second thing is a method, that is public static void method A. Here, what is matching in these two things? What is the common thing? The common thing here is this string text is having something like method A, which is matching with the name of the method known as method A. Okay, in such kind of cases, when the string text is matching with the method name, then using the string text, we can call this method, but not directly, guys. We need something known as reflection API. With the help of reflection API, using the string text, we can call this method name when the string text name is matching with the method name. Okay, this reflection API has method class and invoke method, using which this process is possible. Now let's move into the practical mode. More of the theory is done, guys. Okay, more of the theory is done. Now let's make this kind of concept practical. So let's move to my Eclipse IDE, where I'm going to create a new class. I'm going to name this class as Lion class. You can name it anything, guys. I remember Lion now, so I'm just creating it as Lion. Okay. Now inside this class, I'm going to create a main method, public static void main, string of args. And we have this main method inside this Lion class. Along with the main method, I'm going to have another method known as public static void some method A. Okay, some method A. So inside this method, whenever this particular method having the name as method A is called, I want to print out something. That is inside method A. When method A is called, this statement known as inside method A should be printed into the output. Okay, it should be printed into the output. Now guys, inside the main method, let's say I have a string text. String str is equal to method A. Now things are getting more practical, guys. Okay, whatever I explained theoretical here, okay, is going to be more practical here. So string text, and this is a method name. Is there anything common between this string text and this method name? Yes. The string text is method A and the name of the method is also method A. That means both are matching. Now using this string text, I can call this method, but not directly. Okay, but not directly. What I have to use? I have to use something known as reflection API, which has this method class and invoke method. Before I go there, in order to call, in order to invoke this method using the string text, with the help of the string text, I need to invoke this method. I can call it directly, guys. I don't want to do like this. This is not what I want. Okay, method A, I don't want. Okay, this method A anyhow will call this method itself, but here the case is different, guys. I have to use the string text only to call this method. That is string text is stored where? str. Using this str, I have to call this method. How to do that? Can I say str? Is this possible? No, this is not possible, guys. Okay, I cannot use this str to call this method, even though method A is common. Here, in place of this, I have to write down 2 lines of code. Okay, here I need to write down 2 lines of code, which actually uses this reflection API. I'll explain that. Fine. The first step here is to retrieve the method. Okay, then the second step is to call the method. So first, let me show you how to retrieve the method. How to retrieve the method? For retrieving the method, you don't need any reflection API. This reflection API is not required for this retrieving the method, guys. Okay, I first want to retrieve this particular method into this main method. Okay, but for that, reflection API is not required. This particular first step, reflection API is not required at all. Okay, so what I'm going to use is a method known as get method. Okay, get method is a predefined method in Java. Okay, how can you access this method? Let me show you how to do that. So what is the name of the class? Lion. Inside the lion class, we have two methods, main method and method A. If you want to retrieve this method A, okay, this method A is inside the lion class. So you have to write down something like this, lion dot class, lion dot class. Lion dot class is the class in which this particular method A is available. Inside this lion dot class, okay, inside this lion dot class, I want to retrieve this method A. So for that, in order to retrieve the methods, what is the method we have to use? Get method. So I have to say lion dot class dot get method. Okay. So inside the class, if you want to retrieve any method, then you have to use this line, guys. Okay, it's not related to reflection API. This statement is not related to reflection API. Okay, this is a normal statement. If you want to retrieve any method inside a class, you have to say lion dot class, that is class name dot class dot get method. Get method is a method in Java which will retrieve the whatever the method that you want from whatever the class you want. Here I want to retrieve this method from which class? Lion class. So lion dot class dot get method I will say. Okay. Here which method I want to retrieve? The method having the name as the string text. So I'll simply pass str here. Okay. Lion dot class dot inside the lion class, which method I want to retrieve? I want to retrieve the method which is having the name as the method A. So this one. Okay. So I have to pass str, which is holding the method A itself because this text is matching with the method name. Now, guys, does this particular method has any parameters? There are no parameters for this method. So this part is optional. You don't have to provide any parameters. This is enough, guys. Okay, this is enough. Lion.class.get method will retrieve this method. Whatever the method you want from the class, that can be retrieved using this get method. So there is some error coming. That's fine. Hover the mouse and say add throws. Okay, in real time, you have to say try catch, but for now, I'm just ignoring the error by saying add throws declaration. Okay, the error has been gone. This particular get method has to retrieve the method known as method A, right? So what will be the return type of this method? Get method. Return type of this method is method class. Method class belongs to which API? Method class belongs to, okay, which API? Reflection API, guys. Okay. So hover the mouse. You see method class is being written. I will simply say m is equal to. Okay. Hover the mouse and select create local variable. So immediately when this particular method class has been added, you see java.language.reflect.method. So this method class belongs to which API? Reflection API. Okay. So this part is not belonging to reflection API, but this method class belongs to the reflection API. Okay. Whatever the method, whatever the return type of this get method is there, that is actually belong to the reflection API. Okay. Fine. So far so good. Now, how to call the method? Second statement is now using this statement, using this get method, I was able to retrieve this particular method and store into this object reference of the method class, which belongs to the reflection API. Now the second step is how to call this method. First step, retrieve the method is done. I retrieve the method and stored into the yum. Now how to call this method, which is stored into this yum of the method class. So for that, the method class in Java is having a predefined method known as invoke method. You can see here, guys. If I go to Java 8 API, and if I find this method class, Control F, find this method class, guys. Find this method class. You see, this is a method class. Method is a predefined class in Java. It has some predefined methods. This method class has some predefined methods known as, a lot of methods are there. And this one, invoke is one of the predefined methods. Okay. So what is the purpose of invoke method of this predefined class known as method class, which both belong to the reflection API? The purpose is to call the methods. Okay. So simply, how to call this method? How to call this invoke method? Using this class. Okay. We have to create an object for this method class, then we can call this invoke. But here, anyhow, we have the object of this method class, right? Using this object reference, that is yum dot, I can simply call the invoke method. Invoke. Sorry. Yum dot invoke. Okay. Yum dot invoke. Yum dot invoke of this particular method I have to invoke. So that particular method is already retrieved and stored into this object reference. Simply again copy this yum and put into this object. Okay. And this part is optional, guys. This particular method doesn't have any parameters, so you don't have to pass anything. Apart from the method, you don't have to pass anything. You have to simply say yum.invoke of yum over the mouse and say add throws declaration. Fine. So yum dot, in order to call this invoke method of this method class, we have to use the object reference. So I have to say yum.invoke. And this invoke method has to call which method? Which method? Whatever the method that is retrieved by this get method, that's nothing but yum. So yum. Okay. What is the method that got retrieved? The method which is having the string text name as method A got retrieved. str is method A. Whatever the method that is having this method name that is provided by this str, that method will be retrieved and stored into yum. When you say yum.invoke, that method will be invoked. That method will be called. So using the string text, okay, the method is retrieved and that particular method is called using the invoke method. Okay. So right click, run as Java application. You see inside method A got called. Okay, method A got called successfully. Now what if I create another method like this? Public static void method B. Okay, system.out.println inside method B. If I write something like this, so instead of method A, I want to call method B, guys. How this is possible? Simply change the string text from method A, just change this to method B. What will happen, guys? Now str has this method B. So this statement will be executed. That is loin.class.get method of str is now method B. So get method of method B. Which method will be retrieved? Method B will be retrieved. This particular method will be retrieved and stored into the object reference of the method class. And when you say yum.invoke of yum, which method will be invoked? Which method will be called? Method B will be called, because this string text is there. That particular text which is matching with the name of the which method, that particular method only will be called. Okay. So run this. Right click, run as Java application inside method B. Again, if I change this method B to method A, this method will be called. If I change it to method B, this method will be called. Okay, like that it is flexible now. Okay. Now, third thing is, so far these methods doesn't have any parameters. Method A doesn't have any parameters. Method B doesn't have any parameters. What if I have a method which has some parameter? Public static void. Let me take two parameters. Okay. Method C. I'm just writing method C. Two parameters are like this: integer A, integer B. Okay. So this one more condition here, guys. Okay, the condition here is when you are working with the reflection API, okay, for invoking the methods or retrieving the methods, whatever it is, this method parameters should not be primitive data types. Okay, I cannot provide int here. I should not be providing int here. This will not work, guys. If I provide int here, this is not going to work, guys. This concept of the reflection API is not going to work. Okay, this concept is not going to work. This has to be the wrapper classes only. Instead of int primitive data type, you have to provide the wrapper classes. Then only this concept will work. If not, it will not work. Either it should be wrapper classes or any class name, but it cannot be the primitive data types. Okay, just understand that. Now I just provided integer. That's fine. So when this particular method C is called, I want to do something like I want to just print down the sum of this A and B. What are the parameters are there? I just want to sum it out. That's it. Okay. The result of this parameter sum has to be printed when this particular method is called. Now, guys, so far using this code, I was able to call this methods which doesn't have any parameters. But now I want to call this method C, which is having two parameters. So here I have to, first of all, I have to change the text from method B to method C, right? When I change the string text to method C, which method has to be called? Method C has to be called. That's one thing. But this particular method has two parameters. So what I have to do? Lion.class.get method of str is there. Okay. Now since this particular method has, the method has to be retrieved. This method C has to be retrieved by this get method. But this particular method has parameters. So I have to provide the parameters also here, parameter types here. That is first of all, the method having the str text, that is string text, that is method C. This is matching. Then which is the method which is having the parameters as first parameters of which type? Integer type. Just copy paste here. Then simply say dot class. Okay, this is compulsory. Comma, another parameter is there. The second parameter is also integer. So integer dot class you have to say. Okay, this is done. This part will work. Now this get method will retrieve the method having the name as method C with the parameters as integer and int. Two parameters are integer. So this particular method will be retrieved and stored into the yum of this method class. Okay. When you say yum.invoke, which method will be invoked, guys? This method will be invoked. But guys, are you passing any arguments? A has to be passed with some value and B has to be passed with some value. And from where you are calling this method, invoke method is calling that. So this invoke method itself has to pass the arguments to this particular method C. Okay, M is nothing but method C now, but it has two parameters. So I have to pass the arguments. That is, let's say 3, 6 if I pass. M dot invoke of 3. M dot invoke of M means method C. Having the parameters as this 3 will go into the variable A, 6 will go into the variable B when called. Okay, and when printed, system.out.a plus B, 3 plus 6, that is 9 will be printed in the output. So let's run this. Right click run as Java application. You see, you will get the result as 9. That means this method C got invoked. These are the changes, guys, you have to do for calling the methods which are having the parameters. Okay, fine. So this is all about the reflection API and how you can use it practically. But guys, why I have to explain all this reflection API for you? Okay, what is the need for the string text to call these methods? Where exactly is this useful? Okay, so the reason for me to explain this kind of concept is simply there's something known as keyword driven framework. Okay, in Selenium automation, we have different frameworks. One of the frameworks we have is a keyword driven framework. So as part of the keyword driven framework, what actually happens is you'll be having an Excel file. There will be some Excel file like this. Okay, just assume that this is Excel file, guys. Okay, this is an Excel file having the lot of rows and columns. Okay, just assume that these are the different rows and columns, and this is Excel file. Okay, and let's say this Excel file has some keywords: login, logout. Some sample keywords are there. Okay, inside this Excel file, there are some keywords like login, logout, register, and so on. There may be any good number of keywords inside this Excel file. These are nothing but keywords. Okay, there are keywords in the Excel file. And on the other side, we have some Java program. Where we have some methods like public static void login method. There's a method known as login method. Similarly, we have another method, logout method. Similarly, we have another method, register method. Okay, is there any match between these keywords and these methods? In the Java programs, we have this login method. Name of the method is login. Same time in Excel file, we have the keyword name as login, which is matching, right? So there are two things that we have to do, guys, here. Okay, that means this Excel file, we have to first read the keywords from the Excel file. Okay, we have to read the keywords, these different keywords from the Excel file, and convert them into something known as string. String S1 is equal to, by reading this first keyword and converting that into the string text. Okay, this is the first step. And the logout has to be stored into another string text, that is a string S2 is equal to logout. Okay, second keyword has been converted into the string text. Conversion of these keywords into the string text, that is the first step. Reading is a step 1. Okay, string S3 is equal to the last keyword we have in this Excel file as part of this example is register. So register, that's fine. Now we have 3 string text, right? By reading this different keywords from the Excel file, we created 3 string text. Now using this string text, can we call these methods? Using this string text, can we call these methods? Yes, we can do that. With the help of what, guys? This login can call this login method. This logout can call this logout method. This register string text can call this register method. But how? Can we do it directly? No, with the help of all this concept is based on that, right? Using the string text, if you have to call these methods, okay, we have to use something known as reflection API. Right? The same thing applies here also, guys. Okay, here we need something known as reflection API. Okay, if the string text is matching the method names, using this reflection API, we can we can make this string text to call this appropriate methods. This part is fine. This part is clear, right? This portion of the keyword driven framework is clear, where string text are calling the methods having the same name using the reflection API. This part is clear for you. On the other side, we need to convert these different keywords into the string. How to do that? How to read from the Excel file and convert into the string? For that, we need some other logic, some other program. Okay, some other program we need. It's not reflection API, guys. Okay, some other program, which I will be explaining as part of the keyword driven framework. When I explain about the keyword driven frameworks, I will be explaining what exactly this program is, using which we can go into the Excel file, read from the Excel file these keywords and convert them into the string text. Okay, this part is not part of the reflection API. This just you can ignore it for this session, guys. Okay, you can ignore what is the exact program for reading from the Excel file. You can ignore. But on the other side, after these keywords have been converted into string text, using the string text we can call this appropriate methods having the same names using the which API? Using the API known as reflection API. Okay, using the reflection API we can do that. Okay, so that's the reason, guys, I have to explain about the reflection API, which actually calls the methods using the string text if the method name is matching with the string text. That's all about the reflection API, and its actual purpose is in the keyword driven framework. The keyword driven framework we are going to use. So this is all about the reflection API, guys. Okay, this is all about the reflection API. And in the next video session, I'm going to take up the next topic of Java, that is generics. Okay, I'm going to explain generics in detail from the next video onwards. So that's it, guys. See you in the next video session. Thank you. Bye.